trying to start. We will probably be fine in time, but yeah. So now we do need the stream to start. Has that started? Then also good morning to the stream in case you can see and hear me. We may get slides at some point. Thank you. So welcome to the second edition of the workshop on programming local first software. After last year's success, we decided to do this workshop again, and where last year we kind of had a good program with, I believe, 6 time slots. This time we accepted 7 plus 6 half slots, which means you get 10 slots total, but we accepted an overall of 13 contributions, which means you get a wide variety of contributions from all kinds of people. So the workshop always was focused on bringing together academia and industry. This was one of our initial goals, where we were like, well, you know, we do a lot of academic research, but in industry they never hear about that, and in industry they do a lot of super interesting stuff we'd like to hear more about. So this was the initial motivation of the workshop. We nailed this goal very well again this year. We added kind of 2 new things that I think worked out very well, in the sense that our contributions cover both like experience reports over a long history, but also new ideas, algorithmic techniques, things that get very technical. And also we have submissions from very senior and very junior people, which is amazing. I think bringing communities together is what I'd really like to see at this workshop, and what we managed. And I mean, I say we managed this, but really it was the submissions of the speakers that made this possible. So thank you very much for all of the great submissions. And by the way, if you're in industry and would like to help with kind of this collaborative spirit, we are also hiring at our research group. So that was my 2 minutes. But this workshop is not just about the speakers, right? It's also about the participants, about all of us, which in practically means that every talk slot has about 50% of the slot is reserved for discussion. And discussion doesn't just mean that you ask questions to the speakers. I would also ask the speakers to maybe ask questions to the audience, and also you may discuss with each other if there's an interesting topic going on. So it should also not be the speaker that has to like keep this going. And one small kind of recommendation for that is I'd like to ask you to maybe for each talk just at least write down one idea or one question that you think is like a key topic, something that stuck out to you, something that you find important or interesting. And if you don't have an idea where to start, I'd recommend going with the core topics of the workshop, which is how does this help with programming, right? Why is what was presented just now something that makes these hard challenges, these problems where no one knows a real answer, easier to tackle, easier to work with? Or these annoying challenges, right, where everyone knows it's bad, but we really want to improve it, go away. And if you don't know how the talk helped in that sense, if you're unclear, maybe write it down as a question. Same for the local first aspect, right? Why is the talk related to local first, right? Why is this, I work locally, I always have my work available, but still can collaborate with second parties, right? Why is that something that's central to this idea? If you're not quite sure, maybe write it down as a question. And if you think like, I don't quite know what my understanding of local first is, let's discuss this. Yeah. And with that, I think we're ready to start the second edition of the Programming Local First workshop. Brooklyn, would you come on the stage and explain us everything about local first in many more words and wonderful examples?
All right. Wow. Thank you, everyone, for showing up early today, and to the organizers for having me. I'm super thrilled to be here. I'm actually really excited for the entire program. I was, going after the schedule was posted, started going through them, and lots of stuff I'm really excited about, and hopefully that I can also tee up during this talk as well. So I'm going to be talking about Feeling the Local First Elephant, a roadmap, hidden gems, and new puzzles from the field. And when I suggested the talk title, I didn't realize how old this phrase was to, this parable of the blind monks and the elephant, I guess was the original version. I'd always heard it as a bunch of scientists in a dark room, but the original version is, you have 6 blind monks, and the king asks them if they can figure out what an elephant is, and they all try feeling different parts of the elephant, and one feels the trunk and says, it's like a snake, and the other one feels the leg, and it's a little bit like a tree. And none of them can quite agree, but they all have part of the picture. None of them is wrong, right? They just don't have all of reality. To talk to you a little bit about the part of the elephant that I see, my name is Brooklyn Zelenka. You can find me on the internet as Expeed. And I'm the co-founder and CTO at a company called Vision Codes, where we've been doing local first and local first-like things for just under 5 years now. Where we started doing, we didn't have the term local first or lo-fi at the time, but lo-fi secure and user-owned apps directly in the browser, including on mobile. These days, and especially in the last couple of months, we're now much more focused on edge and local first computing in particular. Programming languages and distributed systems are my jam, so I think I may be in the right place today. And I had so much to say, in fact, that my original version of this talk was 179 slides, so I had to cut that back a little bit. Also, despite having, CTO and co-founder, all this stuff, most of the time I feel like a dog driving a car, but in kind of a great way, because I get to go out and range ahead and figure out how do these things actually plug together, and how do we take these ideas and try to actually apply them. And even though it's still just trying to figure out the edges of where these things happen, you get to learn a lot along the way. And as in this comic here, we should write down the things that we discover. We should communicate. I'm so thrilled that we're doing these kind of conferences between academe and industry. So my goals today, are threefold. One, taking stock, kind of give you sort of a state of a union for local first. Looking back, an experience report. So again, this is from my personal experience. Your mileage may vary. You may have had different experiences, and that's totally fine. In fact, I would love to dig in with people throughout today and anybody who comes to the conference tomorrow about the different things that they've seen. And I'm going to spend less time today talking about internals of CRDTs and more about the rest of the picture, right? It's, we'll just do local for software, draw the rest of the owl. I want to talk about the rest of the owl. And because of that, I'm going to be mainly looking forward, pointing at problems and solutions for this next chapter, and we'll talk about why I think there's a next chapter in local first. Now, the other thing to be wary of with the, this elephant metaphor, there's another version of this story that is 6 blind elephants and a monk. And the elephants decide that they want to discover what a monk is like, so they get one. And the first one goes and explores and goes and just squishes them. And says, monks are flat, squishy things. And the next elephant goes, yes, I agree. I agree this is a flat monk. It's really easy for us to come up with a single narrative, even though it's just one narrative, right? And flatten it and have that be the only thing that we talk about. I want to see a diversity of narratives and differences in how we think about the problems, especially so early in the evolution of local first. So let's not flatten our monks completely. Something seems to have changed in the last 6-8 months or so. Even this time last year, talking to people about local first, I would have to give them a full definition. And now it's the opposite. People are coming up to me and saying, have you heard about this local first thing? Like, that's an amazing development, right? A few signs of this have been, there was this lovely article in Wired earlier this year, and a couple of weeks ago, a few of us ran a unconference next exchange loop. And we were trying to keep it small, maybe 40 people, and then 200 people signed up. And so we extended that to what the venue would allow, 88. But these are lagging indicators. These show that there's a lot of interest, and it's really grown, and there seems to have been this sudden inflection point that's happened. And when I look around online, I see lots of apps and lots of tools that are claiming to be local first. That's amazing, right? This is now a selling point on the front page of websites, right? This isn't something that you have to define for people and point them at an article anymore. Arguably, local first and local first-like things have been around for a little bit now, right? Apple Notes, Figma, Jupyter Notebooks all have local first features in them. They just don't call themselves big, banner local first software. And my co-founder Boris often says, if Apple open sourced their stack, we wouldn't have to exist, right? We're trying to get to the same things that these large companies have the ability to do, but bring them into everybody's capability. So it's very early days, which means that it's exciting times in both senses. There is a lot of low-hanging fruit. Frameworks are just emerging, so there's no lo-fi lamp yet, right? There's no clear stack that everybody uses that's interoperable. And in many ways, though, again, we wouldn't have framed it this way at the time, Fission started to do a lo-fi lamp, right? Turns out that there's a big gap between here and there, which means that it's still today very manual. It takes a lot of investment to do lo-fi in production. And there's very little handholding, which again, super exciting. The people in this room, we get to go and explore and figure out new things. For people that are trying to take this stuff and put it in production, they have to be a particular kind of character. So it's been said the medium is the message. Also, the medium is the medium, right? So when we had desktop computers, that constrained things in a particular way. All your software was on a single machine. You could move it around on floppy disks. You knew everything that had been loaded onto your computer. Nobody could take it away from you, right? Now we basically rent software in the cloud. In the cloud era, we get a bunch more capabilities from having small computers in our pockets that are always connected, or maybe not always, but the assumption is always connected. And we can do, really great video chats, and Zoom got us through the pandemic, but it also has its own constraints. I don't know what lives on my machine anymore. I don't have full control over it. And now with Local First, we have new constraints, new ways of working, new things that people want to do with it, but it also constrains us in different ways. What are the new degrees of freedom that we're given, but also the new constraints? Historically, and I think probably mainly because we've all had the OSI model shoved at us so much, when I talk to developers, they think of the internet as being the source of truth, and then our local machine being a cache for the internet. So we're going to take some part of the internet, slice it off, and put it on our machine. With local first software, you have to change that model for them fundamentally, which is, on one hand, simpler, right? It's more cellular. It's more this, individual nodes talking to each other. But because it's different, it takes a bit of, it's a change of mindset. It's a different way for them to have to think about things. And so there's a bit of education that's still involved, even though people understand the term and what it gets them. But they're looking at maybe different parts of this elephant as well. They're really interested in, say, collaborative text editing and not, data portability, let's say. I think all of these things can get us towards what's been called previously disorderly programming. I don't know about you, but I don't often get to fully specify my program in advance and know all the services it's ever going to talk to, and then generate my program, right? Ideally from specification. It's messier than that. I need to collaborate with other people. I need to try different things and pull them together. And having that be spread across the entire internet and many different services, and some of those services go down or they change their, literally yesterday I was uploading my slides and they say, oh, you've hit your slide limit. I'm like, you didn't have a slide limit before, right? Why is that a thing? Why do I have to change tools now? I should be able to just disorderly interact with my services and with other people. I was talked out of adding this to a previous presentation, and I actually regretted it because then the rest of the day I ended up talking about this basic idea. Crossing the chasm, it's a bit passé now, right? It's been around since literally the 60s, this idea. And basically you have different market segments and different personalities that go along with them. And the book, famous book, Crossing the Chasm, is about this large one in the middle, but we're not quite there yet, right? We're at that little one in the corner, the smaller chasm, between innovators and early adopters. Innovators, people in this room, have a particular personality type. We like working with things that aren't quite finished yet. And as soon as we get them working, we drop them and move on to the next thing, right? And so you need to cross this chasm to early adopters, right? Who are kind of the cool kids, right? They're gonna go out and find the interesting new ideas and take them and popularize them. But it requires a mind shift, right? The things that they care about aren't necessarily the things that we care about. And so we need to find a way of aligning those so that they can take the things that we're building and go and grow the community even more. A different way of expressing this, basically the same idea, comes from Simon Wardley, who was the COO at Canonical, where he developed this, this other way of viewing this. So essentially on your vertical axis, you have how visible something is, so from totally invisible to very salient at the top, and then how mature a technology is along the x-axis. And things tend to follow this trend. They start out relatively salient, and then they, over time, get hidden and become, dull as dishwater. And that is what success looks like, right? Success is becoming invisible. It's becoming electricity, right? We don't think about the magic invisible force in our walls that, has the lights go and makes, the slide possible, but it goes into a utility. And over time, the value that accrues has this S-shaped curve, where it takes a really long time to get going, and then you hit this inflection point, and then it levels back off again as things become a utility. And this is both, it works in both ways. As you grow, more people become interested in the problem because they can now make money on it, right? But you also have to have something where you can develop in such a way, right? Where you don't just let it die, down there in custom software, where it can become industrialized over time. Then, when things become utility, they enable the next round, right? So you can build on top of this again. Arguably, the cloud is part of what's allowed us to do local first software, right? It's not anti-cloud. It's in spite of the cloud in the article, but it's building on top of these primitives that we've been able to test through cloud software and finding those problems, sure, right? But also being able to say, well, I need to sync. There's plentiful storage now, and I can load as dumb storage all of my local first data right there, and it's available for me to do that really easily. So we're taking this random walk through the solution space, and things are pretty good right now, but it's just gradient descent, right? We're probably going to have to find areas that feel rougher, that are really great for innovators, hopefully we don't end up in this pit of despair too much, but sometimes we have to go through them to find these higher peaks, to find, hopefully this really high peak. And in order to do that, we have to go and explore in a bunch of different areas, right? If we're all going in one direction, we're probably not gonna be able to find as much. So what even is local first? I would argue that it's three things these days, right? Convenience, idealism, and a movement, right? Something that came up a number of times, and from separate people, which was interesting at the Local First conference, was this idea that desktop computing was personal, cloud computing was impersonal, and local first programming is interpersonal, which I've always associated with Next, Steve Jobs' company between Apple and Apple. Something that inside Fission we've always called postmodern programming, where you can reinterpret data and recombine things sort of at will. But I think it really captures the mindset that a lot of people are coming into local first with. It's this interpersonal, interactive, even though all of my software runs totally locally, it is about this collaborative aspect. Which makes it not surprising that it shows up in the 7 ideals, right? We have seamless collaboration with your colleagues right in the middle, which I think in this list is an absolute slam dunk, right? There's no question that people in the community have found value with the seamless collaboration idea. These 4 are, I would say, very important. People still really care about no spinners in particular, right? And your work isn't trapped on one device, and the network is optional, right? Security and privacy by default, I think there's still a little bit of work to be done, but people agree with this idea, right? They don't want to be locked in, Facebook, and Facebook can mine all of their data, whatever the thing is. These 2 are what get me out of bed in the morning, the long now, and retain ultimate ownership and control over your data, but they are further out there, right? So these are more in the category, when at least we're talking to people about adopting local first, in the category of eating your vegetables, right? Things that you should do, but that are the first things that they look to cut when they're making difficult decisions. And that kills me inside a little bit, right? So I think there needs to be a lot more work done on these specific aspects. It's not totally clear how you'll retain ultimate ownership and control when people are trying to build businesses that try to lock you in, right? On the far other side, I think some of these things are absolutely inevitable, right? No spinners because of latency. Bandwidth keeps growing. Bandwidth is actually pretty good. Latency is a physical limit, right? Mark Miller has this great quote that New York isn't getting any closer to Tokyo, right? And despite all of our devices getting faster and more performant, the latency barrier will increasingly dominate applications going forward. Not only is it, in the Local First article, there's all of the latencies between these data centers, I believe it's Amazon's data centers. There's also almost like a social justice or even market-based side of this as well. So this is all of AWS's data centers worldwide. And you'll notice that there's a conspicuous lack of them in these fully uninhabited regions that have quite a few people in them, right? That just aren't valuable enough, right? That don't bring enough money to put an entire data center there. I used to work with a guy out of Nigeria, right? Why can't he have a data center nearby? Why can't he be the data center, right? For him and his family, right? Local for Software provides a real benefit to him. He doesn't have to make the round trip to, in an ideal case, I guess it would be down in Cape Town, right? But realistically, it's going to be US East 2, chances are, right? So even for the people that are online, right, that are innovating in these parts of the world, local first software provides them a real benefit. This helps us get us out of the cloud tar pit, where we're trying to pull together all of these, different APIs and working in their, particular framings of problems, right? Learning AWS is a skill unto itself. It's its own thing. But local first and things like CRDTs get us out of the muck, right? It lets us code beyond, without regard to time and space. Anything can get merged together, and so we can just get back to the stuff that we actually care about doing, right? Putting cat pictures on the internet. A major part of, at least where Fission started, and that gets me so excited about local first, is that we can federate data and not apps. So instead of having, slicing with apps that each contain your data, we can slice the data this way and then overlay apps on top of it, right? and share across many of these different applications. And this sounds radical, but this is how your laptop works. You have a file system, and you load data into apps. It's when we moved into iOS and Android, right, the mobile era, or in browsers, where you don't have that much storage, and until recently you actually really couldn't store in the browser, that this seems like a radical concept. Leslie Lamport has this great quote, slightly tongue-in-cheek, about a distributed system as one where failure of a computer you didn't even know existed can render your own computer unusable. And a few weeks ago, Martin said, well, by this definition, lo-fi isn't a distributed system, which actually ends up being a really great litmus test. I think this is better than at least what I was using previously, which was going into the actual properties for it. So actually to do that and to give an example, and still I would say that this question of what is local first is still open, right? Instead of the CAP theorem, I tend to use this extension pacalc, right? So it says under partition, you have to choose between availability and consistency. Otherwise, so in the case where you're not under partition, consistency or latency, right? So it recognizes that even when you don't have a partition, latency is a thing that you can choose. And a lot of things that we think of as local first are PAEL systems, right? So AutoMerge, ElectroSQL, UCAN, which is a auth system I work on, these are all PAEL. And so that I don't call anybody out, I've redacted this particular project, but it's essentially an operational transform. And the source of truth not under partition. So under partition, source of truth is local. When you're not under partition, it's in a data center somewhere, right? This is the failure of a computer you didn't even know existed, right? If that node goes Byzantine and starts imposing different data, it can start breaking my application, potentially, right? We would have to then say, well, I'm going to break this, say that I'm under partition, and just work totally locally, right? But there is something here where I think we're going to keep seeing this, because there's an incentive to put things in the cloud. So while we're talking about just, classic distributed systems things, the fallacies of distributed computing, local first actually solves a bunch of these sort of out of the box, right? Or at least recognizes that they exist, right? Sort of front and center, right? The network is reliable. It's not. By default, we're totally local, right? Topology doesn't change. It's changing all the time. And in fact, we can decide who's in our topology or not, right? We can pull somebody out of our application and remove their rights and see, a different version of our document. Latency is 0. Well, it definitely is when you're working totally locally, right? It doesn't solve all of them. It doesn't solve all of them, right? For example, the network is secure, I think is still an assumption in local first, right? And we'll talk about a few of these as we continue in the talk. There are also some new local first fallacies, or at least things that I see people talking about it this way, right? Fallacy 1, everybody's online, right? Even though it's local first, you assume that the person that you want to pull from, that their data is available right now, and that they're there to manually press a button. Manual pull is safe at all, that you can trust where that's coming from. Local first doesn't suffer Tesler's law. So Tesler's law is that there's a minimum amount of complexity in a system, and at that point you have to then move it around. You can't actually reduce it any further. So it ends up inside of a library, and it's the library maintainer's problem, or it ends up in the application, it's the user's problem. You have to move it somewhere. All programs are weakly consistent, right? So there's a subset of problems that are weakly consistent, but not all of them are. Encryption at rest is secure forever. This one, I had to learn the hard way, basically. So even with at-rest encryption, where you have the keys and they're not held anywhere else, all encryption is breakable, right? presumably quantum computers will become a thing, and all the standard crypto that we use right now will become broken. And if somebody's downloaded your entire data store, they will get into it, right? So you need defense in depth. And last one is lo-fi can avoid capture. We'll talk about this near the end of the talk, but historically, all systems in telecommunications have had this period of expansion and opening up, and then slow capture. And so the question is, how do we push that off as long as possible and make it so that even when that does happen, we've locked parts of the system open? Oh yeah, there's Larry. Yeah. So from the field, a little bit of my experience from the last, again, not quite 5 years of lo-fi. This is barely modified an exact slide that we gave in 2019 in a pitch deck. So you have users and you have developers, and there's this giant gulf of things in between them, right? So you have the browser and server and data store and all of these things. And if we think that software is going to eat the world, or at least continue eating the world, you now have to train people in Kubernetes and front-end development and back-end development and database design and all of these things, right? With local first, we can collapse this down. We can say, hey, it all lives in this application. The data format is standard, and it doesn't matter which application it runs in anymore. And you don't have to learn all these things. It all runs directly in your browser. You don't have to learn how to deploy Kubernetes. This gives you faster iteration, focus on end users, lower the barrier to entry, and a term we used to use was ship your mocks. So you can just do some, quick prototyping, and that is a production application. There is no difference. But then Larry showed up again, and people started asking questions like, well, how do I submit forms, right? Well, I guess you could store it in your local store, and then we could do some peer-to-peer sync and do store and forward networks, right? Or we could go to the cloud again. So it flips your trade-offs, right? Your constraints are completely backwards. Doing things that are offline first, syncable, peer-to-peer, like, all this stuff just works out of the box. Amazing, right? Portable data, all of that stuff. You want to do aggregation and search and filtering and indexing. Actually, it's much harder, right? Not impossible. And in fact, I think these are problems that we should work on. But they're not immediately obvious how you'll solve them. So, I mean, how hard could it be to build that slide, right? So this is the stack that we put together. So we put this together as a roadmap and then actually got a pretty sizable way through it. And it starts, at the bottom with identity and PKI and some read control with, crypt trees, and, goes all the way up to distributed computing, like literally WebAssembly, moving around the network. I was really surprised to find the parts of this system that people found interesting and useful, and even some of the tiny pieces that I'd pull out and reuse, which again shows to me how early we are in this stuff. So selective sync, really important to people, right? To say, I don't want to pull down the entire data store or even catch up to where I was. I want to grab these specific records, right? An unstructured store. So where we landed with it was a little bit like RDF without the RDF bits, right? So having a data store that you can reinterpret in different ways and build CRDTs out of. Portable computation, which is why I do that now as most of my day. And command and mutation control, right? And that's the one that's actually really sort of taken off. Having a auth mechanism that works completely offline, but also networks between different machines and does get you out to resource management, seems to have actually been at least the early success of this stack. Questions we got from day one. Access control when I'm not online for every request. How do I push this into software somehow when the software's not running on a server? How do I tie into existing services that don't have this beautiful algebra behind them? when I want to get access to more compute resources, like a GPU or emailing newsletters, secrets management, but without going full cloud, right? Like, how do I actually do that? I think probably more obvious for this room, read optimization or incremental view maintenance, right? I want my stuff to show up really easily and fast, selective replication, and observability tools, right? I was surprised by how many people ask for observability tools in particular, right? They want to see how stuff moves around so they can debug, and then also see how, introspect how their application's running. One of the really nice things about local first, if you buy into the whole idea, is that you can build reusable tools that work across application sort of as its own app. Again, making an analogy to desktop computing, you often have like a debugger of some kind or an event log that's system-wide. We built what we originally thought was essentially a Dropbox clone, but people were just using this to debug their programs. So they'd have a problem, it wasn't rendering, they're having issues with it, browser tools are only so good. They would load it up in this thing, navigate down to the part of the data store that they were interested in, and they could see, the text that was there or whatever resource was there, edit it. And they were just using it as a debugger. I actually think we need more shared debuggers, right? Things like this that both show off that you can move the data around and that's fine, but make the experience better for everyone. Prior to doing this, my understanding of a very, very high level tech stack was that you had data at the bottom, you put compute on top of that, and then auth sat on top as a sort of, as access control lists, right? You'd have your data, and then compute would act as a process behind there. And this did not work out for us in a local first context. We had to swap things around and move to another mechanism, right? Feels a little bit more like tickets than a guard, where our data store was aware of the auth layer and the compute was aware of the data layer. And then things worked. Arguably, there's actually one more layer in here, which is effects and resource management. We'll talk about that a little bit later, but interacting with systems that aren't inside of a total local first paradigm require changing between different levels of consistency, or actually being able to tie together different levels of trust as well. So speaking of different levels of consistency, I originally had the original image from the paper cited in the corner there on this slide, and then I saw May Milano's talk at Papers We Love, and she did this nice reduction. This is, I think, a lot more comprehensible. That there's this hierarchy of consistency models. And they're compatible as long as you find the closest consistency model that is shared between the two, right? So eventual consistency, obviously, can still be made, it's not made linearizable, right? But the same set of events can be put on a linear set of events, right? We can pick an order to put them in. And not all systems have the same, and not all programs have the same consistency requirements. Saying that everything is eventually consistent is really great for a lot of programs. It doesn't work for all of them. And so I think as we're developing programming languages and tools and ways of interacting, there needs to be more work on this in the local first paradigm. Inside fission, we always go back to the COM theorem, which I think in this room is probably fairly well known, but I'll at least state for the video, which is a problem has a consistent coordination-free distributed implementation if and only if it is monotonic. That is to say that it only grows over time and you don't invalidate previous results. When you have to go back and start revoking things, then you have to start recomputing data and do a little bit more coordination about what's in the set and out of the set, right? Which gets me thinking about authorization space, right? What is more non-monotonic than auth? So there are two worlds. There's the world of abundance and the world of scarcity. And in abundance, which is usually represented as a pull-based architecture, you can say, I want to copy all of these different things, right? Computers are actually really good at abundance, right? I can copy files, move them around, all these things, right? So this is, somebody's giving me access to something, and I'll pull that down because I can see it, right? It's in my world. The world of scarcity is a world of push, and this is saying, I want this data to live over there, or this should be in the group. And people that have been ejected from the group shouldn't be in the group anymore, right? This is all about scarce resources and controlling who has access to what. And it is a way less bright picture, but it's still very important, right? It doesn't make us feel warm inside, but it is unfortunately a hard requirement, right? One of my all-time favorite quotes is that cryptography is a tool for turning lots of different problems into key management problems, which is both horrifying and liberating, because as an abstraction layer, this is really great, right? If we can frame things in terms of encryption and signing, then it doesn't matter how exactly it's implemented. We've already handled that, right? It's already down in the cryptography layer. It doesn't have to live in a particular location. All or nothing encryption, we found did not work, right? People want to have the ability to say, at read time, I want to give this person access to these things, this person access to those, and this access to these others. And because you do cryptography at write time, you need some flexible data structure that lets you do this. You need some kind of, in our case, we picked a hierarchy, but you need something that you can hand somebody keys out of band and say, here you go, here's access to all of this stuff. There's a couple different takes on this. I haven't seen it used a ton in local first yet, which is why I'm going to talk a little bit about now, this idea of a crypt tree. It basically says every node in a graph has a key for itself and all of its children. And so if I give you access to just, in this case, a photos directory, you can see everything below it. Or if I give you access to just a single photo, you can't see its siblings or its parent because it doesn't have the keys for them. And this actually extends really nicely into a data structure like AutoMerge, where you have a series of streams that can each have their own key, and the parent can point down at it and say, hey, here's the key for it as well. So if you have access to this part of the structure, you get everything. You have access to just this one sub area, you only get that one piece. And of course, it has to evolve in time as well. And one mechanism for this, right? So again, not having all or nothing encryption is to say, well, what if we do backwards secrecy? There's also ways of doing this with perfect forward secrecy. Whole other talk, basically. But even with a simple mechanism like using hashing between each step. Now, if you've landed at a certain point in time, you can see everything from that point onwards. And the parents can point at the latest version. So people who are newly joined to the group can only see from that point on. But cryptography is not always enough, right? Like I said before, all cryptography is breakable, right? And all of this is done at write time. So, unfortunately, we have to keep data off the network, in a defense in depth strategy, which means you need to have some way of proving that you're allowed to go and grab these bytes, which immediately leads you into authorization, identity, this entire world. And it's worth noting that there are Byzantine agents, and auth accidents will happen, right? I think this is a pretty illustrative example where, this kid was probably allowed in the room most of the time, but maybe not in this context, right? Being able to control access to resources in a context-specific way is really important in production. And further, we also need to do revocation when it turns out we've made a mistake, right? And pull somebody's access back. We found, and the most straightforward way of doing this was with auth provenance and just baking directly into certificates that, the entire history. One advantage of this is it means that there's no single point of failure. There's no single list anymore. There isn't a group to manage. You can just interact between systems and that all works, and that's great. So, obviously I work on a particular version of this, right, called UCAN, but we're certainly not the only ones that have explored this certificate capability model before. But as far as I can tell, we're the only ones that have tried to do this in a PAEL system, right? And even going and talking to some of the original capabilities people, right? Alan Karp, people like that, about this. They say like, typically in a capability system, we do it like this. Like, well, I need it to be partition tolerant. Oh, yeah, then you definitely need to do it that way. Okay, great. You need rooted authority, definitely. Having capabilities and paths through auth networks, actually, I should probably roll back here, showing that there's paths through the network that are verifiable in the certificate itself being passed around, ends up being the critical component. It's not that you're only delegating access to a single thing, it's that you're drawing paths and saying, I show my intention to automatically redelegate this thing to somebody else. It has some extra benefits, like resource satisfiability, right? You can say with this, whoever has access to this capability in a token is able to use this remote resource, or they're a member of this group, or they're able to download this block of data. And further, and something that we haven't actually fully explored yet, but there are a couple of folks at Protocol Labs looking into with this, is eigentrust, which is a transitive trust model that uses provenance. And so you can start building eigentrust out of a similar system. This is the most number of citations on a particular slide that I have, and for a reason, right? We'll talk a little bit about co-effects in a little bit, but this slots really nicely into, there's this nice symmetry between capabilities and co-effects for resource management in a totally distributed way. While we're on the topic of trust, how do you trust computation? Well, historically, we've been in the bottom, which way are you facing? Bottom right of this corner, right? In centralized clouds, which is very performant, centralized, right? That's totally works. If I start to receive results that somebody else has computed, how much do I trust them? Why should I trust them? Is it because they're in the group? Is it because they've replicated the computation? Today, what we do in local first is everybody runs absolutely everything, right? Which is not super efficient. One way is to not have everybody run everything, and after you hit a certain threshold, say, you know what, we probably trust this. I've gotten from the group, 3 people have agreed on this. It's essentially sort of like a light consensus. Where things seem to be going, and we've had a few people build on top of our platform already, is zero knowledge proofs. So you get a 200-byte proof that some compute was run correctly. It's also really great if you're doing things like building indices in a distributed way, so that not everybody has to pull down all of the data and build an index. You can get 200-byte proof aggregated across all of these providers that chunks of this were done correctly and that the aggregate was also aggregated correctly. So this is called programming local first software. So I should probably talk a little bit about how to program locally first. Bloom, so the same people that did COM, have this, I think really sum up the situation nicely. Much of the pain of traditional distributed programming comes from this mismatch between an orderly programming model that people are used to locally and the disordered reality that executes their code. To add insult to injury, basically, with this, is that there's also semantics non-preservation between when you start linking different programs together. Right? So if I have program 1 and I have program 2 and then I put a bridge between them, my assumptions go out the window, right? Unless I've proven them together, right? Which is pretty annoying, right? I would like to have all of my parts of my application proven that they conform to certain properties. So one way of handling this is to say, well, let's use auth to at least protect certain resources, again, in this world of scarcity, and to recognize the different levels of consistency, right? So if I'm doing pure computation, it's deterministic, great, awesome. That will always work. It's even better if it's monotone, right? If I have something that effectively is a query, I can always roll back over it, right? I get transactionality. If you really want to get fancy, you can do fully retroactive data structures, right? And say like, well, if I drop this event and I go back and I replay, like, you know, what would that look like instead? The really hard one is, again, when you're talking to things that aren't controlled in this beautiful algebraic world, right, of CRDTs, when you need to go out and send an email or post to Blue Sky, right, where you essentially need to lock your process, have one person run it, because you have the exact one semantics, receive the result back, and then communicate that to everybody in a way that they can check, either trust you or check that it was done correctly, right? This is a pretty hard problem. And I don't actually think that anybody has like totally cracked this one yet. So, you know, obviously I'm working on things that are similar. We have edge cases, right? I would love there to be some way of handling this fully. A few minutes ago I mentioned co-effects and capabilities. One of the topics listed for this group was type systems to help. So two things to say about this. First off, I actually think co-effects do a really nice job with this. They're more general than effects. You can describe any effectful computation as co-effectful. So effects say this bit of computation, you know, talks to standard out. Co-effectful says this bit of computation needs the following things from its environment. It needs to have a standard out, right? Give me a standard out. And bi-effectful is both. Co-effects end up doing a really great job of resource management because you can now say, I need access to a mail server, or I need to have this much memory available, or this variable needs to be in scope, right? And those can have pointers out. So, you know, I basically, you know, receive a handle and I can write back out again. There's a number of papers, actually more cited on the previous slide, showing that co-effects and capabilities end up being roughly equivalent, right? You can always express capabilities with co-effects. So one of my all-time favorite papers is called The Ghosts of Departed Proofs, right? Where they show a lot of use cases that are normally reserved for dependent types, but they use just new type wrappers, right? Something that's available in a lot of languages. Rust, you can fake them in TypeScript, but you effectively have them in TypeScript. Without having to go and build a fully co-effectful programming language, a task that has yet to be done, right? How do we take existing languages and make them satisfy these requirements? I think there's a lot of value. Like I geek out about programming languages. I love new, novel programming languages, right? But there's a lot of value in taking existing off-the-shelf languages, TypeScript, and adapting them to work in this model for us without having to go to the 100% solution. What if we go to the 95% solution? How much faster can we get there, right? And solve the problem for everyone. Elm is a really lovely language. My team used to use it. Lots of teams have tried it and ended up switching out because it doesn't interact with everybody else's code super elegantly, right? I don't want to end up in the same situation with a bespoke new language. Maybe DSL is sufficient, right? I'd also like to see if anybody's exploring leaning into the computational advantages of local first, where you have a lot of different nodes running the compute. One area is blackboard computing. So we share the results. We break the problem up. We're all sharing results. And as results become available, we're using them in each other's programs. Right? Memoization, propagator state. Propagators are this lovely bidirectional computation model where you can do refinement over time and say, the solution's somewhere in here, and then as other people run it, it gets narrower and narrower. We do collaborative indexing, right? Indexing, aggregation, search, really hard problems in this model. And autocodecs and lenses. So the way that the data is actually literally laid out in bytes, I need to know how to deserialize that. Why do I have to go and find a particular software package? Can somebody write for me a bit of code that tells how to deserialize out of this, run length encoded, really tiny data store to expand that out? Or composable lenses, things like Cambria, that individual people can write the lens just for their the part that they care about, but in aggregate, it gives you a path through the potential schema space. There's these kinds of scale efficiencies are something that I've been really passionate about for a long time. So, as your parallelization increases, your throughput in sort of the ideal is linear. We know from Amdahl's law, it tends to level out, or the universal scaling law, that it actually gets worse at a certain point, because you have incoherence and data contention mainly. But if we're restricting ourselves, at least for parts of a program, to monotone functions where we can share and trust results from each other, I mean, maybe we can do better, right? And this sounds like a utopian vision, but I mean, BitTorrent was able to do it for data availability, right? Maybe we can do this for other things that fit really nicely into the local first paradigm. And the last thing to think about for languages is programming languages should, I would even go further than this and say should affect the way that users think, but they always do. Matching a language to a methodology increases the likelihood that methodology will be used. What is the way that we should frame the problems in our programming languages so that people are writing the kind of code that we want to see written? And final section, for fun and profit, sustainable growth, and avoiding capture. I have yet to see a truly local first business model. I've seen people try to apply SaaS, or at least hosting models to it. I don't think anybody has really solved this yet. So further research needed. The concern is that Git is this lovely, totally peer-to-peer decentralized system that got captured by mainly GitHub, right? And yeah, you have other options. Again, Fission started in GitLab, and we moved over to GitHub because of the network effects. Nobody could find our code, right? Git doesn't have issues or PRs out of the box, right? And some people have tried to extend it, but over time, because there's these one-way doors that occur over time, you slowly get locked in. And so there's this slow accretion of, taking this beautiful open thing and locking it down. For a fuller explanation of this, there's this great book, The Master Switch, that talks about this in the history of telecommunications for radio, phones, TV, and the internet, though at the time that this was written, it's still kind of, speculative. The one phrase that I heard at the local first Unconf in St. Louis that I thought was interesting was, do it yourself by default and use store-bought when you get busy, right? So it always runs totally locally first, and then you'll pay somebody for hosting. The hope is that then they don't start adding a bunch of features that lock you in over time, over the course of 20 years, let's say. And how do we do this without losing our soul along the way, right? How do we make it sustainable and values aligned, right? I don't have answers for this right now, but you may remember near the beginning of the presentation, there were the long now and owning your own data. And those are the easiest things to throw under the bus. How do we prevent that from happening? It's really easy to say, yeah, you get collaborative applications, but then, here comes the airplane, and you get your, user-owned data, right? We don't want to end up in that mindset, and I've seen people starting to go this way, right? What we want is to be actually, to have incentive alignment between these things. So I propose 4 things to check a business model against. Does it empower users to participate? leave without loss, so change providers. You control access to your own data, we call this safety, and provide capacity to others, right? So anybody in the network should be able to provide capacity to others. So to wrap up, we have to remember that there are narratives and that there's a wide gulf between these two, right? Between us each having our own total picture of what local first is versus us all collapsing down into one thing, and there's a sweet spot in the middle there. We still need to go and explore and try different things and evolve, but we don't want to get totally disconnected from each other. We've done an amazing job so far, right? It really does feel like we're in the knee of a curve, which is great. Last year, Peter gave a series of open problems to work on. And I agree with literally everything on that list. The ones that seem closer to me, and again, these are different parts of the elephant, right, are identity trust encryption, right? That entire layer still needs more work. We need lossless data interoperability, a way for managing and working with remote resources that are often not local first themselves, because people still need to interact with the rest of the internet. We need extensible CRDT frameworks. Common complaint I hear is that CRDTs lock you into a particular way and they're not flexible. I think they are flexible. We just need to give people the tools to do that. Collaborative, maybe verifiable computation, especially for indices. Reversible compute or retroactive data structures, and a lot of work on business models. So basically, I want to see a Cambrian explosion of different approaches. Go find some more elephants. Thank you.
So yes, we have a microphone in the middle if you want to ask a long question, but you can also shout them. Maybe, Brooklyn, do you have any questions for the audience first?
I think I asked a bunch of questions through the presentation, so if anybody wants to answer any of those things for me.
So I think it would be better if people could ask questions through the mic, because then people on the stream can hear them as well. So, yeah.
So even if all the data can be recovered and you can theoretically move from one cloud provider to another, there is still quite a lot of technical cost. You know, you have to physically go make all of those operations. Looks like it could be automatized, especially now with the Copilot and things like that. So I wonder if there is any experiment, you know, to make so that our business logic, you know, the one that is unique, meaningfully unique to our application, we can still reasonably write it. But we can write it in some form that then can be wrapped up and twisted in some automatic ways so that now is running on AWT. Is automatically collecting some statistics of how much we pay and how much we would have paid if we were running on the Google service. And then we may transparently be automatically switched without knowing it, you know, on another cloud provider. And that could happen like multiple times a week, ideally.
That's a really interesting idea. I love it. So the first part of the question was, is there some way for us to do this in a, I guess, semantics preserving way? And then the second was about actually moving between providers, right? So the semantics preserving way, I think is actually the harder part of the two. Because typically you have to impose that in advance. I guess the other way to do it would just be to get some general sense of, on this machine, you know, people tend to be getting charged this, and on that one, that, and put an abstraction between and move it around. I mentioned that we're working on a distributed compute system right now where we actually do things that are not dissimilar to this. My initial gut reaction when we looked at this, and we're still going to do a little bit of static analysis, was to do look at the cost semantics, look at the cost model for a bit of compute. Obviously, with Turing completeness and whatnot, this becomes difficult, right? So instead what we've done is set so in WebAssembly, you can set a fuel limit, say you're allowed to execute this many operations. And the user says, I give you up to this much fuel to run. And then we can start to see, okay, you ran this much fuel and it costed this much at the end. They ran this much and it cost this. And that we may be able to get some after-the-fact statistics on this.
I have a small counter question on this topic for I guess, the audience. I'd steal one of Peter's tricks. So on programming models, right, and semantics preserving transformation, do you think that existing programming models are great for that, and we should keep using this orderly programming, or do you think we need something new instead, a different programming model that's better suited? Could you try everyone, like, thumbs up for existing models, thumbs down for we need new models?
New programming languages for the win.
So I think we have a somewhat even split, maybe a little bit more on this sum position. Yeah, thank you.
Yeah. Just really quickly on that. So again, I'm super all for new languages. I was having a lovely conversation before I came up to talk, where Simon Peyton-Jones, one of the creators of Haskell, has this great presentation where he talks about the life cycle of a language and how many users it develops, right? So most languages, it's one, it's the creator, right? If you're really lucky, you get to like 10 or 50. And then there are languages that have, as he calls it, a complete absence of death, right? Java, right? Where even if people don't want to use it anymore, it's too late. We're already invested, right? So yes, absolutely, we should invent new languages, ideally that compile down to these things. My challenge to this group is, how do we use the existing languages with these new models that we're talking about?
Yeah.
Yeah.
I think there was one question over here.
I would have a question regarding sustainability. It's the thing that we actually should somehow worry about. And, with the cloud computing movement, everybody was like, yeah, we go to the cloud, there we have green energy, everything is better. We centralize these computations such that we can have a better control of stuff. How does lo-fi fit in there?
That's a great question. Yeah, especially in regions where there isn't green energy, right? Yeah, I mean, I don't have a strong answer. I think it's great to raise. I think that there's a broad question here about the things that we do run locally. People play video games, they watch videos locally. They're pushing all of that over the network already. Having the latency, also isn't free, but it is an interesting and a good point. Yeah, Peter.
So I just wanted to actually say, I think you made a good point already in the talk, which I wanted to return to, which is the traditional model is there's a big cloud computing center. We spend, I don't know, a few $1 million burning up some GPU time to train a 3% better, hopefully, model on cat image generation. But the local first model you propose is one of distributed verifiable compute that's collaborative, right? The sort of challenge model I always use as my reference point is map generation, right? You have OSM tile data. Right now, everybody downloads OSM data and runs the map generation for themselves, right? Each source produces their own thing. If you look at what Google has done with Chrome compilation, which is object file sharing, they have compute clusters that produce object files. And so most developers only have to compile a couple of objects to build new versions of Chrome, which is fortunate because I learned at one point through a very unfortunate series of events that you need like 200 gigs of RAM in your desktop to actually link Chrome. It's like some insane number. I just couldn't actually get my computer to link the damn thing after building it. But that's neither here nor there. The point, though, is that Google has this decentralized, let's call it semi-decentralized or distributed compute model where participants in the model contribute compute resources. The institution, the firm, contributes the majority of it, but each node in the system, because for the file you've written, it's faster to compile locally, but for things you haven't worked on, it's faster to pull. And so you can imagine actually that in terms of the total energy consumption budget for difficult compute, that if we can reuse computation done by other people, if we can use new techniques like this portable compute technology stuff that Brooke is working on, or sort of verifiable zero-knowledge proofs of the validity of computation, use CRDT things like Mickeljohn's LASP model for distributing incremental computations over large I think of it as sort of streaming make files, that actually we have the potential to radically reduce the cost of these large distributed computes by being able to reuse resources in ways that are sort of like fundamentally baked into the infrastructure, rather than things that require, identifiable problems at the scale of like Google in order to be able to take advantage of. I would never set up a system like Google's build system for myself, but one could imagine if we had the right primitives that, we get this as a consequence of our operating system design rather than as like a special project that has to be sort of staffed and funded by a very large firm. So, it won't happen by accident, but I do think it's possible to envision a system, like you can imagine this question of distributed indexing, right? You could imagine the people's Google, where you index your data as you generate it, and then we use large-scale distributed indexing systems to link these things together, and so we actually reduce the compute cost overall and the energy cost of our computing infrastructure. So I think you're working on the right things to get us there to some extent.
So yeah, I had a comment on what you said, that we should find ways to use existing languages but it's contradictory to your own main point of not being locked behind the door. In some sense, you are saying we are accepting that we are locked behind the door of having to use exactly Java, and that the solution, in some sense, is that you can use the Java VM or the dotted machine that was designed for that from the start without necessarily using the same language. So connecting with what he just said, an operative system or a virtual machine that are kind of sharing some aspect could be designed to not be able to lock in a specific language architecture.
Yeah, I mean, WebAssembly as a target, I think, has this as a dream, right? Absolutely.
So I have a question on the last slide that you mentioned about extensible CRDTs.
Yeah.
As far as I understand, CRDTs are composable. So what do you specifically mean by extensible effects? Can you explain?
Yeah.
Extensible CRDTs, yeah.
Sure. There's two ways to attack this problem, right? One is have a whole suite of CRDTs that already exist that you compose together, composable CRDTs. The other way, and there's some work we had done inside Fission, and then actually there's a published paper that does this with SQL, and I'd actually really love to talk to some of the folks from Lecture SQL about extending this idea as well, where you separate the raw data of a CRDT from its interpretation. So you have, in our case, this is not the SQL version, this is the data log version, right? But where you have a series of triples, right, that describe some relationship that always turns into, because we were using hash linking between them, always turns into a directed acyclic graph. All directed acyclic graphs are interpretable monotonically, right? So you can then run a program over that interprets it as a row-only set, or as a last write wins register, or any of these different ways. And you can combine different data sets together now and say, okay, these join in this way. I would like to interpret this as a last write or wins register, or I just want to count the number of events, or whatever the thing is.
Maybe I'm getting it wrong, but does this sound like MRDTs to you, where the exact representation is decoupled? MRDTs being an evolved form of CRDTs. Have you merged replicated data types, merged replicable data types? Does it sound like that?
Possibly. I'm not familiar with that specific work, yeah. So,
it's
there was a paper published earlier this year from I think it was within the PACT group, doing this in SQL.
It's a little bit related to MRDTs, but the kind of composition extensibility is different. So there's tons of things I would like to talk about, extensibility and composability of RDTs, but I don't want to keep you from the coffee any longer. We will have lots more time for discussions later and tomorrow if you join the unconference. Thank you. And thank you to our speakers. just needed to get him to sit down. Did we start the recording? Some people still trickling in. So I guess it's my great pleasure to have the first talk session. I don't know how this works. The second session of today, which has, as I said, this great mix of academia, industry, more experience reports, and more algorithms. And we start with Annette, who's talking a bit about her experience from kind of an academic side, I guess.
Yeah, thank you, Ragnar. I'm actually trying to mix all three aspects into one talk. So what I'm going to show you today is what we at Kaiserslautern University try to do in the space of offline first applications. So for those of you who don't know me, I've been part of the local FIRST and CRDT crowd already, I guess, for around a decade. And together with Christoph Thyssen, who is a colleague from the Department of Biology, we set out to see how collaboration or collaborative software can be used in education. So he's a biology didactics professor, and at some point we sat together and were talking about state of the art in giving lectures in schools. So what many of you know and what is kind of considered a classical model is teacher-centered learning, where a person is standing in front of a blackboard teaching students how the world is supposed to look like. There's a lot of interaction between teacher and student, but not so much around students. What is kind of the other side of the coin, at least at the moment, is to have collaborative learning in an analog fashion, so using pen and paper and maybe other fancy materials where students sit together and work together. So they learn together. Teacher is maybe controlling what they're doing, but he's not kind of the center of focus. The problem with this approach, as you know, is that, well, it's analog, right? They work together on a piece of paper. What we actually want to have, maybe, also with new tools coming out and schools being able to use digital technology, is to transfer this analog collaborative learning into a digital collaborative learning. And at least in German schools, it's not so easy to get this working. And I guess my experience is representative, at least for many European and also international situations. Some of you might remember that there was this great initiative, this one laptop per child thing, where they wanted to get digital technologies out, equip schools and classes such that every child would have one mobile device, one laptop, where they can share and work together in activities, share also internet connections and so on. Unfortunately, this project died in 2014 for various reasons, but I think it had this great idea. People go together, they work together, they can take their homework home, continue working, come back into school, sync, and see what the others have been doing. Maybe also work from home together somehow. So there's kind of a huge space of when work is done, how it is done, but it's still collaborative. Today's reality, so I have a kid in a school, or actually two kids in two schools. Today's reality, at least in German schools, is actually not reaching what we had back then, I think. So schools in Germany, in our hometown at least, have tablets, for example, and laptops, so you would think it's not so difficult to get some software onto these things and work. Actually, all the school books that we have been digitalized. So you get digital workbooks, you got school books, but in essence, they're just better PDFs. So with nicer scrolling functionality, and yes, you can take a pen and kind of scribble on your iPad, but then you have it kind of on your iPad or your tablet. So these digital material that is out there, that is sold by companies, is not collaborative at all. It's not intended for collaboration. It's intended for this, you do your single homework on your own, and maybe sometimes you sync with a teacher, but you never ever see what your classmates are doing that are sitting next to you, right? So this does not work, and I don't know if there are any plans to get this to work. There are, of course, many different collaboration tools out there that we all use. Problem with this is that if you look closely enough, even at university, the situation is that many of these are too expensive, especially for schools.
And there are a lot of data protection concerns. Whether these are valid or not, I'm not going to discuss, but at least this is the situation that teachers and headmasters and so on have to deal with. Schools, after the area of Corona, where everybody was at home, started to digitalize more. So some of them were already at the forefront, others kind of caught up. What many of them established were either some form of network file systems, which is at least some way of sharing your work with others, within a ecosystem that a school is allowed to use. The problem is these are typically too generic, and you typically also have no concurrent collaboration. So if everybody uploads their text document, you can see what the others are doing, but you're still not working together. What is out there with wikis and things like Moodle and Nextcloud is getting into this direction, but after talking to teachers, we figured out that these things are actually too difficult to handle because they're very general, and most of them don't support offline very nicely. So for example, Nextcloud, depending on how you open the file, you get copies. Yeah, well, good luck. And then you have 30 copies because you have 30 students, and every teacher is kind of saying, that's not what I'm going to use. So we sat down, and actually, within the scope of a project, we decided that we want to get real collaborative environments for learning and studying together into schools, and together with BASF, who is sponsoring this project, and their Teens Lab, we are developing a software called the BASF Teens Lab Book. What the software consists of is that we have a collaborative surface here where instructors can place experimental descriptions, students can place spreadsheets for filling up data, we have text modules, you can generate diagrams and so on. And the idea is that the students go to this Teens Lab, kind of get a tablet, work on these instructions, tick off the boxes as they go along, share their data, and in the end, they have a common session where they can kind of show how things go together, and if several groups, for example, do the same experiment, they can compare how different their results are. The requirements that we got, and that were growing over time, because at some point I realized, oh, it's actually cool that you can get collaborations, so let's see what we can get out of that. Yeah, so we are supporting currently text, photos, videos, spreadsheets, and data visualizations. We get requirements for extending the software for new components, so for example, having little plugins for colorimetry and stuff like that. We have collaborative and also non-collaborative content. For example, one of the tasks that we got was that the task description, like the experimental description, must be non-modifiable. Yeah, no student is supposed to change a single thing in there because otherwise, things could blow up. We provide templates for tasks. So for example, when you do an experiment and need to measure temperature, then you get a template spreadsheet that is already labeled correctly and so on. And we distinguish between public boards that are shared with everybody in a group, private boards where you can put your private notes on, and these script boards that contain the pre-contained material. This is mainly for convenience. This is how the specific project works. I guess not every collaborative software needs to have that. How is the system built? So in essence, it's local first, but it follows this flavor of local first, where you have a server that provides persistence and in general the access point or access location for the data. So we have a web server that serves the web application. It's a React application that does also data management using Redux. Material UI for the front end, and for synchronization, in the current version we use YJS that is connected to a WebSocket running on our server that persists the data into CouchDB, and we have another little media server where we store all the static content. It was not always like this, so I like to eat my own dog food in a sense that at some point we initially we started the collaboration layer with a concordant platform, which was done in a collaborative little startup that did not survive, but we learned a lot from how we did the data modeling there. So this was our initial starting point. Last year we switched to to YJS, and eventually we might consider also switching to Electric just to see how the data model within the application kind of changes. Now, when you start a project like that, you know, it's very easy to kind of say, yeah, I'm going to do a little prototype and start working and so on. This has been in development now for, I think, almost 4 years, and it's developed mainly by students. Yeah? So it's a very organic thing that grows over time, whatever that means. Once in a while, somebody needs to sit down and clean it up, I guess. Developing such a stack might be, for many industry people here, a thing where you think, yeah, well, you know, just plug things together, we know how this works. My experience is that even students that like web development and want to learn more about it and even did a few projects are totally overwhelmed by that. Yeah? And so when kind of preparing for the talk, I was kind of looking back, what were the challenges that we were facing and are still facing? So where is the inherent complexity that we are shifting around, as Brooklyn rightly said? Let me start with the one that is maybe not so obvious. The UI is for us actually a huge challenge. I'm not a front-end developer. It turns out that if you develop a web application that is supposed to run on laptops, on tablets, by different vendors, and is supposed to be accessible. So we also have had recently a user study with sight-impaired people, yeah, so they also want to use it. I don't know where this complexity comes from, but it's simply not possible to maintain any software that kind of does what we're requiring. And so just to show one of the examples, if you open this application on a tablet, you somehow need to fit the keyboard somewhere, right? Came a little bit as a surprise. We were developing, of course, on the laptops, and we opened it on a tablet, and suddenly like half the space was gone by the keyboard. And then you start redeveloping and, you know, thinking up about where to visualize what. So it's really very difficult, and the problem is the shows. Yeah? So we have customers in a sense, and they are worried about this a lot, much more than I ever was, but yeah, there you go. The second challenge that we are facing is data model. So we are now already in the second synchronization framework. Maybe it gets better if we take a third one. But the problem is, you know, I have the impression I know how CRDTs work. The problem is the way that we need to model the data in the application for the front end, for rendering and so on, tends to be slightly different from the way that I model my data with CRDTs. Then you have the transport data model, where you don't have the CRDTs, but kind of the stream and YJS of delta updates and so on. And then we have a persistence model, where you want to make sure that you persist stuff. And then you want to be able to debug things. Well, good luck, you're transferring your data between different views. At least for us, I have not found the sweet spot here, but maybe Peter has an answer for that.
Not at all. I just wondered if you could give a specific example of the challenge there.
Yes. So, as I mentioned, we have different components that we can use. We have a text editor, which is great because we can use YJS with the Quill editor, which is really a lifesaver for us, I guess. But we have other components where we do it the hard way. And one of them is a to-do list. To-do lists are that simple. Everybody knows how they work. So this is the example I'm showing you here. Yeah? So the way the to-do list looks in the application is that you have different items. You can also switch them around, which is not very visible here, but and you can append them here, you can tick them off, and you can change the content. The first student that sat down modeling the to-do list did it in a column-oriented way. Basically, I guess because Concordant didn't have nested CRDTs, so what we got were 2 arrays in essence, one for the status here, so whether it's ticked or not, and one for the description here. 2 arrays meaning, you know, if you put them together, then you have the status for the corresponding description. But as you all know, this means that you need to make sure that these arrays are always changed the same way, which means you need to have some form of transaction, making sure that if you add something to the one array, you also add something to the other, or remove, right? What also turned out to be interesting in that way was if you have 2 different CRDT objects, say, if you want to implement something like undo, which we're also supporting, you suddenly need to not only undo things on one object, but on a second one. So all the nice tricks that people play with stacks and so on are good, but they get more complex the more objects you have kind of in there. Another way of how to model this, of course, would be instead having one array and then for each entry here an associated map, JSON, whatever, and that has then these two entries. But this requires for us that we have nested CRDTs, which is possible with YJS, at least when I figure out how to use this in our Redux binding. Or to do something with references, which then means that you need to query many, many more objects, and this does not necessarily make your life simpler. Yeah? So this interaction might increase latency, and this is sometimes indeed observable by the user. It gets more interesting. So for the to-do list, we only have two objects, or two CRDTs. We also have a spreadsheet. And there, so in the current version, by the way, for the spreadsheet, we have 5 objects working together. Yeah, so it gets more complex by the day somehow. What we figured for the spreadsheet was actually that semantics are also something that users are, wondering, worrying about. They have certain ideas, and the ideas that our customers have differ from what we can often build with the CRDTs you have. So Brooklyn was perfectly laying the stage out for that, yeah. So being able to have customizable CRDT semantics in some form would be nice. So with YJS, we are, at the moment at least, able to do everything we kind of want. But it's not so trivial. So one of the requirements that we got is that when we have a spreadsheet here and we have a concurrent edit with a remove. So one student is editing something, so think about they carefully put all the data in the spreadsheet, and then somebody is removing a part, and then it's all gone. You don't want to have that, so you want to default to the edit taking precedence over the remove. It's not so easy to build this with the CRDTs that we had. Okay, we managed somehow, just as an indication that it's really not so simple. Most applications that we figured when we did a small search, they go for the easier way regarding the conflict resolution. So for example, when we looked at Notion, if 2 users start here with a spreadsheet with 4 columns and 3 rows, one of the users goes offline and edits by adding here things into column A and removing column B. While concurrently, another user added things here into Y. What I would like to have is that later column A and B are still there. Yeah? So they do this at the same time. Bob does it online, Alice does it offline. As soon as Alice goes online and synchronizes, what happens is that all her work takes precedence, which means that not only the entries in A appear, B is also deleted. And what's interesting is that also the column that was added by Bob and which Alice did not even know about disappears. Man, that's annoying, right? So you can, and I'm pretty sure that the developers tried their best to not come up with the semantics, because why would they? Yeah? So as you can see, there's a real inherent complexity. We had a paper presentation at the PAPAC this year where you can see kind of what cases you need to consider and then start designing kind of the semantics that you want to have. But mind you, this is nothing I would expect an average developer to come up with. Yeah? In our first versions, we also had the default for removing because it's just so much simpler, right? Second, as I mentioned, this has been a project that has been going on for a long time. And the more students we have on that, the better you want to automate testing and CI and these kind of things. So we do now some test-guided development. I had 2 very brave students that came up with the test suites over last winter. So we by now have pretty good, I would say, coverage of our things. We need to test for 2 things. We first of all need to test for the interaction tests, so based on the user stories, whether what we expect happens if I'm kind of offline working on myself and I press a button, whatever this button triggers should kind of happen. So this is the stuff that we test, but then we also need to test what happens in a concurrent case. So how does the state evolve, both with local actions and with actions coming from different users? So we have now a test setup where we have 2 clients. We have the CRDTs here, and then we have kind of the materialized versions that we use within the application for modeling the application state. And then we, do different operations here on the CRDTs and later on kind of check whether they are equal. Yeah? And you get a lot of tests to run for that. Our CI pipeline currently takes approximately 2 minutes. The longest test takes 19 seconds or so. Yeah? And yeah, there is space or so, but mind you, I'm not talking about this is the best that academia can give you, right? This is what the average programmer, yeah, our master students, I would assume, are average beginner programmers. This is what I get if you kind of let them loose and tell them, you know, try what you have. Yeah? And yeah, so this is kind of the state we are currently in. This project will be continued. We didn't put it open source yet, but it's supposed to happen within the next couple of weeks, I hope. So just to stay within the time frame and give us a bit of time for discussion. Writing collaborative web applications is fun and pain. It's very nice. You get very excited people if you kind of show how things work and, you know, have the synchronization and everything is really, really funny. Writing a substantial application, and I guess this is a substantial application with like 24,000 lines of mainly JavaScript code, is something that generates a lot of pain and also a lot of happiness. What we also figured out with our first test runs with the students in the lab is using collaborative software is non-trivial. You need to educate your users somehow. I know everybody knows how Google Doc works, right? So you can sit down and simply write your stuff. The more functionality you have, the more interesting it gets. And many, so one thing that we actually learned from last year's unconference in Berlin, that was also organized by Ink and Switch, was, and which proved out to be very, very cool, is we needed to make the status of the application visible to the user. So right now we switch between green and blue, depending on whether your data has been synced or not. And just giving the user this visual clue solved so many issues they had, because they would not understand, like, I have it here, why is it not there? Like, it takes, you know, a little bit of latency is a thing, even if you stand next to each other, if you have to go through the cloud at least. As an outlook, what we are currently planning to do, we have users. We can deploy this, so we use this in university classes nowadays. We are planning to deploy this to real schools, real students, so also scale things up. What I'm really interested in is to see interaction patterns. I don't know how people use Google Docs. I'm not Google, but we can ask or can look at how our students are using this and do some meta-analysis. You know, how many contributions were done by a specific person? Do they work one after the other? How fast is or how fast does somebody react on a wrong entry and tries to correct it? Do 5 people try to correct the same thing? How do they work together? Which also has some didactical concerns. There is no real software out for that, so teachers don't know how to teach with it. Yeah? And eventually we also need to give teachers the tools and hints on how to set up the right exercises. I guess we also should look a bit more into a systematic approach for data modeling. So right now we have this slightly messy setup with CRDTs and then Redux and so on, right? I guess this is what you need in some cases, but again, how do we model this? I know approximately how to model with CRDTs, a lot of people don't do. Access control policies. We have a very thin access control layer right now. We did work on access control previously. I think this would be a good use case where we can practice this. And also one thing we don't have right now, but I hope is easy to obtain, is peer-to-peer connectivity. Yeah, so such that it really works if they are sitting together in school and the Wi-Fi breaks down. I was once in a school where that happened. We did not use our software back then, but a different one. And it's a pain if you have 30 highly motivated students sitting there and there is no Wi-Fi for 3 days. We tried very hard to get our suite back then into a local first thing, but it simply did not work for several reasons. And I totally understand hesitant teachers nowadays if they kind of say, well, if I can stick with analog, paper works. I know how paper works, right? Going digital has a very specific risk, and I guess it's on us to reduce that risk somehow. Thank you.
Hi, I'm Clemens Klockmose from Aarhus University. We are also building collaborative systems for high schools, have been deploying in high schools, and I would love to chat of potential collaborations. Just
would be
flagging
great.
that. Yep.
Hi, great talk. I was wondering about the challenges of these different data representations that you mentioned, and maybe you could elaborate a bit more on that, why you need this kind of in-app view of your CRDT, because maybe I'm biased a bit, I guess, from like a reactive programming viewpoint. I would just expect that you basically can perform your edits directly on your CRDT and use that as kind of a single source of truth, and then in your user interface just have some kind of derived view of that you that you kind of bind that to your React interface and display that. So why do you need another data representation?
So we have that derived view. The thing is, so we have Redux in between. So we have this derived view, and then we have Redux for maintaining, in essence, this derived view together with the CRDT binding, so to say. Yeah, and this needs to be in one specific place. So whenever I update stuff, I kind of need to go through that thing and then need to materialize. For some of the application, like components, like spreadsheets and so on, doing this in an incremental way is non-trivial. Yeah, so if you materialize everything from scratch, it's much, much simpler, but the larger the data gets, the worse.
Thank you.
Julian is a little bit spoiled from Rescala.
Yeah, thank you so much. This kind of field report from people really, especially working with student developers, is so incredibly helpful and valuable to see. I am as astonished as I am impressed that somebody thought to model a to-do list with 2 columnar arrays. It's the kind of thing that, like, sure, yeah, I guess you could do that, but I would never have thought to try that, so it's great to hear how it went. So thank you, that part was really great. One thing, I know I asked, but you mentioned in your slide with the triangle that there was a tension between the application, the storage, and the network transport, and you had different representations of each. You described the challenges of the sort of front-end part, but I was curious if you could elaborate, like how the network and storage parts of that triangle also were tricky.
I'm probably not the... Yes.
There, yeah.
I would like to tell you more about the challenges of doing the persistence here. The problem is we have not done that yet because it's challenging. So the thing is, whenever we have students starting with this, they want to see what is in the database. In our database, we are storing the YJS stream, in essence, right? So the deltas, such that we can reconstruct things from them.
The encoded incremental updates, not the sort of materialized document.
Not a materialized document, and this is kind of difficult because then the students can't see what is actually in the database. And if you break invariants, so for example, we had one invariant that the spreadsheet needs to have at least one entry. The problem is that due to synchronization, sometimes the creation of the spreadsheet is not as fast as some other parts. So what we kind of do is that we create a spreadsheet and then we add one cell. But this addition of one cell is then synchronized. So the more students kind of open it on a tablet, the more of this one specific cell that we of course hard-coded to be R1, C1 appeared multiple times. Yeah? And then you kind of materialize from the CRDT and it breaks because the invariant that you have unique rows and columns is breaking famously. We had no way of going to that stream of data. I mean, it took us a while to understand what happened, yeah? And I mean, just because we just coded it, it was kind of, yeah, it should be that, yeah? But
it works fine until there's latency.
It works fine until there's latency, but we had no way of kind of, knowing what is actually now in this YJS layer in. What is the data that we kind of have? So we need to materialize that somehow. I think I recently learned that Databricks, I think it's Databricks, that they have this debugging view in the developer's view for the materialized CRDTs. And I think that's exactly what we needed.
I have built exactly this component, and I will show you what I built so that you can steal it.
Yeah.
Yusuf has one too, yeah.
Yeah. So this is the stuff, this
is so
all
good.
Need, right?
Thank you so much, yeah. And I really appreciate you unpacking that as well. It's super helpful to hear about. The other thing I just wanted to share was I went to a great talk by a guy named Sam Ritchie at Strangeloop last month. He is working on sort of a live coding notebook for learning physics and mathematics called Emmy, based on Sussman's work. And he's thinking about, he's in a slightly different context, but again, he's thinking a lot about these like collaboration uses, and like the professor is live coding, you know, the lecture so that students can see it, but he wants the students to be able to edit it at the same time so that they can experiment. And then how do you deal with all the conflicts? I was like, oh, this does sound like a CRDT problem. So maybe there's some opportunity to connect up all the people who are working on this and see if we can, you know, form some kind of a mailing list or something where people can chat about their challenges.
Maybe you can already set up. But actually, maybe have a short question for the audience. Like, who would you try to have students implement some local firsty application kind of thing? Is that something? Quite a few people that did. So, were you
How many with GUI, with graphical user interface?
Similar experiences? Different, okay. So maybe we talk about that at some point. Yeah. So we have our second talk of the session, which is, well, I'm not going to guess what it's about anymore. I'm wrong every time. So, Yusef, the stage is yours.
All right, then it's up to me to explain this. No worries, thanks. So some of you might have seen my presentation yesterday at Live, what I'm trying to build with TypeCell. It's kind of a mix between Notion and Jupyter notebooks, and it's built on top of a local first architecture. I want to share my experience, really building on top of local first. TypeCell is a fresh take on what I think documents and software could look like if we really think about, okay, putting users in control. For me, what does that mean? Focus on hackability, so making it possible for users to extend the software from within the software and user programming, etc. And also try the very ambitious goal of making the complexity of programming a little bit less complex. I try to do that with a live evaluate as you type programming environment. And of course, build on top of a local first architecture because of all the other end user benefits already I think everybody is familiar with. And because why not, how hard could it be? So here we go. Today I'll share my experiments and lessons learned. I hope to give you some insight in how I went about building this, so you don't have to hit the same roadblocks. But I also look forward to hearing from you, like, okay, why did you do this, etc. And I'll do this mainly by going through the different layers in the application. Before I show how TypeCell works, good to keep a couple of design principles that I had when building it in mind. So in TypeCell, everything is a resource, and the resource maps to a YJS document. Things are editable as much as possible by the client. It's built on YJS. I do have a server, but philosophically, I would love to minimize the logic on the server. So I would love to minimize that central authority. And the way it's architected is it consists of many small, lazily loaded resources, as opposed to having an application that syncs all the state to the local storage, and then build on top of that. TypeCell consists of many small resources, because maybe at some point in the future there's going to be this big graph of people working on different resources that are interconnected, etc. I would love to see that someday. Enough said, quick demo, so you can grasp what it looks like. First, okay, what is TypeCell? So this is more about the live programming environment, but then we know what it is. So it's similar to Notion, but in Notion you're limited to the blocks that Notion provides, or in Google Docs. And in TypeCell you can actually extend it with a notebook-style programming environment. So here I have one variable in one cell that's used in the other cell. The 1990s marquee is still alive, and when I change the other one cell, it gets propagated to the other cell. And then when you take this system and you start building on top of that, you can build other things, import libraries from NPM, get some cool confetti, or maybe make small calculators, small programmable documents. You can also extend the system. So in this document, I register a block that is a map, and now the Notion kind of document system is extended with the concept of a map that TypeCell doesn't have any notion of. So now the user can press /map, and the map is inserted into his document, and is imported from the other document. So now you know how what it's about, but of course this talk is more about the local first principle. So let's see what that looks like. As I mentioned, everything in TypeCell is a resource. So here I'm visiting my profile with the tester, it was just a demo account. And when I hit F9, I actually bring up this inspector. So this might be interesting to how it worked around, one of the limitations that Annette mentioned. I hope it's visible, but you can see the resource that has been loaded now in memory, and this has the type profile. And there's resource, this corresponds to one YGS document, and everything has an ID, which is like a random identifier and a way to address it. And here I can inspect a single document, and you can see, okay, it has my username, it has the date that I joined, and also the URL of my avatar. Now, when I open my workspace, you suddenly see a lot of other documents being loaded. And these are documents of different types. So now you see a project document and a number of rich text type documents. I can inspect that. So if I look at the workspace, which is the project document, you can see it has references to its children. And they all have an ID. And when I open this project resource, it needs to load those children because I need to know the titles of those documents, right? Something else, another concept that I use is the URL resolving. So every YGS document has this unique identifier, and there's one step. So for example, the page that I'm in now, it's tester/public, etc. And there's a way to resolve that where actually the server is involved. But it resolves to two identifiers, and those are two nested documents. So this is actually the project resource is now the parent, and then it knows, okay, I need to load the sub-identifier as well. This project resource, what you see on the left-hand side, but it's got this view where it can load this nested resource, and that's the what I call the sub-document. Let's see when, so here you see all the documents being loaded, which corresponds to the left, and now I'll collapse one of the folders, and to be able to show the documents in that folder, this is what I meant with the lazy loading. Yeah, I need information about those documents, in this case the title, so you'll see, okay, those are instantly loaded in. When I expand it, and this is all happening local first, right? So it's first loaded from disk, and then in the background it starts synchronizing them with the server. But if I collapse it, you can see they're still available locally. So now I say, okay, also show the documents that are not loaded into memory. And you see the loaded property for those documents that are not actively being used. They're set to false, but they're, so how you can see that things are offline. That then, of course, brings all the benefits that we know from a local first architecture. So here you see live collaboration between two different tabs. I can set one user to have a flaky connection, so go from offline to online every 5 seconds. I can start editing the other documents and set to offline, so that it will basically pause syncing. I can edit the title in one document, go offline, and then you'll see it reflected in the other document, or the other way around. And I think what is nice to notice, because I'll talk about this later, is once I edit this title, you actually see it reflected in 4 places. So it's reflected as the title in the document, it's reflected in the sidebar, it's reflected in the title of the browser, and it's reflected in the URL. And this is because, I find it very nice to see how, for me, it became a lot easier to build a reactive view application on top of local first architecture. So this was actually, maybe in a traditional architecture, this is a lot harder, a lot more, at least requires more code to implement. And here, everything just works, quote. So now you see it's updated anywhere instantly. and also in the URL and the title, etc. Finally, now I open a private window and also has the concept of, okay, everything should be editable, so users can start editing this document. It saves its changes in local storage, but of course I'm not signed in, so it cannot sync it to any account. But it does give me the option to either revert the document or to sign up, save a copy, etc. But it's a cool way for people to already get started with the software without maybe creating an account. There we go, sorry. Yeah, so I hope that gave a good overview. Now I'll go through the different layers and my experience in those layers with local first software. Yeah, my experience was a little bit different than from Annette and Annette's students. I figured because I really experienced, okay, because updates are streamed in automatically from the CRDT level and writes are instant because you have the data locally, it actually makes the view layer a lot easier than when you're building a traditional application. Like no more error handling about network requests everywhere, data requests, etc. And you don't need to write an API layer for every model that you add to your application. A lot of that plumbing really goes away. But yes, I do feel sorry for those students because getting started with YJS, it definitely is complex. So this to write, yeah, you have this nested, and this is similar to that nested to-do list that you were talking about. It's complex, it's not very ergonomic, as people say. And reading is even worse, so you need to manually observe changes to the document, etc. I didn't want to work with that, so I built SingStore, which is an open source library which tries to solve these things and also give me a lot of hand-on experience that helped me building the rest. But the writes now are simple property values writes, and it translates to what you see on the left. And reads also automatically listen for changes, and that bridges with reactive libraries such as Mobix, Vue, Svelte. And now my components are React components that simply look like this, and they automatically update when the age of James, in this case, when it changes, that component will automatically re-render, but it will not update when anything else, let's say you change James's last name, or let's say you change James's height or whatsoever, this component will not re-render, but any change about age, whether it's local, remote, etc., automatically now gets propagated to the view level, to the view layer. This took a look at JavaScript proxies stuff, etc., to build, but it did find, yeah, it made that view layer a lot more easy to work with. And you can actually see some to-do examples in about 200 lines of code now. Zooming out, this is kind of like what the entire architecture of the local first system now looks like. Hope it's visible. So as I mentioned, on the left-hand side, you see the app UI, and the view layer stays quite, is quite easy, but we move a lot of that complexity. I think the backend is also relatively easy because it's regular updates, data agnostic updates that are being shuffled around. But there's more complexity in the sync layer, which is what you see below the document pool. And that definitely, I think, at this moment, when you're starting to adopt a library like YJS, there's more things going on there. So I had to build a sync layer that takes care of this. So the view layer just adds, asks the sync layer, okay, load the document with this ID or create a document with this ID, but then it's the sync layer responsibility to keep a pool of all the different documents, to connect the YJS providers or remotes, connect IndexedDB, connect the local storage, keeping track of the sync status. So one thing that I do is when you edit one document offline, and then maybe you later on you open typecell, but not necessarily that document, I still want that document's changes to be synced to the server, right? As soon as your connection reestablishes. So there's all this orchestration around documents, the sync status, forking, reverting, etc., which you saw. that at this moment still requires a lot of orchestration. So it's all not rocket science, but it's definitely, whereas the view layer was a lot less work, now there's more work here, and I do think I know there are some people in the room working on things to, libraries, frameworks to make this a lot easier, and excited to see that as well. That brings me to the backend. And there I had some fun experiments where I thought, okay, because I had to work on a lot of stuff on the view layer, the notebook system, etc. In the first year of building TypeCell, I was like, I'm not going to build another auth system. I'm not going to build the storage, etc. You know what? These CRDTs, they just shuffle updates around, so maybe I can actually connect an existing backend to it. So I tried this experiment where I connect Matrix, which is an open source chat server, as the transport and the storage of my updates. And this was fun, and actually worked quite well. So I didn't need to write my own backend. And what I did is, instead of chat messages, I sent the CRDT updates, and instead of chat rooms, you now have, or the chat rooms correspond to documents, and the chat messages, they correspond to updates. And then I got all the stuff that Matrix already provides out of the box, so identity, authorization, etc. Potential also for end-to-end encryption. I think this will be interesting, to see if there can be a world where you have like a bring your own backend system, whether it's for compliance reasons, so companies approve certain type of backends, or user preference, etc. One sec. So this is what it looked like. So you have this collaborative docs, and then if you look into a chat room, normally this will be hidden, but it's just base64. This is the actual Matrix chat app, and you see the messages being sent there. I also built the same for Nostr. I got some good response for that. Yeah, go ahead.
Quick question on that. Did you ever get flood banned? Like when you send too many messages at once?
I didn't get banned or whatsoever, and but I host my own Matrix instance, so that's cool. It's open source, it's decentralized, federated, so I could prevent myself from being banned. I wouldn't do this, pollute their public service.
On Slack. Because we didn't want to run our own infrastructure.
Yeah, okay.
It was fun, but
You got banned? Okay,
well,
nice.
It would like block the bots for spamming the channels.
Nice. I managed to avoid that, fortunately, but there are some reasons that I tried not to go too far into this direction. It was super interesting to explore. I also did it on top of Nostr, which is a decentralized Twitter people are trying to build. Actually, Jack Dorsey, one of the founders of Twitter, he saw it, and he sent out a message endorsing it, like, oh, this is an interesting direction, etc. So there is interest for this space, but for me, I was running out of innovation tokens, so to say. So I decided, okay, pause this for a while with end-to-end encryption. That would be really nice, but it's really complex to get the key management, the UX right, etc. So I said, okay, let's pause this and focus on some of the other stuff. And now I'm settled this summer, which is actually cool by itself. I managed to keep the entire application intact and plug in a different backend. Like, yes, of course, it was a couple of weeks of hard work, but at least it's possible. I didn't have to start the entire application from scratch. One of the main reasons was also because I wanted cascading permissions, and Matrix didn't support that out of the box. So I wanted, okay, if you, I think you also demoed this, if you have access to a parent folder, you want access to the documents in between. And now I built that on top of Supabase, which is Postgres, basically Hocus Pocus as a WebSocket backend. And the backend, I still try to keep it to a minimum. So it's responsible for rejecting some invalid writes. So you shouldn't be able to change your joint add date that I showed earlier. And it also takes care of the permissions. I would love to see a decentralized way of doing this. For now, that's handled as like on the database level, these permissions, and including the cascading permissions are handled on the database level. I'm not sure if I have time to go too much in depth, but where it gets more complex is areas such as cross-document operations. Of course, you have search. One that I was interested in is things like back references. So let's say a user links from one document to the other. So Alice creates a document, favorite cities, adds a link to Bob's document, Lisbon. But Alice doesn't have write access to Lisbon. But I would love to show on the Lisbon page that actually, Alice is linking to this. So how do you model this in a CRDT world? That's a challenge I've been exploring. I'm curious to hear your solutions to these kind of problems. One thing that I'm experimenting with is so-called inbox resource, which is a public append-only inbox where users can post messages like, hey, I actually did post a link to this document, and then with some validation around this. Will be interesting to discuss this more in depth as well with you experts on this. But I think it's time to conclude. Yeah, for my experience building local first, yeah, of course it brings a lot of end user benefits that have been discussed many times. But what I really experienced, it also enables or maybe forces a clean separation, a truly clean separation of concerns, and that really levels up my engineering productivity. So to summarize that, no more crap plumbing, finally get rid of that stuff. So you get a really simple view layer, simple, even pluggable, potentially pluggable data agnostic backend. So I think that is super promising and fun also to build this way. Of course, there's also challenges, as with any new technology. Yeah, you have to invent a couple of things. You have to work your way through those. I do feel sorry for the master students having to work with this. There's more complexity that moves to the sync engine, so to that middle layer. I think there's a good opportunity for frameworks to take some of that plumbing away. And everything cross-document gets more complex. Then I think things that I didn't touch upon, but are well known as challenges, schema management, migrations, validation, etc. And also some UX paradigms. So in TypeStyle, when you have everything is editable, that works nice for the main document. You can show a message like, okay, changes are unsaved, sign in or revert. But what if I drag around a document on the left-hand side? How do I present that to the user? Like, okay, you actually made a change that is not persistent for you locally, because we like that you can edit this, but you need to sign in. How do you reflect that? Yeah, I think working with colors could definitely be an interesting way, but I think there's also a lot of patterns that still need to be invented or need to limit the users in some way. All right, thank you.
Awesome presentation, Yusuf. I'm curious how you handled lazy loading with cross-document references. I think I remember you showing that at some point where you can like you can export something from one document and then import it in another one, or did I misremember that feature?
Yeah, so it's based on the ID system. So the other documents, when you open that, it knows, okay, it needs to load this ID. And then this kind of crossovers between the local first and the programming, the live programming part, but then the live programming engine gets the data from that document, puts it in the reactive engine, and now the context that reactive engine creates is also available then to the code that renders the parent document. Does that make sense?
Gotcha. So you basically like walk the document to see if there are any references to other documents when you lazy load that one and you lazy load all the documents that it refers to, more or less?
It's being lazily loaded when the view layer. So it's not, in the sync engine, there's no resolving of references, but as soon as the view layer needs it, so it says sync layer dot load a document with the ID,
gotcha.
Then the sync layer basically handles the model, which is translated into an observable MobX model to the view layer. But because things are local, that is fast, so I don't think...
That makes sense. Yeah, okay, I got it.
Then in the background, when you have it in memory, it starts syncing the things in the background, but the view layer doesn't have anything to do with that because that's the magic.
Sometimes the data may not yet be present.
Yeah, then it's so there's a load and a get operation. The load is returns a promise that only resolves if you either have the document locally or if you're connected to the internet, and the get only returns the document or undefined, so only if it's in the pool already or locally stored.
Hi, thank you for the presentation. At the end of the presentation, you mentioned like some access control, like read or write access control to parts of a document, like with the Lisbon example thing. I'm actually very encouraged to hear that this is a problem that other people encounter, because I have a paper at UPSLA, which will be presented on Friday, which is somehow a first proposal to manage access control for parts of documents, like for example a counter embedded somewhere, where like a server can specify a security policy, which then the untrusted clients should somehow follow. So please come watch the presentation if you're here on Friday, and also come to my poster, which I believe is today on the poster session.
Nice. Yeah, it sounds super interesting. And then, because I think that also opens up the opportunity that you don't need the server to like handle all this. So.
Client server at the moment, but hopefully at some point. Hopefully at some point it will be peer-to-peer, but that devolves into key management,
nice,
as we have seen.
Looking forward. Maybe post a link on the Discord also. Then,
I was curious, just to make sure I understand you, about how you do synchronization. Does the document need to be physically loaded into memory and then you do the network sync? And so then you're applying any of those small network changes to the loaded document in memory, and then you can write that to disk. Is that right?
Yeah, so this is based on the YJS provider system, and yeah, it needs to be in memory to sync. And then there's the concept of the background syncer, which sees, okay, have there been, it's basically a table, which is also a YJS document, that keeps track on, there's like a needs sync since property, so that if there are local documents that haven't been synced, that the only thing the background syncer does is put them into memory, it says load, and when they have been synced, it releases the reference, and then it will be.
Okay, yeah, that was kind of what I was getting to, is if I have two documents and I'm currently working on one, and you're working on the other one, I don't get your edits until my system loads that second document in the background, even though I'm not looking at it.
If you're not looking at it, and if there's no, but then you also don't need the, unless I'm missing something, do you need the updates then? If you're not.
Well, if I'm working on document A, and I know that you're working on document B, and I'm going to pick it up where you left off, and I go get on the plane, and I open up my document, and want to look at your document, I don't have your changes unless I physically synchronize it. It kind of goes back to the triangle question, where something I've been thinking about a lot is what happens over the network. I might want to send a bunch of stuff over the network to synchronize a lot of stuff, but not do a lot of work on my CPU to actually physically update the CRDT. And so then what goes over the network versus what's stored on disk versus what my application looks at might be different in different places. But the way that you're doing it keeps it nice and simple, because you physically have to have it in memory.
So you're right, I do it for the write part, I solve this problem, but not for the read part. So I'm not like, it could be you've missed updates. That's currently not addressed.
Yeah, but that makes sense for this case. So that, interesting, thanks.
Just quickly, I'd like to take this discussion on the programmability level, right? So you wrote your own sync layer. You said that could be put into a library, a framework. But your application also seems to rely a lot on the specific behavior of the sync layer. Do you think this is something that would be good to extract?
Yeah, I think there's definitely generalizable things like the document pool. I think that AutoMerge is like, I saw a preview of the AutoMerge repo, which is taking care of parts of this stuff. So it shows, okay, the generalizable thing is you have documents that need to be connected to network or to storage, and with the identifiers, there was a lot of similarities between the problems and how I solved them, and think what that is doing.
Maybe to
example.
ask for the other side, are there things where you would say being able
Whether
to
or not,
customize this
yeah.
were like super useful?
So there's things where permissions, I think, I can fork and revert documents. Yeah, maybe it could be part of the sync layer. Maybe those are generic things, but maybe not every application wants to have the potential to edit the document when you're not signed in. So maybe the sync layer could provide it. I mean, there's no application-specific code in that sync layer. So it's possible to extract it, but the question is everybody interested in those?
So maybe we need languages to build sync layers.
Ah.
But it's easy. It just takes 5 minutes.
Thanks. I'm so sorry you had to do all that work. You should have had more time to do the fun parts, and the rest of us should have fixed those problems already for you. That said, there are still problems. I'm curious, I haven't got to it yet, but it seems like you might have, or at least you're probably thinking about it. Background sync?
Mm-hmm.
Have you looked at it? Is the browser standard support good enough? Does it work? Have you tried it?
Huh. I have not. It's the easy, simple
Okay,
answer.
yeah.
Sorry.
Do you plan to?
Sounds interesting, so that's
Fair enough, yeah. Has anybody else got background sync working? No? Brooke has. Here.
Like in background sync in a browser? Just
I mean, unless you're running somewhere else.
yeah. What's the specific problem that you're running into?
I don't have the tab open, and someone has edited the document.
So there.
Oh, I see.
So there's like a browser API. You already know about some magic browser API where you can like spin up the app, then that can do this, right? Or like
The unfortunate answer for us was a service worker, which is does not always work in all browsers, right? But it's magic when it works. Yeah.
How do you keep it alive? Just for the stream, I've my service worker goes to sleep whenever Chrome feels like it. There's background sync, which is some API that the Chrome has that's non-standard. I'm not sure how widely distributed it is or if it works on mobile. You know, like really finessing this stuff and getting from like it looks good in the demo when you have the person sitting there to it works every time when you get on the airplane that the data's there is like quite a lot of work, and it seems like other people are racing ahead, so I was hoping maybe somebody had done this one already.
And you even haven't tried mobile Safari.
Mobile Safari is a special kind of hell, and so is Android on Chrome on Android also has shocking absences at times. I think shared workers don't exist there. Service workers do, but not shared workers. Yeah, Johannes, apparently, for those who are not there, you can, Johannes Schickling.
I was hoping this was the reason you've been compiling and linking Chrome.
That was an earlier project. So that project, and I'm only mentioning this as a cautionary tale because nobody should do this. I was trying to fix the multicast DNS support because some intern set a flag wrong in like multicast DNS support like 15 years ago at Chrome. And it was like a 1 byte change, and it took me 2 weeks, and I never got them to accept my patch because the notional owners of the module hadn't actually worked on it for several years, and no one would reply to my emails. As far as I know, my patch is still somewhere in the Chrome like bug tracker. So save your energy, and besides, peer-to-peer doesn't work anyway.
I've been there. I spent 2 months working on Chrome for a different project earlier this year. So
yes, that was. If you want to learn more about that project, that one was called Capstone, and I think I wrote about this on the Ink and Switch website.
Thank you. I guess we are out of time, so we are now for the last talk of the session, which Matthew maybe goes back into academic, but I'd be surprised.
Good luck. Thanks.
Stage is yours.
Okay.
Thanks. Yeah, Matthew. So yes, unlike the previous talks, I'm not going to talk about real software. I'm going to talk about design proposal that could be real software someday if we feel like it. Yes, so it's a design proposal. It's also really a request for feedback. I'd be interested to hear what you think of this proposal, good, bad, if you have any extra suggestions for how to change it or improve it. You can also treat this talk as just a set of ideas that you might want to use in your own local first projects. So our goal here is to make what I'm calling version collaborative documents, which combine the best features of Google Docs and Git. So on the Google Docs side, we have, of course, real-time collaboration, but also this idea of different document types like Word documents, spreadsheets, recipes, etc. They each have their own custom behaviors. On the Git side, we have version control, diffs, branching workflows where you can fork a document, make some changes, and merge it back in, and of course, local first and decentralized. Then in addition to these features, we'd also like to not have just a fixed like Office suite, but also the ability for programmers to add third-party document types. Like if you figure out how to implement collaborative CAD files, you should be able to implement that on top of some common platform with a common backend. So to outline this talk, I'll start with the core concepts behind the proposal, which are sort of analogous to the concepts in Git. I'll talk about a platform, which is sort of like the generic backend-ish layer for many kinds of version collaborative documents. Then since it's a programming workshop, how to actually program these different documents, and end with some related work. So our first concept and the central one is a document. A document is just a unit of collaboration, basically a thing that a group of users can collaborate on in real time, analogous to just a Google Doc or a Google Sheet. As you can see kind of in the picture here, we got a group of users who are looking at this document. They can see each other's cursors, make live edits. Oops. There we go. Yeah, so instant local changes in your own document. These are propagated live to collaborators, hopefully within a second or so. Conflict-free merging, if multiple people are making edits at the same time, they should all show up and sort of preserve the user's intent as well as you can. So under the hood, a document would be a document ID, which is just a UUID, labeling a grow-only log of updates, describing the changes to the document by different users. Probably these updates would be just operation-based CRDT messages so that you don't have to worry about like reordering and latency and stuff too much. So pictorially, we've got this document, just a little square here. It's got a document ID, 9B1D, etc. It labels this log of updates, insert some text, delete some text, set the formatting of some span of characters. Then when Bob's working on this document, he'll generate new updates saying, set this span of characters to have font size 20, makes a newer log with this extra update. Likewise, Alice can make her own edits, insert some new text in the document. It just keeps appending to this log. Okay, so our next concept is a fork. So now we make the rule that at any time a user who has read access to a document can make a fork of it. This creates a new document with a new document ID whose initial log copies the original log, sort of like a git branch command. So here in figure form, we've got this document. It's got two updates in it, and this document ID 9B1D, etc. So Bob, who has read access to this document, can say, I want to make a fork of it. It copies the update log to a new document with a new doc ID and also a new owner. So Bob owns this document, and he has full permissions on it, regardless of what permissions he had on the original doc. So now Alice and Bob can make their edits independently, just appending new updates to their logs. And they may not even be aware of each other's updates. Like maybe Alice doesn't even know that Bob forks this document, so they're just completely independent units. Of course, if you can fork documents, you also want to be able to merge documents later. So here the idea is that if documents A and B have a common ancestor, we say that A's owner is allowed to merge document B into A. And what this does is it copies over the new updates from the other documents log. So in pictures, we've got these two documents from the previous slide. They've each had some, so they were a fork of each other. They've each had some other updates in the meantime. And now Alice can say, okay, I like Bob's edits. I'd like to merge them into my document. So this makes this appends new updates to her log, which is basically just all the updates that Bob's made that weren't in Alice's document already. So for example, maybe Alice inserted some new text while Bob did some editing and changed some formatting spans. Now when you merge it in, you'll have both of those changes. And the hope is that if we use something like operation-based CRDT messages for the updates, then the result should approximately make sense. Like if you use the paratext algorithm to manage the characters and the formatting spans separately, you'll get the result, which is basically what you expect of like the characters formatted how you said. Of course, this won't always work, so you probably want to have some sort of diff preview view where Alice can look at what changes are Bob's updates going to make to her document before she approves the merge. Just like a GitHub pull request. Okay, so those are the concepts. Let's see how you might actually use this fork and merge behavior in practice, like a semi-realistic example. So our setting is that we have at a company, there's some financial analysts on the team. They have this document that they give to the executives saying about what they think the price should be, like the modeled price for their product, then what they model the company's profit will be, and then how it compared to the actual numbers for each quarter. So we have this Q1 report that's owned by the manager of the team. They're the only one who can make updates to it because they want to keep it in a nice state for the executives. So when people want to work on it, they make some forks. So the analysts make a new fork where they can update the model to improve the accuracy. And then also some interns that make a fork where they can enter the new data for the next quarter. So now people make their updates. The analysts edit this document just like in a Google Sheet. They're all live editing the document together, updating the spreadsheet formulas. Likewise for the interns, they open it and they're each typing numbers. They can type over each other, whatever. Then maybe at some point the analysts think that their model is doing well. They want to see how it works on the Q2 data instead of just the Q1 data. They fork off a new document, which we can just call test, merge in the interns' updates, and then you look at the resulting state. Maybe they say, okay, this model is not perfect. It's giving us some weird results on the new quarter, even though it worked on the previous quarter. Going to make some further updates in our collaborative view. And then once they're ready, they can tell the manager, okay, we're ready to merge these updates into the main document, make a merge request. The manager just says, okay, we're good. Likewise with the interns, they say, here's the Q2 numbers, merge them in. And now we get a nice new Q2 report with a better model and also the updated numbers. Okay, so that's just the summary of these concepts. We've got a document, which is a unit of collaboration. You can fork a document, which copies its update log, because documents are really just a log of probably up-based C or DT messages. And then you can merge a document just by copying over the new updates and hoping you get a reasonable result. Okay, so moving on, now let's talk a little bit about the platform, which is sort of the generic implementation of how do you implement a generic version collaborative document, basically just viewing it as its update log. And now we treat the updates as opaque and don't really care what's inside them. So here's what I propose we do. When a document is created, its owner assigns it a home server, which could be something like github.com, GitLab, etc. The home server keeps a copy of the document's update log, which we treat as the single source of truth for the document. So of course, users still have their own copy of the update log, which they update in a local first style. Whenever you make an edit, it updates your own log. You see the change immediately. But these updates are technically just optimistic or tentative until you push them to the home server, and the home server says, like, okay, yes, you had permission to update that document. So what this looks like, we've got the home server's update log, grandma's update log over here. She inserts some new text into the document, which shows up in her own log, in her own document state immediately. And then at some point, she'll push it to the server. The server will say, okay, yes, I approve this update. I will add it to my own copy of the log. And vice versa, when other users make edits, they'll send it to the home server and eventually reach grandma's state. And the fact that these updates are reordered here hopefully shouldn't matter if you're doing some sort of op-based CRDT or other commutative data structure. In principle, we could also have peer-to-peer updates in this setting. Even though I've said central home server, grandma could still talk to other peers, like people next to her on a train, and get their updates as they're collaborating. So they'll see each other's updates because they're persisting to their local logs, but technically these updates are tentative until you push them to the home server, and the home server says, like, yes, that person did indeed have permission to access the document. Okay, so now the question you've been thinking for the last two slides is, hey Matt, this isn't local first, right? You have a home server that's a central source of truth. So I want to try to argue that actually it's okay and we can still get the properties we want most of the time. So yeah, the objection is that a user's update log is not the single source of truth anymore. It's just technically a cache or like optimistic copy of the home server's update log. But the difference from like a traditional client server app is that a user can still fork their local copy of a document, which does create a new local source of truth. And I would argue that this avoids many of the problems that we're worried about in the first place. So first half, you say your home server is down, or maybe they jack up the price, so you don't want to pay them anymore. well, then you fork a local copy of your document, put it on a different server, and hopefully coordinate with your collaborators to say to them, like, hey, please, merge your existing tentative updates into this other copy of the document. We're going to go on collaborating from there. Likewise, if the whole internet is down, you can make a fork on your local device, say I'm the home server now, we can talk peer-to-peer for now, and then later, maybe once we have internet back, we'll fork our document onto a different home server. Likewise, if you lose permissions to a document, like maybe you have some petty dispute with the document's owner, you can just fork the last version you saw. Now you have a new document that you're in charge of. In the same spirit as like a Git fork, where if you disagree, or there's some sort of schism, you just make 2 different copies that work independently from now on. Okay, so the other question is, why put this home server in the first place if it's kind of a compromise? So the reason that I made this choice is because if you go back to the fully decentralized setting, which is like peer-to-peer or no central server, then permissions are really hard. You have all these tricky scenarios like, Alice removes Bob from the document, concurrently Bob makes some updates, maybe other users saw these updates already and made further updates on top of them, and now you want to know, like, okay, were those updates valid or not? Should I reject them, like take them out of my current state? Or, yeah, are they even, like which ones are valid? Likewise, there's scenarios like, Charlie and Dave are admins on a document, they both ban each other. Now you have to make some CRDT-ish decision about what the final state is, while keeping in mind that, the removed actors might not be trustworthy. It's just, I don't know, it seems very tricky. So the home server lets us say, we'll just use some simple centralized solution, like, the server has its own database of who's allowed to access the document, and it'll just accept or reject updates depending on its state at the time of receipt. It's like when you receive an update, you'll say, was it allowed or not? Okay, so that was the platform. So now I want to talk about the programming part of programming Logo first. So how do we actually implement, version collaborative spreadsheets or recipes or CAD files on top of these update logs? So we need 3 things. We need a schema for updates saying what they mean. So you might say, like, okay, each update is a YGS operation. You need a renderer that takes the update log and displays the actual resulting state in a GUI to the user, and also generates new updates in response to user input. This could be, for example, if you've used like one of YGS's rich text bindings, basically a wrapper around that binding that then also handles the updates between the YGS state. And I won't talk about it, but we'd also like this diff merge preview view so you know what you're doing before you merge in a different document. So the important part here is this renderer, which is probably familiar to people who have made CRDT-based apps before. So we have these update logs over here, your local copy, and then you just you send the updates to some CRDT state if you're using app-based CRDT messages. That computes what the current underlying state is. You render that in a GUI using some like functional reactive programming framework. The user sees it, and then when they make new edits, it goes back into the CRDT state, which updates the GUI locally, and also the local update log, which eventually reaches the server. So stay familiar, this is very similar to a figure in the Pushpin paper, where they call it document functional reactive programming. Okay, so that's it for the technical content. I just want to mention some prior work, especially since I know a lot of the authors are in the room here. So the main inspiration for this proposal is Upwelling by Ray McKelvey and others at Ink and Switch. They talk about basically a rich text version of this, like your rich text editor where you can fork off documents, make your own changes, and merge them back in later. So the proposal is sort of trying to generalize that to arbitrary update types and document types. There's also Pushpin, which has this idea of document functional reactive programming, centered around CRDT documents that you identify by a UUID. And there's also platforms like Matrix CRDT, which Yusuf just mentioned, or AutoMerge Repo, which basically try to be the back-end data stores for your CRDT documents, give them the documents in a nice way that you can read and update. So as far as I'm aware, these don't have forking or merging, although maybe that'll change in the future. And another difference is that they're focusing on the more decentralized or federated setting, as opposed to accepting these home servers as a compromise. Okay, this is just a brief recap of the proposal. I'm interested to hear if you have any feedback, even if it's just like, this is a bad idea. Ideas, improvement advice, or how you would go about implementing this. Thanks. Peter's had his head for a while.
So Peter was first. Peter probably wants to explain why this is not allowed first. Maybe let's go with
I think
They all raise hands at the same time.
Oh, thank you. I think this is a great direction to be thinking about. So one of the main examples that motivates this is the use of spreadsheets, obviously, and I think you were kind of using that in your example. But the actual use of variant spreadsheets is merging doesn't really happen, right? You get these forks and you cherry pick changes across them, right? And you never sync back together. So how do you handle this sort of cherry picking workflow?
Let's see, that's a good question. So I thought about this a bit from the CRDT side of how would you handle cherry picking like op-based messages in a CRDT, which there's sort of tricky technical issues around like you're missing some prior updates that probably you said were causal dependencies and you want to preserve those. Yeah, so that's one question. I guess the other one is in terms of like how do you represent this in a GUI? I have not thought about that at all, but it seems like you should be able to have some sort of history view of like, or maybe like a way to just, outline a grid of cells, say copy these changes only. But yeah, I think that would be neat.
So I want to just quickly get a mood of the room on this manual merging. Do you think like involving the user and helping to make good merges is a great idea? Or do you think that, no, the user should never ever have to manually like be involved in the merging process? What's the thing?
User agency.
So nearly everyone is on users should, like, manual merging is a good idea.
We are all developers, we are biased.
I asked the room, not the general public. Thank you. Further questions?
Great presentation. I love that you're thinking about these things. We've thought a little bit about this fork merge model as well. Two thoughts, one on access control and the other on the home server concept. I'll start in the reverse order. So home server, at Vision, we had done something similar for a really long time, but we didn't frame it as the single source of truth. We framed it as a discovery mechanism or broadcast, right? So it is the fallback for if you don't have peer-to-peer connection to get up to date really quickly at a known place. It's basically a rendezvous, right, to get there. I understand that you're also trying to do that so that you have a source of truth around the access control, right? And so you gave this example, what happens if Alice ejects Bob and then there were a bunch of concurrent writes? I agree, it's a tricky situation, right, because you don't have consensus. One technique that we developed at Vision is something called submarine sealing. It's basically cryptographic anchoring, but without a logically centralized server. I can go through the details with you after, but the basic idea is as people are making their updates locally, they can decide to take updates from other people under their own authority as well and say, like, I certify this because it's in my causal history. So that's one way to solve it.
Okay, yeah, it sounds like a good idea.
Two very quick points. I won't argue with the home server thing. I think you already have a sense of what I think there. But I think, number one, identifying the diff and merge as actually vital and essential for all local first applications, I think is a very good distillation of something that's becoming clearer to me as we're going further. Actually, Brooke's thing about pacalc is like latency is the same thing as partition, is the same thing as working offline, is the same thing as having privacy. It's just different degrees of latency and whether or not you're doing it on purpose, which is meaningful. But the end result is then you need to figure out what went wrong and when now you come back together. So I thought that was a really good insight, and I think it's a hard problem, and I would love to see, like, what should the API be? What are the primitives, like, that everyone's going to need to implement for the renderers? Or like, this is stuff that we're thinking about. I can't wait to see what you do with it. And the other thing I wanted to say was we do have fork and merge in AutoMerge and in AutoMerge repo, and I'm sure you could do it in YJS with a few lines of code as well. It's there. We just hadn't shown it off much lately, so it works. Yep. I can show you on my laptop if you want to see it.
Yeah, I know also, so I think after writing the report for this, before making the slides, I had seen some stuff about like AutoMerge's internals as an update log. It's like, oh yes, this seems very similar.
Did you compare your model with the one that Word, actually, like Microsoft Word, already kind of comes with? So, I mean, talking to non-programming people, they are typically very fond of, sharing documents, merging conflicting views, and so on. And it seems to work, so they really love it. What I'm a bit curious about is how would the experience be different with using something like the home server setup that you have? Isn't this increasing the complexity for normal users too much? I mean, right now they, just send a document, merge it, and they're done.
Yeah, I think so. The home server part is mostly about the live collaboration, like when you have your fork of a document and you want to collaborate on it with several other people. Yeah, I guess it doesn't fit very well into the more traditional, like email a file around and look at the changes and merge it model. I'm not sure how you would make that compatible, other than just like declaring the home server as my device because I'm the only one making updates.
So, I mean, Word has that thing where you can merge documents together, right? So you don't need to manually go through that.
Yeah.
And this looks just very similar. So, I mean, if I would like to sell this to people, what would be the major selling point from?
Business model.
Yeah. Let's see. I mean, I guess for me the selling point is being able to support different kinds of documents on top of a single platform. Like you want to be able to say, like a programmer can add their new like fun little recipe editor as opposed to just Word documents. Yeah, I guess in terms of Word specifically, the main difference might be like different semantics in terms of merging. Like I know the Microsoft Word track changes isn't really exact in terms of where you're putting characters or not. I imagine that usually doesn't matter if you're like editing different paragraphs. So maybe that's not too.
What I would hope for as a user is to get a view of what I'm actually merging from whom, kind of so I have the history. And I guess this is something that you can provide because this is the feature that I always miss if I get Word documents to merge with, because I have no clue what the history is, where it came from, where the fork happened, and what merges were done on the way.
Yes, that's a good point.
So I think you also had a question.
No, it vanished. Sorry.
Sorry about that. We had some questions in the back. Are there still?
Hi, thanks for your presentation. Quick disclaimer, I work on a startup that's basically building this for rich text documents, and we have a similar setup with a centralized server for a few different reasons, but permission control is one of them. And just a quick comment on user agency. From our research, we realized it was really important for users to actually see things before they merge, because sometimes the results they would get from the CRDT merges weren't exactly what they would expect. So even if the CRDT merge is good enough, it was important for them to understand, especially with large documents, to understand exactly what was going on and what were the differences as a review step as well from their own work. Was diffing and merging was a really important thing for us.
Thank you, this is great work. So I'm totally on board with the forking and merging. I think that's great. I think having the home server do centralized access control while having still local first document data, I think is a reasonable pragmatic compromise. I kind of hope we can maybe get the decentralized access control working, give it some more time as well. But the point I'm most concerned about is the append-only log of updates, because if it's, say it's a text document and every single keystroke in the editing history becomes a separate update, you quickly end up with a log that's hundreds of thousands of updates long, and now downloading that entire log and storing that entire log are both kind of inefficient. So what we've doing with auto-merge, and which I feel like this sort of fundamental model here would need as well, is some sort of compaction mechanism where you can say, like, I'm going to take these 10,000 records in the log and compact them into something denser so that you don't have to download as many small individual updates. But that does kind of complicate the model because it's not just copying records from one log to another. You kind of have to have some concept of this compressed record replaces this list of individual records that was there previously.
Okay, the first 10,000 entries in the log are exactly these operations, and now I can compress them, I can flatten them, because I have the authority, because I'm the referee. So this to me sounds like a very interesting thing to follow up on.
Yes, yeah, that makes sense. Yeah, I guess this notion of like the referee can enforce causal stability, so like there are no more concurrent updates because I said so. So then you can, yeah, like in the pure op-based CRDT's work, just replace it with a state.
Yeah, I'm working on a similar system to this, and like that it's peer-to-peer based instead of client-server. And I think one of the advantages of building applications on top of this, which I've been building for like the last 6 months, is that with just thinking about everything as a peer is an enormous simplification for the end-user developer. So like the DX just feels really good to not have to think, well, this runs on the server, this runs on the client. And so I think his point about the referee, thinking of just think of peers that have different privileges. And that's actually how we implement some of our features. Like to compress the log, for example, we have epochs where you can like freeze state at a certain state and just throw away all previous changes. Obviously, it's a really destructive action, and you'd want to do compaction, which would be smarter, but pragmatically, it's just like, let's just compress it all down. And so what we've done with that is like only one of the peers in the space has the privilege of executing that compaction. That way you don't have two compactions going on at the same time and stuff like that. So there's like pragmatic approaches here that you can take that are in the direction of where you want to go without introducing like the home server.
Just a very short summary. I think having a single writer for some state is an amazing way to have.
I am really glad to see that you and the other folks in the more academic side are thinking about this problem. All of the formal literature we have assumes convergence and merging of everything. And like history hiding, you're starting to say like, oh, well, we want to have like a provably equivalent log that skips over intermediate states. But I might have part of the log. So I can, you and I were collaborating, and then I closed my laptop, and then you realize we pasted the AWS key into the document. So you do a commit that like jumps ahead, or maybe the one we push to GitHub or to our, the code sharing, put the patch up on whatever. Like I might have a different history that's partially equivalent. You might be willing to send me the full history. You're my lawyer. And we're negotiating, but the version we send to the counterparty with the red lines is going to be like, just the shortcut. So I think there's a lot of really interesting cases here around, and cherry picking as well, right? Like I think cherry picking and history hiding are actually two versions of the same thing, which is we're trying to get more fine-grained control over the dependencies in the history and being able to create different versions of commits that have the same outcomes. And right now, this just feels like the Wild West to me as I'm like out there implementing. I have no theoretical framework for what's like, am I just going to blow my foot off if I try and implement this? Or is it totally fine and it's all going to work? We're just making it up as we go along. But we know, we do this all the time as developers with Rebase. But Git doesn't help. Git's just like, oh yeah, those are new commits. Did you already push those commits? Too bad. But it's the same commit. No, it's not. Something happened somewhere, so it's a whole new set of commits, and anybody who depended on the old ones is wrong. So I think we can do better, but I don't know what to do. I'm really hoping that some of the theory people will start working on this so that I can implement it for you later.
Did you ever look into delta state RDTs?
Did I look into delta state RDTs? I have seen the paper go by. I looked at it. Maybe I didn't read closely enough. I was like, this doesn't feel like it solves that problem. Like it felt like a reiteration of the stuff that we already have. There's a reading group reading this on the local first web dev next week. Did anybody already read it and can tell me if it solves that problem?
Yeah, I think that's more on the optimization side
of
how
what
do
I thought.
Manage a counter with missing deltas. They don't talk about the problem like how do you manage a text CRDT where you've omitted one of the deltas that tells you how to position future characters.
One thought I've had about this since Brooke is here is that I think this is like convergence CRDT thinking people, but we also will need cryptography people because we're like the Byzantine failure models where we're using like hashes to like show that we have consistency and coherence. Those hashes then encode some version of the information that we're now eliding. So something salt, this is where I'm out of my depth. Yes, content addressable stuff is just another way of like giving away the keys, yeah. Brooke, what do we do?
Yeah, I'd say also, I think if you solve this like cherry picking history hiding problem, it also addresses exact undo or selective undo and like reject changes. you could probably build those in at a lower level so you don't have to build it into each individual application.
So just to restate your question, how do I remove stuff from history and still preserve hashes?
If I have the full history of like an edit session that has some information I don't want to share with somebody else, and then they make edits on top of like the rebased version that doesn't have that, can we continue to collaborate where I have like a fuller history than other people, right? Like there's going to be different versions of the history. They're sharing some versions, I'm getting versions, like we might all have different levels of fidelity. Is there some way that we can maintain like this Byzantine fault tolerance properties that we have without leaking everything through side channels?
So the short answer is yes. So yeah, when we were doing the Rhizome work, we looked at this pretty closely. Like, how do I give, the comment you made earlier that latency and encryption are effectively the same thing, right? So you can have regions that only certain, or regions of the causal graph that only certain people can see, right? A metaphor for that is you take a blank node in the graph, and then you hang off of that. Here's a bunch of encrypted stuff or stuff that I'm not going to push over the wire. But then you can still say, well, I'm doing writes over that, but I can't see all of this stuff, right? So that's one way of doing it. To do compaction with this, you can basically keep a link, so the compacted state with a link to the previous compacted state, and then links to the head of the uncompacted thing. So you have the full history, the compacted state pointing at it.
Let's get a whiteboard later.
Yeah. And you don't have to make the entire history available, as long as it's stored somewhere that somebody can check. Yeah.
I guess this is a great time to leave you to lunch, because I think we're already 10 minutes past our time. So thank you everyone for staying, and thank you for the speaker.
Good afternoon, everyone. Would you slightly take your seats? Move slowly, you had a lot of food. Great. Yeah, thank you everyone for being here at the second or third, depending on how you count, session of the Programming Local First workshop. And we'll start with a great talk by Carlos already. So this was meant to lure you back from lunch. It seems it has worked. If everything's ready, then Carlos, the stage is yours.
Okay, thanks. So try to make this an overview so that we have enough time for a discussion session. So, okay, I'll try to see the slides from here. There's no mirroring coming on, so okay, but I think I can work from here. So is that okay now? Yes. Okay. So the talk's title is a question, and the answer is maybe. There are some solutions, but they're not 100% okay. And this is also a brief literature review where I'm going to show you several works. I will not be able to go into detail, but these works are kind of roads into answering these questions, so they might be interesting to see later on. So what's the connection from local first? So I guess the crowd here, we all want to go from client server to local first. We want the good properties of local first. I try to bring some from memory, so independence from network, faster response times, more control over data. So see, these are some of the nice things. But by moving out of client server, we also lose some things. So we no longer have the thin clients that they're just a presentation interface and a way to collect user actions. Client server is also good in terms of metadata. We have much lower metadata needs, so it simplifies. So I'm not saying that we go to client server, but we need to solve some of the problems by doing things local first. And also, I also noticed that upgrades are easier because if you have all the code in the server and you push it to the browser, it's very easy to do the upgrades. So, but we'll have to solve some problems. So, you all know from the CAP theorem that there is this tension between consistency and data availability. And in order to have high availability, we need to accommodate for divergence. And this is what we get also in local first, as we have seen in the previous talk. So disconnected clients can evolve their data independently and synchronize when possible. And we might have this fork join model where it's quite messy. But tracking divergent, okay, it's interesting, but it requires metadata. So I'll talk a bit about the impacts in terms of metadata. But how many clients are we talking about? So this is also important. So we might have millions of users, but we only have 3 or 4 interacting on the same state, okay? And in that case, we can kind of compartmentalize all these interactions, and our metadata growth will only grow to 4 or 5, the number of parties that are interacting. But we might have some applications where we need thousands or millions of users interacting. I tried to come up with some cases. So for instance, voting polls, where we want to accrue a lot of votes. Systems monitoring, if you are trying to see that observability, the behavior of the system, and do it in a kind of CRDT-based way. Social media, just collecting likes. Likes is just like collecting votes, but less important or even more important. And Wikipedia editing. So some pages have been updated by hundreds of users, and we might want to model that. So we might run into sessions where we have many parties that are iterating over the same data. So we have a problem here, is that metadata need is linear on the number of clients that are issuing the updates if they communicate directly, and we'll come to, that will help us later on. And okay, I'll be showing papers all the time. So this is a result from the 90s that tells you basically the same thing. So there is a linear relation between the number of actors interacting with the data and the metadata size, okay? So this is established. So now we might guess, okay, either we pay the price and we do it because we need to do it, or we try some workarounds. So the question is, are there workarounds? And there are some, and the talk will be about some of these workarounds. So impossibility results that are correct we cannot do anything about them. They are very useful and they are correct, so there's no way around. But if we can tweak a little bit the conditions, we often find a way to do different things, but we need to kind of change the system model that is underlying to the result. So one way to change it is to not focus on how many parties are doing the updates, but on the number of updates themselves. So we could collect something called a causal history. So you can imagine for each update, I can create a unique ID, and then we just keep sets of these unique IDs, and we compare these sets in order to track which data has diverged and needs to be synchronized back, okay? So just have these sets of random unique IDs. If the random ID is long enough, we don't have collision. That's the birthday paradox, and we can keep working with that. So by doing that, we build something called causal histories. I'm going to talk about 3 systems that kind of build more or less on top of this. The other way is if we restrict the communication topology. So if we get what was talked in the morning, like referees, points where we communicate to a given special party, we can kind of tweak and restrict the communication topology, because the result only holds if we are interacting from all to all, okay? So if we restrict a little bit that, we can improve a little bit the metadata cost. So I'm not sure if this is the oldest, but this is the oldest reference I know about of using kind of hashes to track what's happening in the system. So this is in the track that we don't care how many entities we have. We care about the updates themselves. So this system, this is a paper from 2003. I don't want you to read the whole of the abstract, but the idea is that, okay, it's like a version control system. So you are changing documents. This is before JIT, I suppose. You are changing the document, and then you track the hashes of the resulting document, and then they build a graph that is connecting all these hashes, and this is what is used to detect when things need to be reconciled. It has a good property that since they are hashing the content, if 2 different changes end up resulting in the same content, they can detect that, and you no longer need to. These things are called like coincidental equalities, if I recall. So this is the idea. Then, sorry. There were evolutions of like doing systems with hashes. One is here from Martin. But before that, you already have systems like Bitcoin where we have hash chains. So in this case, if I got the gist of Martin's proposal, so what we have is this for a direct is for a DAG, for the same properties for a DAG. Where does it differ from the previous system? Is that in hash histories, it was the hash of the content. Here you have the hash of kind of the update and the hashes of the things that preceded it. So you keep adding the hashes of the dependencies that you have together with the update, and you hash the thing together. And this way you get a system with the same properties that you get kind of in a blockchain, where you have this kind of self-certification of what is happening. So, but this is growing a lot of data, okay? This is a lot of data, but in some systems, you want to document what happened for auditing. This is all fine, but there's a huge metadata cost. So can we make these things smaller in terms of metadata? So we try to do a little bit of this in an MSc thesis. So the idea was the following. I'm going to have the abstract, but I'm not going to tell you in detail. But this is the gist of the idea. Like when we are comparing that, we might have parties that diverged a long time ago. So in order to compare data, we can look at these causal histories. Sometimes you call this a causal context. But if you are syncing very frequently, most of the causal context is in common between the parties. And if a party diverges for a long time and didn't sync back, probably you no longer want to incorporate those elements because they diverged from the system a long time ago. So we try to have a thing based on Bloom filters. It's a variant of Bloom filters that are kind of forgetting information all the time. So they only accurately track the most recent information. And the idea is that if you sync frequently, you might be able to just look at the most recent information to detect divergence, and then have a system that is not growing, not even with a number of updates in the system, like the prior one did that. Unfortunately, you no longer can have 100% accuracy. There is a trade-off. I don't think that the solution is perfect. There's a problem about merging Bloom filters if you have an open system where you don't know how many actors you have. So there's still research problems over here, but this might be a direction. So with this, I close the ones that are based on kind of probabilistic things and hashes. Now let's look at deterministic solutions. And I'm going to look at the two specific cases, that counters and that admin set. So I'm the unlucky person to be the first one to present a spec of a CRDT. So what do I want you to get from here? I'm not going into the depth of the math, but if you want to do a counter that works as CRDT in a given number of parties, it's very easy. Each party has its own counter, its own, how do you call it, single writer entry in the counter, and I keep updating my entry, and we collect the map with all the entries, and the end result is summing the image of the map, all the values in the map. Okay, this is very easy. What's the problem here is that we for any actor that tries to do something, we have one entry. So this is again linear on the number of actors. So what can we do about this? This is a problem. And so we did some work in 2017, even a little bit early because it took some time to publish. And it is possible to kind of do a multi-step protocol where I can register the account under a given identity so that I'm totally local first. I can operate without internet. But when I have connectivity, I will try to transfer this count to another party. You can think of it as kind of the special and the arbiter, okay? And you get rid of your own local data, and then we control the linear scalability problem. So we designed this system for like this can work for any number of tires. It's generic. But we thought about like, we have end clients over here. You have this could be your content distribution network with all those points that we have seen in the morning, where we have places that are important enough to have their own data center. And then we might have the root ones. So the things are migrating from here to here. The idea is that we register under the same replica ID. Then we don't have server affinity, so we can have fault tolerance in terms of servers. So we can try to be transferring to one server, then to assign to another one. But in the end, this is an atomic transfer where the thing will only end up in a given server. And once the clients know that the thing has been transferred, they can remove and forget all the data that they have. They just need one counter. So we don't even need to have one data item per server or per entity we interacted with. So this is a rather complex protocol. I'm not going to explain you, but you see that's a kind of three-way handshake where we are preparing to do the transfer. And the end, we have something over there that in the end will be transferred into the account in the server, and you kind of reset everything in the end, and you forget all the information about what you did during the transfer. So this is one approach for counters. Now, there is a very interesting recent one that was presented in PAPOC. Maybe some of you watched this presentation in this year's PAPOC. The authors choose not to publish the paper. Probably they're going to send to another venue. But I have some highlights of the paper over here. So what you can do is, if you depart from the previous approach, where you had this non-server affinity. So if you kind of crystallize the hierarchy that you have, you might be able to distribute each entry for the different nodes and then do some intelligent tricks that they do in the paper. So they form a binary tree, and then wherever you are, you have your local count, and you have the neighbor your child from your left, from the right, and your parent, and you combine everything so that you have only one entry per node, no longer n entries reflecting the number of nodes. And the algorithm is very simple. It looks something like this, okay? Just want you to see that what I have. So you have this state over here, and you have different merges depending on, you can merge to the left, to the right, and from your parent. And then when you are gossiping, you are basically sending to one size the sum of all the things you got from the other places, okay? So I'm sending to the right what I get from the left, from myself, and from a parent, and so forth, okay? And with this, you get a very interesting solution, but over a static topology. But this is one thing that we know how to do. Now, we did even a different thing in 2017 called borrow counters. It works for counters, probably not for the like. We have a difference between permanent nodes and transient nodes. In the permanent nodes, you create an entry that you will assign to the transient node. The transient node will do counts over there. you keep doing merges and receiving information. I don't have time to explain this right, I'm sorry. You keep updating, receiving information, and when the transit node is done, it will kind of crystallize what it's done. It will close its entry. And at that point, the permanent node, so B is transit, the permanent node can move this information over here to itself. So it's kind of similar to the initial system I told you about, but simpler to reason with. And this is, well, it's not being very used. I'm making some publicity with it. I think it's a very elegant design. Sorry that I'm one of the authors, but I was not the main author. It was one of the students, so I can really say that. This was not my idea. And it's really simple. And you can, again, tying with the discussion in the morning, you can use these things, these points where you have a referee to kind of simplify a lot the system and to work around the impossibility results. Now, going for sets, so I'm not going to explain this thing, but the magic between observer remote set or admin set is that each time you are putting an element, you need to assign it a unique tag. Okay? Normally we call this thing a dot. So you need to keep generating these unique tags. And if you generate these unique tags, you can generate it very simply by having the node ID and a grow-only counter that you get from the node ID. So you have this causal context over here. And if I'm generating the next one in node A, since in A I already have generated A1 and A2, now I need to generate A3. Again, what is the problem? We are linear on the number of nodes that are doing these kind of things, okay? So how can we circumvent this problem? So this is an even more complex spec that I'm not going to focus in detail. So what is the problem with scaling causal certainty? So each active item is paired with a tag dot, okay? And the causal context, that thing over here, that collects all the things that I've seen in my local CRDT is linear on the number of replicas that were active and that communicated with me. Okay, I might not have known about it, but if I got information from them, it's linear with them. So we have this is like ongoing work. This is already working for a given setting. It was presented at the local conference. And what we try to do is the same trick that we did for counters, we do it for causal CRDT. So we did it for admin sets, and this also works for multi-value registers and for remove win sets, although we don't have it working. So the idea is kind of this. So we add elements under the replica ID tags. So we have our local ID that we control. We can use it to be local first and add elements. Then, at some point, we freeze it, and we try to migrate to one of several servers. But while it is frozen, I can still keep adding again on the other state that I have that is not frozen. So we never compromise availability, okay? Even for adds and deletes. Even in the process of migrating to I keep calling it the referee, I'm always available. I can always do operations, but I register on a different part of the state. And then when the server incorporates new tags, it will create translation pairs. It's basically saying that what was known as A3, now in my server is like S34. So we while we were growing horizontally in the number of different nodes, now at the server side, we grow vertically because we are creating more numbers for all the clients that we are serving to, okay? So this is kind of the intuition. When I get to see the translation, I can locally forget the local tags. So I get rid of the local tags. And this is something unreadable that shows all the process. From here, and I want to give time for discussion, I don't want to see all the detail, but I just wanted to see that I'm adding stuff. And while I'm in the process of transferring, I'm also allowed to remove information. And then when I'm removing, I'm doing stuff on my local tags. But when I see the translation, I can reinterpret the removal based on the translation that I receive it, and in the end, everything gets okay. Okay, so we have a running implementation in Rust, and we compare the runs with a standard addable win set. So addable win set, if we have this number of a lot of servers, like it grows a lot. So this run here, we are doing operations on a standard set. Here we stop doing operations, but then we keep synchronizing. So this lag there's a little bit of time where the system is getting to know all the other things that it didn't knew from the other replicas. This is why it still grows a little bit. But with this protocol, we end up doing all the transfers. We get rid of the metadata, and it's much more compact. So I didn't want you to show you work that is solving the whole of the problem. I want you to see that there is a problem here. If we have many parties interacting, there are some ways of trying to address it, and I'm sure there are better ways that still have to be found. So now we have time for questions. I have 2 possible questions that I'm already making if you are short of questions for the moment. So thank you.
Thank you, Carlos. That was very inspiring. I'm asking myself, also given what we discussed before lunch, so if you have an ensemble of replicas of a database, you use some protocol like Paxos or Raft to pick a leader and then make decisions that are consistent. Now, we don't do that in local first applications because we don't want this leader somehow. Now, it seems to me that picking a leader for some things, like topic-based here, is still the way to go. How do you see this?
I think it's even better because you don't need to agree on the leader that you are picking. So these 2 protocols that I've shown, the one for state and the scalable eventually consistent counters, you don't need to have server affinity. So you have several potential servers, and you can start interacting with them. And at some point, your interaction with that server will create some placeholder there that you will know about, and that you will be able to transfer information to that server. But at any point, do you need to coordinate the choosing of the leader? So it's always a kind of, actually the communication protocol that we run is kind of CRDT-based protocol, where I show my state to the other party. You see my state, you evolve your state, you show your state back. So there's no leader election in the process. So
that's awesome.
Yeah, so that works, at least for counters. Walter?
So what you call a referee is sort of a coordination point.
It's a coordination point. Yeah, I was trying to connect with the morning talk.
Yeah. That will eventually lead to loss of availability if this referee doesn't synchronize the operations or doesn't make any decision to the world.
So it depends. So for the counters, when we do the let me say the other one. No, I can go to the counters. So only when I see, I'm always resetting my local information when I see when I see that this server that I'm communicating with reflected the data in its own state. Okay, only at that point. And at that point, I can get a copy of the data from the server. So for instance, for counts, I'm moving from the count under my ID to the count under the server. And the server will increment his own entry. Only when I see that, at the same time, I'm storing a local copy of the server's entry with myself, and I'm resetting my old information. So I never lose the data that I accepted from my user.
Yeah, but you rely on the referee accepting your operations to be able to synchronize them with the world.
But I don't have affinity. Mm-hmm. So if it's not communicating, I can start interaction with another one.
Okay, that's the good point.
Is that idempotent? You can interact with 2?
Sorry. Yeah, so the whole protocol is idempotent. So the whole protocol is, we don't have a name for this. This is like almost like CRDT protocols. I'm always showing the state. So all this protocol is immune to reordering, data loss, and data duplication in any order.
Great.
Okay. So it's kind of, actually, the consensus protocols, I think they also have a little bit of that underneath, okay? Sure. So in order to be reliant to the network errors.
So it's been interesting to see you run through almost like a zoo of algorithms for optimization. Mm-hmm. And I'm curious how much you think about choosing these algorithms in the context of particular applications, or certain applications and the topologies of those applications that would be tailored towards certain algorithms versus others, and how you think about parameterizing these algorithms and almost like parameterizing the choice between these algorithms in a way that's accessible for application developers.
Yeah. So these algorithms, some of those, especially the transfer ones, are very complex. So there's some parameterization based on the system model. So if you go, okay, the hard way, you go and read the paper, see the system model. If your system matches the system model, you know which one. So I think, for instance, the tree-based one with a fixed tree is very interesting, but like unless you put more functionality for the capacity to rearrange the tree, it's going to be brittle probably. I'm thinking in background that there is a very nice protocol also from some other colleagues from Lisbon. It's called the Plum Tree Protocol that is used in industry also. It's and where they are always trying to rebuild a tree, but they fall back to a graph if there is any problem. So they're always operating on a graph and rebuilding a tree if things break. So it might be possible, this is a very like soft conjecture, to combine that topology idea with things like the Plum Tree Protocol. So that is one way to go. On these other classes of protocols, they already allow multi-tier, no affinity, but you still have some things that you need to calibrate, like how many servers you want to have in each tier. And there are no, like there are reference implementations, but there are no one did a usable thing for the industry yet. So it's still an open terrain.
So is that why you couldn't have everyone be a leader because you have only a fixed amount of servers, or what else is stopping just everyone becoming a leader and being a...
So what you are trying to do is, when you are rewriting IDs, you want to move from a very big membership into a smaller membership, okay? So this is the idea of having an hierarchy. And these hierarchies happen in all large-scale systems. Even for, like when people build like Bitcoin, it's like everyone is going to run their own peer, but in the end, you have all these places that run it for you.
In the end, it's a centralized system, yes?
Yeah.
But that's a different topic?
But yeah, but again, yeah, I'm no fan of these things, but...
I do.
But no, but what I like to say is that I think that's hierarchies emerge when you are dealing with complexity in society, like in cities, everything.
So if I got you
so you need a little bit of both.
So if I got you correctly, basically, if everyone were their own leader, you couldn't compress the IDs anymore. But,
yes,
but the protocol would still work just without compression.
So, yeah. So one thing that I forgot to mention is, so for instance, in the protocol that we have, it's not totally local first in one thing, because we only deal with interaction from the client to one of many possible servers in the upper tier. And talking with Martin, he raised the thing that, okay, but we also want to be able to cooperate within the same room. So we are trying to improve it, work on that thing. But for that, basically, you need to, some point, to expand the number of IDs that you see, your local collaborators. But then you need to have one doing some kind of garbage collection so that it will get rid of all those IDs and replace them from a upper tier ID so that you are not going to pollute forever the namespace in the system. So that is kind of the idea.
But could you like select for a room locally just a leader? Would that work?
That will work, and these things happens in like cluster heads and things like that in ad hoc networks.
Further, yeah.
So in the setting where you have a large number of clients and a smaller number of servers, I worry that since you've got a large number of clients, some of them might not be following the protocol correctly. And so you gave this example of social media where it's counting likes and what is to stop me writing a client that adds 10,000 likes to my own post in order to boost things. Do you have any thoughts on that sort of Byzantine behavior, how that might factor into these algorithms?
Yeah. So I totally agree that this is a very important concern, especially because we have lots of clients on those circumstances. We didn't do anything about it. And I recall when I was playing with the Nutella network that there was a lot of attacks being done by people just fiddling with the code and saying that they had content that they didn't have and things like that. So it's a very important concern that we haven't dealt with, and I don't really know the total implications of dealing with that.
Yeah, the old peer-to-peer file sharing networks probably have a ton of lessons now that you mention it. But that was BitTorrent's thing, right? That was why BitTorrent won, is they started self-signing all the data. Right, so you couldn't spoof because you had to have the data. I mean, you could just say you had things you didn't, but you couldn't say you had something and send something else because they'd catch you.
So
that's the Merkle trees.
Yeah.
Yeah.
So some thoughts I have on that, not too long, is like for CRDT things, is that it's very hard to constrain. So you can do something Byzantine, say, on the server side, where you have like a Byzantine majority on the server side. If you trust on the clients and they have like keys that you trust, you can kind of build these protocols for the server side. One thing that is very hard is if you don't trust the clients, what are you going to do? Because how do you constrain how much they can kind of ruin the system? So you need to have kind of provenance of what any client did so that you can then remove it. And I think there's works going in that direction.
Sorry, I don't see. Oh, yeah, this is UCAN, right? Yeah.
Yeah. Thanks.
It's a perfect segue. So this thing I mentioned in the morning after somebody's talk of, I made passing reference to submarine sealing. It's actually pretty similar because we have a rooted authority that's delegating. You have the whole provenance, and it basically gets, the whole certificate chain gets rolled up. And so as long as somebody has more capability than you, they can basically take your rights under their authority, but not vice versa. So you have scarcity now, where it rolls up to the top. So I'm very much looking forward to reading this paper because there might be some interesting stuff for us to do.
Okay, so yeah, I understand the description. So the other thing I've seen is the systems where you need to have another majority to certify each update. So it's a different approach, but yours means I think it looks even more controllable because you already have that hierarchy built in, and it's not just a majority that will accept that given client operation.
Yeah, well, it's two things. You already have this hierarchy, and somebody higher up in this chain must have equal or more authority than you do. So there's a higher degree of trust as you roll up.
Yeah.
Great.
Okay.
I think this puts out of time for questions.
Okay.
Thank you very much for your great
Okay,
talk.
thank you. Just the last thing, it was really great to see this mix of academia and industry because that's the way to tell people in academia where we should focus on, and I think this is very, very productive. Thank you for putting up this conference again. Yeah. No. Yeah.
Speaking of not over yet, this is the first of the 6 half talks. So we asked these 2 wonderful people from Actix to put their 2 submissions together into a single talk. I'm super excited to see what they came up with because this is kind of the first submission I didn't review yet. So, which means it will be just that much better.
So let's see.
Are we set up?
I didn't try that before.
It's visible on the
no, it's already
remote yet. It's not on the big screen.
It's just not showing it yet, so you can create the presenter view.
Yeah, but I have. Wait a second.
Technical problems. Welcome to computer science, where nothing ever works reliably. We're working on it. Trademark.
Okay. Okay.
So now you can just put the other window there.
Oh, there's huge lag. That's what you meant, right?
Yeah.
Yeah.
I'm going to.
Okay. This looks like a talk.
This one works. Okay.
Stage is yours. Please go ahead.
Quick reset just so you can get the proper time.
Okay. So yeah, thanks for having us here. It's a great honor to speak to you all. I remember listening in last year, and this year I wanted to be somehow in person, so that's so much better. Yeah, I'm Roland Kuhn, founder and CTO of Actix. This is José Duarte. He's a distributed systems engineer, and yeah, we'll talk about what we implemented at Actix, roughly, just very briefly, but then more about lessons learned. So people have built applications using the model that we implemented, and some things worked, some didn't. Noteworthy here is we approached the local first angle from a different side than was presented so far. So for us, it was not like, oh, there are CRDTs and we can have data agency and ownership. This is not where we came from. So our background is we need to construct systems that just never stop. And the reason is our customers make software for factories and not for the back office, which is totally fine if you shut it down for an hour or two. No, it's for the coordination between what happens on the shop floor, so between the machines and the material and the persons manufacturing actual things in actual factories. So this is not only production code, it's also for real production. And just for context, because many people don't know it, factories are not operating on high margins. So if you, so typically like 2–3% margin that a factory has for turning raw materials and energy and work into a finished product. So if you stop the factory for 3% of the time because, for example, a DSL line has 97% uptime, then you're now making a loss and you can shut down your factory. So you cannot use IT on a factory shop floor without answering the question, how do we make it so that it never stops? Then the other thing is, we went to factories and wanted to roll out software, and software needs to run on computers. So the obvious question was, where do we put them? So to cut things short, we decided we want to roll something out without involving factory IT, because they are really picky and really slow and they just get in the way. So just put gateways like Raspberry Pis on the machines, give people tablets and let them use their phones, and so on, and then use a Wi-Fi. So we can usually get a Wi-Fi in these places and then tell people to not connect it to anywhere, and they are fine with that. So if we have this, how can we make a system work? So we want to roll out into a factory just giving them devices, and they are supposed to do their computations locally because there is no connection to the cloud, because we cannot afford it due to reliability. And we want to have collaboration between them, because a factory is inherently a very collaborative organism. Yeah? So the goods, the raw materials move through a certain step of workstations, production steps, and so on. And lots of people doing things locally and then collaborating with other people nearby to move the process further along and eventually finish the product. So this is where we came from. This is the context. Then we stood in the office at some point and tried to figure out how to build this, and we came up with a key idea how we want to do this. So single writer principle is the only thing that we could think of how we can make something that you can always write to. Yeah? If you're the single writer to something, you can always write. That's totally cool. So we call them events because we believe in domain-driven design and so on, not delta state CRDT operations that are opaque. We give semantic meaning to things. So, and we add these events to local logs. A node can write multiple slices if it wants. Then these log slices are replicated between the nodes. So now at a receiving node, I might have 17 slices. Now, how to make sense of this? I need to merge these logs. And for that, we are using a coordination-free, totally deterministic order based on Lampert clocks and cryptographic node IDs. So we have a merge operation that is deterministic. Now we have a resulting single log, and now we need to make sense of that. And this is the question of a programming model. So how do we interpret these merged logs? Now, what we are getting at here is, since we cannot afford to have consensus because that makes us unavailable at times, the best thing that we can aim for is eventual consensus. So once everything is disseminated, all is said and done, everybody should come to the same conclusion about what the result should be. This is the best we can hope for. There's a link down there, archive number about a paper at eCoop this year, where you can read up the full theory. I will just give you a tiny brief overview. So what we do is we let people design protocols by specifying a global type. And this global type is then projected into local types, just as it normally is for session types, session typing systems. And then we have the local agents, and we can check whether they conform to the types that came out of the projections. So we have a proven theory that has some properties like deadlock freedom, eventual consensus, and so on. We have implemented a type checker that you can, in Haskell and Rust. Rust compiling to WASM, so you can use the type checker in TypeScript using this machine check module. And then there is the machine runner library, which uses Actix. This is an open source product for shipping these logs around. You can use this to write down your state machines, run them, and get your state of what you would normally call documents. I call them workflows. Yeah, so because in the end, what we're doing here is not just everybody can add text to a document and all edits are accepted. In a factory, the point is sometimes also coordination. Only one should do something. And yeah, I can get into the details because I want to talk a bit more about this slide. So you're not supposed to read this slide. This is mostly a reminder for myself so that I can touch upon the points, and you can let it sink in and ask questions later if you have more points that you can think of. So when we asked our partners or customers about their experiences using this system, these were their answers, consolidated set of their answers. The first one is people are still very much used to talking to a central database, which gives them this godlike overview where I can see everything. I can make the rules. I know that the rules will be followed because I believe that Oracle is correct, for example. But they don't have that here. So they need to think about how would people solve it if they are not omniscient. So people who actually need to talk to each other to figure out what the other person has done. It's possible. If you stay in this metaphor, people get it, but it takes a bit. It's a shift of mindset. Once it's done, they really like it. So the second one is similar. This machine runner presents a very restrictive interface. You use it in TypeScript, but you need to write down your state machine explicitly as a state machine. There is another approach that we might want to try, which is done by another company in a different context called Temporal. They use async await for basically a very similar purpose. So it should be possible to use other language features to make the presentation different. But still, it's rather restrictive, and the reason is that we want to know exactly the shape of the communication so that we can check whether it's correct. That's the end goal of it. So at first it feels restrictive, but it makes sense later because in the third line, what we focused on is this graphical representation. I showed you these state machine graphs for a reason, because people in factories think like that. When you ask them to explain the process to you, they will start drawing on a whiteboard, and it looks something like that. So they can immediately compare the programming diagrams with their own diagrams and then see whether they match. And sometimes you make this protocol design, you make the projection, you implement the machines, and then the programmer says, hey, this doesn't work. There's an event missing here because otherwise it wouldn't do what we want. It doesn't have the right data. And then this loop runs and runs again and finds design bugs in the production processes of a factory. So we've actually seen that, which is pretty cool. Then, of course, you can do this machine check automatically, and that is very nice for productivity. But there are some challenges. So you can always get updates from the network. And if you have asynchronous processes running in your application and you have asynchronously incoming events from the network, you might get into situations where you don't really know which update is the one that you want to deal with right now. So you start an async process and it gets invalidated, for example, because something changed. Also, there is a problem not so much for the programmer, but for the users of this system. So they get this tablet, and if it's not connected to anything, they make changes, and then they ask themselves, why does the dashboard not update? So you need to figure out the UX to make this work. Yeah, I'm stealing too much time, so let's discuss the last ones offline.
Okay. So for my part of the presentation will be, in contrast to Roland's proven theory, this is pretty much vaporware. and I'm looking for feedback, ideas, etc. So as for software evolution, we have like 2 fields. On the data end, we can use Cambria to translate data between different versions of schemas, etc. But on the behavior end, we don't really have that. And in Actic's case, we cannot ensure that each participant has the same version. We have a swarm system, and if one participant does not like to cooperate as a totally different version, the whole system cannot, it's not progress, but the cooperation part falls apart. So yeah, and since Actic's peers are now state machines, the whole question I pose is, so how can we make them cooperate despite their differences? So as I said, on the data end, for example, we change the state names, etc. We can use Cambria. But on the behavior end, so if we want to add a state, as we have here, the 0.5, we need to add new labels, new edges, I mean, and make everything work. So here, my proposal is we do versions instead, because if we just have one label, we will be having not a deterministic machine, but a non-deterministic one. And so the labels with the version stops those conflicts. So let's run through a trace. So we start both versions, V1 and V2. I forgot to tell you, V2 and so on, like all know the previous versions of the state machine. So the state machine doesn't get edges taken off. So we start at state 0, we do turn on V2. Machine 1 does not progress, machine 2 progresses. So we do that again, and we now have an inconsistency because the old machine is still at 0, the new machine is in 1, and they both know the same, they both know that state, so we have an inconsistent state for the system. If we instead replace the V1 in the last edge with V2, the V2 with V1 in the last edge, we now get the same transition in the middle, but when we do the last one, they both converge to the same state. So yeah, this is a really brief demo. And as for the next steps, we still need to figure out a bunch of rules, formalize everything, build a proof of concept, and profit, I guess. So yeah, we are now open for questions.
Thank you.
Hi, this is very interesting. Yesterday at the live workshop, we had a paper about the schema change problem, and we posed exactly this problem as one of the examples, and you have an approach to solving it. So I suggest that you get in touch with us and submit your solution. Thank you.
Yeah, we shall do that. Thanks.
I'm very excited about your talk because it sounds like the strategy you're using is almost exactly the same strategy that I use for Muse for the application I'm working on, in terms of each device has its own logs. It can eventually get those stuff from everybody else, and everybody gets eventual consistency, but can happily operate on its own. I'm curious, in terms of the schema change problem, if you have run into schema changes that are not backwards compatible, whereas in that case you were adding a state 0.5 where V2's start state and end state both had a valid state in V1 as well. Have you ever come across a state that you were not able to represent in a previous version that was entirely new, so it completely diverged as opposed to came back together?
Sure. So as far as we encountered or not, the simple answer is no, because this is still like idea and vaporware. But I'm available to discuss a more detailed approach, because this I also have like a paper, if you want to call it, of sorts, with all the ideas I have. But yeah, like I couldn't put everything here in a 5-minute demo. So yeah.
There's one anecdote I can relate to this. That was long before he joined. We were building software for a factory. They were tracking the work that was being done to gain transparency and then use that to optimize the processes. And there was a change in the sub-process. So the big sequence of production steps was the same, but how an individual starts and stops working, there was a change. Something about the break being handled differently. And there, we didn't have this work yet. We did all of it manually, and it was not possible. So we had to version the whole thing and switch it all at once. Because we were not able to figure out how to make it run side by side. So I guess there are such cases where it just doesn't work.
That's been my experience too. I just went through a terrible change the world. That's been my experience too. Most of the time, we've been able to find ways where the two versions coexist gracefully. But not all of the time, and just recently had to kind of stop the world, make sure everyone migrates into the new world, and that's it. Can you be specific? So it was actually in the Muse case, it was for authorization, where in the original synchronization, it was only a single user. And so it might be multiple devices for that single user in a local first, but it was a single person. Whereas in the new world, a second user or a third user on the team might come in, have permission to make edits, and then be removed, and their previous edits need to remain, but future edits need to not remain. And so that was the problem for us in terms of needing that schema change, where version 1 did not have that ability to put up a wall and block a client. But we needed to put up a wall to block a client and be able to communicate when that wall should or should not be blocked in time.
Could you pass the microphone?
So the thing that's different than the Cambria model, and this is something that didn't come up in Jonathan's schema change here, so I think I'm going to try and generalize what you're saying, which is that the treatment of the data structurally was determined by the values in the data. Whereas in normal schema migrations, you like rename a column, everything that went in the one column goes in the other column. But here, this is a form of migration where how you treat the data depends on the contents of the data, not the location or the structure.
Yes, because we ended up adding data about adding data. Yes, because we ended up kind of adding data about authorization, and that authorization affects how you look at other data. Essentially is the way that it operates. It's a generalization, but yes.
Okay, yeah, really exciting stuff. I'm also very interested in verifying local first software, and one thing I've been thinking about a lot is also like, could you verify different versions of the same software against each other and reason about their interactions, which is pretty much what you're suggesting here. So I think that's a really cool idea. And I mean, coming from these behavioral graphs, you have a lot of information there, right? You basically know how each version would act in which case, so you can reason about their interactions, which is, yeah, pretty much what you're suggesting, I guess. Yeah, so not so much of a question, more of a comment. Really, really cool work. I'd love to discuss the details offline later.
Thank you very much. There's one link here. So the theoretical model has this notion of subscription. So not everybody sees all the events. We haven't done that yet, but your question triggered an interesting thought that we might use this feature to try to verify this, because we have already well-formedness conditions for that interaction, so we could see whether they translate into well-formedness conditions on the evolution. Yeah. That's yeah, thanks.
I have a slightly related question, which is, so you said basically everything on like the ground level, you do everything is eventually consistent, or eventual consensus as you called it. Yeah. But then you also said you do coordination sometimes where things have to coordinate. Could you talk a little bit about that? Because I find it a super interesting topic.
Yeah, okay, so I think we have 5 minutes. The example here that fits well into factories is the logistics one. So let's say a machine wants some new material, and you have logistics fleets of 10 robots. And you don't want to have a central point for coordinating the logistics fleet. So these 10 AGVs, so these ground vehicles with an arm and a tray and whatever, so they drive around the factory. Now, this has been actually implemented by a partner of ours and is being rolled out in a factory, that they all see the request from the machine as an event, and then they place bids by emitting other events. Everybody sees the other events and so on. This is not a Byzantine system, right? So every node belongs to the factory. We are not considering malicious actors. So all run the same optimization process and come to the conclusion like node 5 should do it. Then emit an event, and then node 5 does it. Now, what happens during a partition? Because we are not using consensus, so it could be that node 7 is separated, got the bids, but not all of them, and didn't get the decision, makes up its own decision, says, oh, it's me. So node 5 and 7 both start driving, and once they reach the storage, they will come close to each other and hopefully will be able to sync their logs. And then node 7 should see, okay, it wasn't actually me. I need to run a compensating action to abort this mission. This is how a factory prefers it, because they prefer that 2 start driving instead of 0 starting driving.
So you don't really do consensus first, you kind of do then compensation?
Yes, it's a compensation model, yes.
Okay.
What's the Helland paper? Promises, apologies.
Yes.
Does anyone remember the title?
Yeah.
But the idea is, like, at scale, ultimately, you can't really always coordinate. So at some point, you're just going to have to do your best, and then you end up reconciling later.
Yeah, that was a very influential paper, what concerns me, at least.
I was talking to one of your colleague, and he said that another problem was random electromagnetic interference that disables any wireless internet. Is it your case as well?
So we have one case, for example, where this was also an early customer. They are using the system inside a warehouse with lots of steel drums having lots of different materials inside, and coverage is very spotty. So here, the normal local first CIDT-based approach would also work. But I mean, this is clearly the system that we need to deal with this. So we have sporadic connectivity and sporadic synchronization, and it just works. In factories, this is an actual problem. In my home, it's only a problem in one room, and I have yet to figure out why.
One more question, which is a bit about the programming side, right? Because I see you sell software to companies, so maybe you don't want that to be easy to program.
No, we do.
You do, for you. But are there kind of like, for you, or let me put it like this, what open problems do you still see? Like, what are the challenges you face? I mean, Jose, you talked a little bit about things you're working on, but maybe you can elaborate on that a little bit.
Yeah. So there were 3 more that I didn't talk about because time was up. Just forgetting compensating actions is one of them, for example, or forgetting to emit an event. And I mean, our theory is deadlock free, but if you program it wrong, then yeah, you get deadlocks.
So in the sense that you have a couple of assumptions that that programmers should be reminded of, like things that they need to do for the system to work correctly. It's good insight.
I was wondering if you had size constraints on the logs that are passed between devices, and so if a device is offline for long enough, can it run out of space to write its own log? And is that a problem you're concerned with, or how have you solved that?
Yeah, that's a pertinent question that we have not yet answered in the way I would like. So currently our devices all have at least 20 gigabytes of memory, and that's enough for, so it's like a machine doesn't do 1,000 things per second. We're not dealing with those events. We're dealing with human scale events. And 1 gigabyte gets you a lot of clicks covered. Also with some tricks, they compress really well. So currently we can solve it by replicating everything everywhere. But if you wanted to roll this out to other use cases, you really need selective replication. And that's the next step, obviously.
we have any final questions? Otherwise, we can already ask the next speakers to set up. And in the meantime,
no next speaker.
No next speaker. Thank you very much for the great talk. And one announcement I forgot. So for those of you who know about the PLF lunch, we will meet at 6:30 at the lobby. For those of you who don't know about it, sorry, it's booked out. Dinner. That's a word. Food.
Do you have an adapter?
No. Dinner.
Does anyone have an HDMI USB-C adapter?
And if you, for some reason, can't participate in the dinner, let Walter know. I think we have one already. Are we good? So everything's good. So this is the second of the 6 half talks. So again, a duo, and the stage is yours. Just go ahead.
There are display settings, I guess. Okay. Oh wow, I can't see it here. Where's my cursor? Yeah. Am I ready to go? No, I think we're still.
We need to fix the aspect ratio. Any second now. We have very competent volunteers. Great.
Okay.
Thank you. Now the stage is yours.
Okay, today we're going to present some low-level details of CRDTs. In this work, we extend out-merge with undo, redo, and move operation. So this work was done by Leo Steven, Martin Klemben, and me. I will talk about the move operation, and Leo Steven will do the follows. I don't know how to switch it. Okay. So to make sure that everybody is on the same page, I will talk briefly about auto-merge. So auto-merge is operation-based CRDT, and it exposes JSON document API. It allows you to collaboratively update your local JavaScript object without introducing any conflicts. And we try to make the developers' life easier. We extend auto-merge with move, undo, and redo operations, and I will explain what is move operation. So actually, it has a very straightforward semantics. It allows you to move any element from any location to another in a JSON document. So why do we need move operation? Actually, it's everywhere. If you're developing distributed file system, it is very common for a user to move a directory. And also, if you're developing a collaborative to-do list, you might want to provide the ability for users to reorder tasks. And also, in the collaborative drawing tools, we move layers up and down, and so on. So it is a feature that a lot of developers found useful and wanted for a long time. But to my knowledge, there is no fully featured CRDT library supporting this feature. So why could this happen? There must be some reason behind it. The reason is it is too hard to implement move operations. And why is it hard? Just let me give you an example here. Here we have initial state of a document tree that we have 3 children under root, which are A and B and C objects. And on replica 1, we move B to be a child of A, while on replica 2, we move B to be a child of C. And then we merge them together. What kind of result would you expect? So the first result is duplicates. If you delete and reinsert B object, then it will easily cause duplicates, which is apparently not what we wanted. And also, we can also reset the state to the prior state, which is also not a desired semantics. So this is our expected result. One of the move operations win over the other, or this one, because we actually don't care about which move operations wins, but we actually, the important thing is to make sure that every replica makes the same decision. They converge to the same state. And here is another example. We have A and B to be children of root. On replica 1, we move B to be a child of A. And on replica 2, we move A to be a child of B. And when you merge them together, if you don't take care of it, it very easily causes the cycle, which apparently breaks the property of JSON document. And also, if you don't want to introduce the cycle, you can duplicate it, but it's also not what we want to be. So what we want is one of the move operation wins over the other, just like before, or result D. Either one will be okay, just make sure that every replica converges to the same state. So to make sure that the good result happen, we define a move operation to be valid if and only if it does not introduce any cycle. And also, there is no concurrent move operation with a greater ID that moves the same element. So the second condition is to ensure that there is no duplicate. So how can we compute the validity of move operations? Here is a very naive approach. Whenever an operation is added to the document, we reapply all the operation in ascending ID order and check the validity of each operation. So if an operation introduces a cycle, then it is valid. It is invalid. And if an operation is valid, then all the operations that move the same element with lower IDs are invalid. Here is an example of this algorithm. So initially, we have a document tree like this. It is set up with 3 make operations. On replica 1, we move B to be a child of C. And on replica 2, we move B to A, followed by that we move C to B. All the operations are valid in local device because they does not introduce any cycle nor duplicates. But when we merge them together, we need to recheck the validity of operations. Here is the operations in ascending ID order. So we reply all the operations from the beginning to the end. Firstly, make A will create a object under root and make B C. And then we move B to be a child of A. This move operation does not introduce any cycle, so it is valid. And then we move B to C. It also does not introduce any cycle, so it is valid again. But we move B twice, so the previous move operation becomes invalid. And finally, we move C to be a child of B. It introduces a cycle, so it is also not valid. And here's the result of the algorithm. So we can ensure that all the replicas converge to the same state, that A and C are children of root, and B is the child of C. But this is rather inefficient, because every time we apply a new operation, we actually need to traverse all the operations in the document. So we can actually optimize this method by the following approaches. So whenever adding a new operation, the process of the reapplying operations with lower ID actually remains the same as before. So we don't need to reapply those operations. All we need to do is just revert all the operations with greater ID and apply the new operation, check its validity, and followed by that, we reapply all the reverted operation in ascending ID order and update the validity. And here is the same example I used before. So before replica 2 receives the new operation from replica 1, all the operations are valid. And after replica 2 receives the new operation from replica 1, we insert it, but now the validity of move B to C is unknown. So we need to revert move C to B, which gets the document tree like this. And then we apply move B to C. So move B to C is valid because it does not introduce any cycle, but it will make the moving B to A to be invalid. And finally, we move C to be a child of B. Here, move C to B introduces a cycle, so it is invalid. And you can see here, we actually get the same result as before by just reverting and reapplying a few operations. And given if you're developing applications that are exchanging operations very frequently, then actually there are only a few operations need to be traversed. But also we have some further optimization. And the first one is bulk updating. So if two actors are running offline, and when they become online, they merge together, you actually don't need to run this revert, apply, reapply for each operation. You can run it for a batch of new operations, so we can amortize the cost of this method. And second one is checkpoint. We can run this revert, apply, reapply since the nearest the checkpoint, so we don't actually need to revert so many operations. And the last one is that we can avoid reverting and reapplying non-move operations because they are always valid. This one is a little bit tricky. If you're interested, you can just refer my paper. I will attach it in the end. And here's the result. This is a prototype implementation of the move operations I mentioned before. You can see here it actually takes about 100 milliseconds for two actors with 10,000 operations diverged to merge. So I think it's an acceptable cost. So here's the undo and redo part. I will hand it over to Liu.
Yeah, thanks, Liangun. Also, hello from my side. I'm going to talk a little about undo and redo. And to start motivating the topic of undo and redo, we first look at an example. And here, because the reason for that is in a collaborative environment with multiple users, the semantics of undo and redo quickly are not so clear anymore as you might think. So to start this, I've depicted two rectangles here, and each store a color in a replicated register, respectively. And Alice and Bob are going to make a sequence of edits over this. And initially, they're both initialized to be black, as you can see here. And to make it more convincing, later on, you can picture that the upper rectangle is on a slide only Alice can see, and the lower one is on a slide only Bob can see. And now we do our first edit. Alice does a set operation, colors the upper one to be red. Then Bob's taking turn and coloring the lower one on his slide to be green. And then A is undoing something, and I guess that's nothing we should argue about, and it's pretty clear that we revert to the state prior to A's coloring to be red and turn it black, and we leave Bob's edit at the bottom untouched. And then once we redo, we restore to the state prior to Alice's undo, and I think we all agree on this, and this is pretty good so far. But now let's turn to this example where we squish these two registers into one and then have the same sequence of operations applied on top of it. So initially it's black again. Here comes Alice's change, turning it red. Here comes Bob change, turning it green. And then A is undoing. What should happen? And we argue that it should turn black again for consistency reasons with the two replica register case. And if A redoes, also for consistency reasons with the other case we've seen earlier, it should turn green again, because then it matches the state prior to the corresponding undo. Yeah, I see a question?
Clarifying question.
Yeah.
Is this, there's full visibility, there's no concurrency in like A and B here?
Exactly, so there's no concurrency involved at this point in time. It's just a sequence of operations. They're synced immediately, and we already have this kind of semantics different here. You might think that this is kind of arbitrary, but we did a little survey, and you see a bunch of logos here, and you're probably familiar with all of them. And interestingly, they all implement the semantics we've just shown here. That so if A is undoing, it's skipping Bob's green coloring in between. Well, actually, I lied to you. Miro's taking a shortcut. So whenever there's a remote operation that is received, Alice's option to do an undo is basically rejected. So this operation sequence is not happening in Miro boards. So we don't want to use this, but you can see that in practice people are taking shortcuts. You might have wondered by now, why am I talking about just a single replicated register if auto merge is a JSON CRDT? And the reason for that is we can view a JSON CRDT like the following. So you see a little toy JSON document there at the bottom. And the reason why I reduced the scope to just one replicated register is that you can basically consider every entry in a map or every element in a list as a replicated register, as you can see depicted here. So we've developed a little algorithm which implements the semantics I've introduced to you. And here I'm going to illustrate just some edge cases you have to consider when you have a multi-valued register which stores conflicts in the case of concurrency. And I will introduce you some notation. So we are just considering the set of operations happening over this multi-valued register. You can always find the current state of the register given the operations in the top left. And each node depicts an operation. And there's also black edges which basically indicate which operation overrides which other one. So initially, Alice sets it to black. And of course, the register state is black too. And then here's the first time some concurrency. So Alice decides, hey, I want to override black and to set it to red. Whereas Bob decides, I want to override black with green. And upon syncing later on with a multi-valued register, it's just important that they both replicas converge to the same result. So we should store the conflicting siblings. And the result would be that the register carries both green and red. Alice later on decides to override this. And this is what we call a merge op in auto merge, because it's replacing the conflicts with just one value and reducing it then basically to just the register exposing the value blue again. And here's our first undo. And undo should undo your last local change. And for Alice, that was the merge operation, the coloring blue. Once we undo this, we also have to restore the conflicts that were present at the time prior to this undo. So this is basically the same situation we've seen before. And also the reason why the register turns green and red here. What happens if Bob concurrently sets the register to carry the value orange as well, but is not aware yet of Alice's undo action? Well, it just produces another value that is added to this multi-valued register, as you can see here. And a similar case is Bob decided not to issue a set operation, but an undo at this point in time. And Bob's last action was the green coloring. The prior state was the black from the beginning, and that's why the undo operation here at the bottom contributes black to the register. Still, because this is concurrent and after syncing, the green and red are still present in the register because they stem from, basically contributed from Alice's undo. A final little edge case is, or something interesting here is Bob's first redo operation. And there's two things I want to point out here. So first of all, we can see that undo and redo can also act like a merge operation. So we essentially treat undo and redo very similar to set operations for a multi-valued register. And the second thing is, although the undone operation is actually the green coloring here from Bob at the bottom, we are restoring the state prior to this corresponding undo, and that explains why the register just contains the value blue, but not the green thing, which is actually the undone operation. But this is in line with the semantics I introduced to you earlier. And finally, we also evaluated our algorithm. And a common usage pattern we were thinking about is, and you probably know this, you're undoing a few times just to see a document version in the past. You don't do any edits, and then you go back. And this is something we do quite frequently, so it was important to us to have this case covered. And the good thing is, and that's what I'm basically trying to tell with this slide, is that in total you pay very little cost, and this is less than 1/10 of a millisecond for resolving this. And this is a student-written prototype. And the other thing is, regardless of the depth of this undo and redo sequence, so regardless if you undo 20, 30, 40 times, whatever, and redoing, it's still independent of the length of the sequence. Yeah, and that's the end of the talk. If you have questions, we're here around. We're happy to discuss. Here are 2 QR codes pointing to our papers if you want to read them and get familiar with the algorithms. But we're also here tomorrow as well for discussing. And we also have an opening questions to the audience. We've already seen quite a lot of stuff that operate at a much higher level, and they were already using undo and probably also maybe move operations. What's your experiences with that? And maybe you can tell a little bit about this.
Yeah, thank you very much. I just want to say, I very much recommend reading the papers. They finally made me understand that auto-merge is not operation-based. Now, questions?
Hi, nice talk. So with the undo redo, I know there's another paper that's supposed to be about undo and redo registers by, I think, one of YIU students, but they choose different semantics than you do. I was wondering if you could maybe contrast and explain like the choices and why you make them.
I don't know the other semantics, but probably if we go back a bit to this, so ace undo, instead of turning it back to black, it could also turn it back to green. That's probably what you mean. Yeah. And we make a distinction in the paper and call what we do here local undo, because you only undo your local changes and never anything else from a remote actor. Whereas the other thing is global undo, where you're allowed to undo all actions also from other actors.
And I guess for this case, you're saying this matches the behavior that you've seen in practice for local undo.
Exactly. So the interesting thing is that all these applications for a single register have this local undo behavior. Yeah.
I have a direct follow-up question. So first of all, I really love the way that you present the concurrent behavior and so on. So what we did was some user studies, and I know it's totally difficult to tell people what is actually happening. So what is done and undone and redone, and it just gets very messy. In our smaller survey, I guess we had like 30 people answering. Experts, non-experts, CS people, non-CS people. It turned out that exactly this behavior, namely losing B's set of red, is what made people very, very unhappy. And yes, I know that all these applications kind of exhibit this behavior, but I'm a little bit doubtful whether they did this because this is the semantics that people want, or whether they did it because it's the simplest way to implement it. What's your take on that?
To be honest, I think this is, I know it's very controversial. People have lots of opinions about undo. And I think actually, but maybe because I've been thinking about this too much, that this is pretty good, or in my reason, the best semantics you can get for a single replicated register, because it basically is very consistent with the 2-register case I've seen earlier. And why should you deviate from that? And also, if I want to undo, I usually understand it as, okay, I want to undo my last action, although...
Last action is not visible. I mean, your last action is gone, right?
Yeah, it's
register
overwritten,
is green.
yeah.
So if you undo your stuff, you're kind of threading back time potentially for a very long time, right? So this reminds me a bit of this Notion scenario that I explained, that the last person who goes online kind of overrides all other people's changes. So this is, if I inadvertently click undo, then I'm throwing away whatever all my collaborators have been doing for the last 2 weeks.
Exactly, it is a dangerous power. But the other problem with global undo is, if we go back to this 2-register case, here global undo would basically undo B's green coloring. And if they're not working on the same slides, it would be very confusing, like first A clicked undo, doesn't see a change, and B suddenly, while working on his slide, has... Yeah, it's gone, the operation, for no reason. So I think it's the way you turn it, it always has a problem, and there's a trade-off to do here. I think that this one is the more natural one. where we have these semantics. I don't know, we haven't conducted user studies. We hope that those people did.
We did, and in our case, people agreed that if they didn't do the last action, then they simply are not allowed to undo. I think that's what Miro was doing, right? So you can only kind of undo the part of the history that you are responsible for, and then and that you've seen, and well, actually also that you are responsible of. But yeah, it's a huge design space, right?
Yeah.
Mm-hmm.
I agree.
Listen to the users. I have a question about move. So I found move to be more problematic when you also have copy. Have you considered that?
Sorry, what do you mean by copy?
Copy, well, in the case of a tree structured document like JSON, it's copying an entire subtree to another subtree.
You mean if I truly wanted to copy a subtree to another, what will happen? Is that what you mean?
Yes, have you considered the copy operation? And because I found it makes move a lot harder than your solution.
Well, I think copy operation now in AutoMerge is just create a new object, JavaScript object, and insert it again. So it does not interfere with the move operation. So you can consider copy operation as make operation. Copy operation, just make a new object there.
Well, not if you want to project changes that happened in the source of the copy into the copy, at another site. If you're making a copy sorry, I don't want to go into a rat hole. So the answer is you don't have a copy operation.
Yeah.
Okay.
So I have a question for the undo. Why do you need to choose one semantics? Why not have both? Because if we go back, maybe I would like to see the red change.
Yeah, it's something that I'm proposing in the paper that might be useful to offer two undo buttons, and one is global undo, the other is local undo, but the average user probably has never thought about this, so I think it's best to follow maybe what's out there already in OT-based collaborative applications. But you're right, there's choices we can make here, but it comes at the cost of user complexity. And for something like AutoMerge, also at implementation complexity, because in something, you can have a total order of all of the operations, but because of causal stability, it's not final at any given point in time. So you might be 3 items down in your undo stack of global undo, but then an operation arrives which actually should have been undone if it was there earlier. So you also run into kind of technical limitations if you're not doing local undo, because there, obviously, your undo stack is final.
So I have one question for the undo and the move. So let's do the undo now. Have you started considering the compositions of CRDTs? Because a undo with a single register is maybe a base case, and with composition, some people undoing different parts of the graph will end up violating some constraints that you have in the object.
Exactly. The nice thing about replicated registers is that each update is basically isolated. That's really helpful here. But if you have a different data type where you have dependency among updates, you need an additional mechanism to track this. So basically for a set, obviously add and the corresponding remove of the same item are kind of related. And so if you remove the add, well, removing something that doesn't exist in this case doesn't matter. But yeah, there's something extra you have to take care of for a more complex data type. Yeah.
Do you want to undo questions?
No, sure. I was just going to suggest that when we did paratext, we had a similar, just absolute rat's nest tar pit of complete complexity and confusing semantics. And as this work goes beyond a single register, and already you are getting angry, tomato throwing questions from the crowd, which is good, right? You're working on something that matters and is important, and people have strong feelings about this. This is a sign you're doing useful work, right? People want this; they care. I think it would be really helpful for you to thoroughly document and lead what you believe the user's desired semantics are and justify that. And what we've seen in some of our work on this stuff is that like we can define a set of, you know, it's like the Condorcet problem. It's like we've defined on Cambria, there were these invariants that everybody agreed we should preserve, which we could then prove were not possible to all preserve. And that then we could justify our decisions because we were like, well, you know, you want this and you want that. But like, I think there's a small mismatch between what Annette was asking, what you were saying is, you were saying, well, you either have local or global undo. And she was saying, no, no, your local undo is giving me the undesired result. Like, local undo should give you green, which I think is what you were trying to say, but didn't say quite so specifically. And
I think we
yeah.
local undo is exactly the right thing that we want.
Local undo is, yeah, people want the local undo, just to amplify what Annette's saying off microphone. And so anyway, I don't want to bicker over the specific color of a single register in this point, but just to say that like, you're going to get a lot more of this as you work on this, and having like good documentation of what your invariants are, how you've decided on them, and what the tensions are, I think will make future sessions hopefully involve fewer tomatoes.
One thing to add there, also this problem we just discussed, Annette, is not specific to undo, because this is also if you delete something higher in the hierarchy of the JSON document, you have edits underneath it. You have the same problem. And that's why I believe that the things we talked earlier about, that version documents, branches, a way to maybe time travel in documents is very important to maybe restore to something you've lost with these mechanisms as well.
So to kind of dovetail with what some of the stuff Peter was saying, and actually what you were just saying as well, that thing I was saying earlier about Tesler's law, right? Right now, we're trying to push this all down into the CRDT. And until we get user programmable CRDTs, like all the way out to the end user, which I don't think is coming anytime soon, maybe this is an area where we have a default behavior and then innovate at the UI layer, right? Typical user is not an Emacs user, fine. In Emacs, you can get a mode where there's like tree undo, for example, right? Or something we were playing around with when we were doing eventually consistent database was always prefer my rights, even though somebody else is preferring theirs as well, right? So always prefer my undo, which is similar to local versus remote, but you're now saying it's like, no, never mind what local means, like literally the actions that I perform, not what's on my machine, right? So like, I think there might be some area to play at the UI layer as well.
One other just small note is that in talking to people and looking at usage, there's local undo and global undo, but perhaps an important one you're not thinking of yet is personal undo. Because I have two tabs open, and they have both separate actor IDs in the CRDT, but if I type something in one tab and then I'm in another tab later and I start saying undo, it's super weird if I undo things I did a while ago instead of the things I did most recently. So you actually can't ignore, you can't just look at the local actor sequence.
But in a way, you're living in two worlds then.
Tell that to the user.
Just something to add about the personal undo. That actually, if you're a person that have two devices, actually you can have two actor IDs on two different devices, so you don't actually undo the operation you made on the other device. Yeah.
Yeah, I had a similar comment on this personal undo. I have a text editor with two windows. So sometimes I'm working on one window, and then I do a lot of work on the other window, and then I come back to the first. I try undoing stuff, but I'm undoing stuff on the second window. But I think I would like to undo stuff on the first window. Yeah, it's user semantics, right?
There's going to be a lot of arguing and testing and defending of principles rather than forget my argument for mechanism.
I think you should just sort out your tabs. There were two more questions on there.
That's fighting words.
Just want to apologize. My intention was not to throw tomatoes, I hope. No, I just really want to emphasize that this work is pretty cool. And I mean, what I mentioned about, making things visible and understandable what's actually happening, I guess that's very, very important, because you're studying this highly, highly, highly complex problem. I mean, this is a register, right? And we are undoing a set operation. Just imagine doing this on, I don't know, a text editor, a spreadsheet. I don't want to think about it. It's really difficult, and doing this foundational work is very, very important and very essential, because only if you spell it out like the way you did, we are able to discuss what the different options are. Yeah? Because as I mentioned, when we did our user study, it was very difficult for us to tell the users what they should see or expect. It's just very difficult for people to think in multiple threads at the same time. And I think the visualizations and the theory behind this, what you're doing, is great.
Yeah, thank you.
Let me embellish that question a little bit, because I was also wondering, like, you've both now a lot of experience with a certain kind of semantic work on this data structure. Do you think you found like a stable footing where you can go now into more data structures, more interesting transformations? Or do you feel like everything is grumbling and you're just holding things together barely? What's the future look like?
Yeah, well, AutoMerge also has a counter CRDT, which is also not a complex data type. But for this already, it needs to work a little bit differently. And yeah, I have now more solid grounding, of course, than when I did starting on this. And yeah, because a counter in a way is also really nice, because there you have true inverse operations and not like searching somewhere in the history. And that makes things easier for that kind of data type. So it really depends. And also the challenging things are probably when you have dependencies between updates and need to introduce metadata for this too.
Similar for Move?
Yeah, I think very similar to Move operation. I have very similar experiences to Leo. So I think it's approaching the end of our talk, so I don't want to add more about this.
People are still there, so we're fine.
One question.
So the semantic of the move is also very controversial. So in your system here, it's just very simplified, because you are just removing operations from the history or hiding them. But have you analyzed what is the semantics that we get from this strategy in real life applications of the move operation?
Yes. If you say so, I would agree that there are also some controversial views about the semantics of move operations. For example, you could argue that if you introduce a cycle, that you can cause duplicates. But in most cases, I would expect that the developers are not expect this duplicates result. For example, if you are developing a distributed file system, and when user move and subdirectory, then it is apparently that we don't want to cause duplicates. So that's kind of like a trade-off decision. It's not always win decision.
But if you change hide some operations in history, what does the user gets in the end, right? Because what is the tree structure when you just hide some of the operations? It might just give a semantics that is not very intuitive for the user.
So yeah, that's a good question. So you're mentioning that we're adding operation that comes a far away history, then it would interfere with the document tree, then how it can impact the move operation semantics. I would say I actually know nothing about it. I just designed an algorithm, and what the algorithm gives us is the semantics of users. And what we can guarantee is that there is no cycle and there is no duplicate. That's all the semantics we can provide for the users.
And with that, I think we don't want to keep you from coffee any longer, so let's thank the speakers again. And we'll see you for the last session.
Thanks a lot.
Heeding last call, I guess. This will be the sadly last session for the day, but it's fully packed with 4 slots this time. They're a little bit shorter, unfortunately, but that's why we'll go right ahead and have Dina talk about.
Okay. Hello, everyone. My name is Dina Borrego, and today I will present you the work I have been developing with my supervisors that it's about maintaining invariance in local first systems. So, local first is a new programming paradigm that allows users to keep the ownership of their data by keeping their primary copy locally while using the cloud for collaboration, synchronization, and replication. The key ideas for local first are the ability to process data locally, possibly in an offline mode, as well as collaboration across multiple devices, improved security and privacy, and long-term data preservation. However, supporting collaboration in such a model poses consistency challenges when dealing with conflicting concurrent modifications and intermittent network connectivity. To ensure state convergence, we can use CRDTs. However, it's important to note that CRDTs alone may not be sufficient to guarantee a globally consistent state. Let me show you an example. In an album management system, we can define a foreign key constraint between albums and artists, ensuring that for every album in the database, that also exists the corresponding artist. Imagine we have 2 copies of the same data, one locally stored and the other in the cloud. Initially, both copies are synchronized and they both contain an artist. Now, let's say that we insert an album into the local copy, while at the same time, another user deletes the artist from the database, updating the cloud copy. At this point, both copies are correct, and they both reflect their respective operations. However, after propagation, we end up in a state where referential integrity is compromised. Thus, besides convergence, we also need to guarantee the maintenance of the invariance, and for that, we need mechanisms. However, not all mechanisms are well suited for local first systems. For example, if we attempt to use locks on conflicting operations, we will lose the ability to work offline because replicas would need to synchronize to obtain the lock. Therefore, our goal is to have non-blocking mechanisms to enforce the invariants and verify their correctness with a mechanical way. Antidote SQL is a database system that combines strong and weak consistency and that uses a non-blocking conflicting mechanism to handle referential integrity. As this mechanism does not use synchronization, we can apply it directly to the local first setting. So I will quickly explain it to you. The mechanism uses an additional column where flags are placed according to the operations that are executed. For instance, when you see an I there, it means that the most recent operation on that record was either an insertion or an update. Now let's look at how this works in practice with operations. When an album insertion occurs, we put a T in the visibility column of the artist's, of the corresponding artist, and this tells us that this particular row has been touched, meaning that we have inserted an album that referenced that artist. The touch allows us to identify conflicts afterwards and handle them according to our predefined policy, that in this case is the Edwin's policy, so both the album and the artist would be retained in the database. As I mentioned earlier, one of our goals is to verify that the mechanisms work correctly and do indeed maintain the invariance. To do that, we followed the following methodology. So we start by providing the conflict resolution mechanism and the invariants that must be enforced by the mechanism to an analysis tool such as Z3, Verifix, or TLA Plus and TLC model checker that verifies if the mechanism is correct. And this verification leads to one of three results. Aborted, in the case the tool times out, and in these situations we need to simplify the specification. This is probably the most annoying case scenario because we don't have any hint about what to do to solve this problem. Wrong, if the mechanism is unable to maintain the invariants, and in this case the tool is our friend and it also provides us a counterexample to help understand what is the problem. After understanding the problem, we can correct it and verify it again. This is an iterative process that ends when the analysis tool returns a correct. And now we can celebrate because we are sure that the mechanism is correct. To prove the referential integrity mechanism, we opted for Verifix, that is a high-level programming language that allows to develop RDTs and define safety properties that are automatically verified. And we started by implementing the mechanism and define the proof we wanted to demonstrate. In this case, the proof encodes the following. For any two reachable states that are also compatible and where referential integrity holds, if we merge those two states, we get a new state where referential integrity still holds. However, this proof is quite heavy because it has multiple loops, which resulted in an abortion by Z3. To access the effectiveness of the mechanism, we then create tests in Verifix based on the earlier example. The tests allowed us to verify that for those specific examples, the invariant is maintained. However, this is not ideal, and we are working on the simplification of the previous proof to get it correct. At this point, we had a mechanism that we knew worked for referential integrity, so the idea was to generalize the approach for other types of invariants. And if we look closer to the referential integrity formula, we see that this part here can be expressed as an implication. So, referential integrity can be seen as a specialized form of an implication, and an implication is a disjunction which leads to the question, why not extend the touching mechanism to handle implications and disjunctions? And that's precisely the direction we have been exploring since then. When dealing with a disjunction, as illustrated in this example, the underlying concept remains the same. However, rather than having the visibility column associated with each row, we have the visibility column associated with each column. Another difference between referential integrity and disjunctions is that in referential integrity, we know which operation must execute the touch, while in disjunctions is not straightforward. In this specific example, we have chosen an operation to execute the touch, but we are exploring some other solutions. Now let's delve into how this works. Suppose we have designated the operation that updates the nationality as the one that executes the touch. So when the operation is executed, a touch is affixed to the naturality column, and the operation that updates the naturality does not change and proceeds in the usual manner. After propagating the operations, due to the presence of a touch on the naturality column, the operation that updated the naturality would have no impact. To validate the correct functioning of the touching mechanism for disjunctions, we specified it in TLA+, and we subjected it to verification. We performed this verification across 4 different models, each distinct in the terms of the number of replicas that we consider and the number of predicates involved in the disjunction. And for all the models, we were able to verify that the specification was correct. Before concluding, I just want to emphasize that local first applications require convergence and preservation of the invariants. In our work, we verified a referential integrity mechanism, and we saw that this mechanism can be directly applied to a local first setting. Currently, we are trying to generalize this mechanism for other types of invariants, such as disjunctions. Thanks.
Thanks for the great talk on this important problem. I'm curious, how application-specific do you think these kinds of invariants are? Do you envision individual application developers going through this kind of process, or are you imagining more, CRDT developers using these techniques to develop more general invariants?
Okay, in the slide that I showed with the verification process was designed thinking on the person who is designing the mechanism. But the idea that we present on the paper is actually a little bit different, and it's an automate. Basically, it was for programmers, and the programmer would provide the specification of the database as well as the invariants and the mechanisms to enforce those invariants, and the whole application would be verified against those mechanisms.
So one thing I was wondering about is, so you started focusing on referential integrity, which is very much from databases. So was this driven by prior work on database-like systems, or did you think about a concrete set of applications that you wanted to support? If so, can you elaborate on that one?
Okay, so I am not working specifically in the local first setting. So when I thought about using the mechanism for referential integrity in these junctions, the idea was more general than that. But when we submitted to PLF, we saw that this can be also applied to the local first setting, because we don't need any logs to do that.
Certainly, but I was a bit wondering if, I'm always looking for what people, what mental model people have of the world, right? What motivates you to select a certain type of application, you and your research group, I guess. It's not just about you personally.
Okay, so how do I choose the examples that I use?
Maybe.
Okay, so referential integrity is a well-known invariant in databases.
So you choose that because it's like a standard thing?
Yeah.
Not for a particular application?
Yeah.
That was basically my question.
Hi, great talk. I saw that you use 5 to 10 operations to verify your model. Did you try more operations? If so, how was the result?
I don't think I understood your question, sorry.
Can you switch to the slide that you are yeah, this slide, just back. No, next one. Yes, you use 5 or 10 operations to verify your model. Did you try more operations, and was it converged or any other result?
Okay, here the number of operation does not represent, I can have a lot, for example, in this situation, we have the update nationality and the update naturality. If we model this example in TLA+, when we check it in TLC, what happens is that it generates models where 10 operations are executed, and it tests it explores all the space, so with 10 operations executed. But it can be different operations. The type of operation that is executed don't matter.
Okay, I was just wondering if there are edge cases not be covered by 10 or 5 operations.
Yes, it can happen, but if we don't restrain the number of operations, the model is too heavy to be proved. And that's why we need a threshold on the number of operations that are executed.
Okay, thanks.
Triggered by that question, a question to everyone in this room. Is anyone using not model checking, but proving things with Acta or Isabel in this space? Yes. Okay, I will very much.
One more, if we have time, briefly. So the idea of maintaining an invariant, in your case, for example, the foreign key integrity, you can maintain the invariant by pretending that a certain operation never happened, like, for example, the deletion of the entity that is being referenced, and drawing a link maybe to the earlier talk on move operations that also had the same idea of maintaining the invariant that there are no cycles by also pretending that a certain operation never happened. I'm just wondering, do you think that's like a general pattern that to maintain invariants, the right approach is just to exclude certain operations from the history, or I'm wondering if that's like a larger pattern that we should be thinking about here?
Yeah, I think that, yeah.
I don't really know where the thought is going. I just wanted to throw it out there.
Yeah, so maybe just a comment about what you just said. I mean, if you don't delete, then you would have to do some transformation, and that sounds a lot like OT rather than, yeah. So maybe delete would be the most in line with the CRDT approach, I guess.
I see it more as adding a compensation than really adding what happened in the past. So, because someone really tried to add modified one of the values, right? So it's not like you're adding in the history, just someone preemptively tried to prevent the conflict by executing an extra operation. So I think you can see it as adding the history or doing a compensation to prevent the conflict proactively.
One thing I hear from users actually often of CRDTs is that they want transactions. And specifically, it feels really adjacent to this work in the sense that what they mean when they say they want transactions is that they want to see either all or none of a particular operation group, right? And so if there's a conflict on one part of the key, they want all the rest of that collection of work to be somehow rejected, which I don't know what that means for a CRDT. Like everything is sort of thought about at a register level, like under the hood. So I'm wondering actually whether this work can be also taken in a direction where, if you can detect these invariants are being invalidated, you could have an invariant that says, oh, there's no conflicts on any keys in this group of operations, and if there are, we'll ignore the whole set. So I feel like maybe there's an interesting opportunity there to like solve a problem we've had for a while, but I don't really know how you would get there from here. But people want it. I get asked, I don't know, once a month or so.
Did you ever look at the delta state RNG?
Yes, I've asked that for those on the stream. He asked if I looked at the delta state. Again.
Not to bring up our database-backed CRDT like yet again today, but part of the rationale behind that approach, where we essentially write all of the CRDT updates into a database, and then we run database queries over it, is that we can then borrow all of this kind of thing, right? So we were doing atomics and transactions and all this stuff in CRDTs to say like all or none of these operations, right? And as this presentation was going on, I was like, oh, we can, if we ever pick that project up again, I would totally use this, so.
So I would argue that both, like some of the problems that you're talking about here and the problem, like the idea of having transactions in CRDTs, another way of framing it is that people have CRDTs with their own semantics, you know, where they have operations that don't correspond to just changing a register, right? So if you need a transaction, probably, you know, it's like, you know, the prototypical transaction is I need to move money from this account into this account. So you can have an operation that is move, and you know, it specifies an amount in a from account and a to account, and it's just one operation, and the operation, you know, stays or goes. And a lot of the, I'm not sure about the referential integrity thing. I hadn't really thought about that, but a lot of situations where you're worried that different operations might result in you know, violating these invariants, what you actually need then are your own custom semantics inside your CRDT and your own detection of what conflicts are, your own definitions of what a conflict is, and your own rules for how you resolve those conflicts.
Thank you. Do you need the adapter?
I don't think so.
Okay.
Thank you very much.
So this time we're going back from academia to some more, well, experience. Let's not separate industry and academia. Well, I'll shut up now. Please take the stage.
Yeah, there's a weird dimension. I'm not sure whether, like, I'm certainly doing stuff in practice. Oh, this is the wrong screen. See, this is where the experience might not translate directly. Use mirror. Does this change something? Yeah. Wonderful. All right. Yeah, so my years in academia are quite a few years behind me, and I've already made it. I've just made it to bachelor's degree. I was too keen to going back into actually building apps myself again, and this is what I've been luckily doing for the past few years. Particularly over the past 2 or 3 years, I've been building a local first, not quite local first yet, music app. So yeah, I'm Johannes Schickling. I'm based in Berlin. Before working on this, before being introduced also to local first, I was trying to help developers work more happily with databases, where I've been building a tool and company called Prisma. But right now I'm pretty focused on local first and doing also a bit of open source R&D besides that. Overtone is the app where I've collected most of my experience actually building local first software or aspiring local first software with, since the caveat to Overtone right now is that it's technically still local only. Hopefully over the next year we'll make the jump to being fully collaborative and syncing, and therefore local first. But it also feels like quite refreshing, having spent, I guess, like the last 10 years all thinking about cloud architectures, to now really think, oh, like we can actually push things forward quite a lot, just like in that local context. So this is where I've spent my innovation tokens, to borrow that term. And so really trying to make the app as fast as possible, as nice as possible to use. Overtone as an app itself, you can think of in the same ways we can choose between different mail clients, and wherever our email servers live, we don't have the same luxury for music. I want to change that, and I want to give you a very premium music client that you can use with whatever music source you're using, whether it's SoundCloud or Spotify or whatever the pirate flag means. Thanks to Peter for that great suggestion. Yeah, I keep pushing back the time for access by another half a year whenever I give a talk, but hopefully this time around this is more accurate. And so, yeah, I just want to give you a quick proof for what I've been working on is actually does exist and does work. The screen resolution is a bit different than I expected, but yeah, so this is overtone. Typically on my screen this says 120 FPS, but I guess not quite on this setup. This is all driven by a state management solution called Riffle, which is based on the previous collaboration with Jeffrey and Nicholas. So this can, as you'd expect from a music app, actually play back music. This right here has like access to all of my Spotify playlists. Navigating between here is all typically 120 FPS. I can like have this sort of Command K traversal. I can go to different artists. So kind of what you'd expect from a music app. So just as reference and to prove that what I'm talking about is actually backed by building a real app. So particularly, so the talk, the title of the talk was sharing some of my lessons. I wanted to share more lessons, and you all are invited to approach me afterwards for other things I might have learned along the way. I needed to condense what I'm talking a bit more, and so I'm just talking about client-side management. This, I think, is compared to what we've heard before today, I think nicely complementary to a lot of the syncing things, etc. No security, no privacy. This is just about how you get the best possible client state management setup that I could think of. And yeah, we've heard some suffering, from using Redux today, and there's also other alternatives such as MobX, etc. I've used those technologies in the past extensively, and sure, you can build simple, medium, and sometimes even sophisticated apps with it, but I wanted to rub an actual database on it, and that was also the core idea of where Jeffrey, Nicholas, and I started our collaboration. Since Jeffrey and Nicholas, I think Jeffrey spoke about this at last year's PLF, where the idea was basically, hey, can we use this great technology SQLite, and can we use that as an actual state management facility for a real-time app, and for like ad reactivity, etc. So this is what Riffle is all about, and I was kind of a partner to this project by building an actual app on it. So, and we've been facing an kind of existential question that almost plagued us for the entire like duration of the project, and we weren't quite sure, like, are we making the right call here or not? So if you're actually looking for how you use SQLite with WASM kind of officially, this is from the Google Chrome blog, where they tell you this is how you use SQLite in browser apps, which is a worker-based API. So they seem to suggest one way. Nicholas, who's been working on like SQLite-based systems at Apple before, I think he and Jeffrey came up with a different idea. What if we actually put the SQLite database in the main thread? So we've been going back and forth on this, and so we came up with some trade-offs. So if you're using SQLite on a worker thread, that felt like the more conservative bet. Sure, you have an async API, so whenever you want to query some data, you need to wait from your main thread to get a message back from your worker thread. But on the other hand, you can't block the main thread, so whatever slow queries you're making, the main thread is not harmed by that. But you do have that latency of like crossing the web worker. You also have more like a higher database size that you can work with.
since yeah, it's basically rather bound to whatever the browser allows you or your file system allows you. And data is typically pretty safe, persisted on disk, whereas on the main thread, it feels a lot more gnarly. The data has to fit in memory or whatever the browser tabs gives you. It can block the UI, so if you make a slow query, the user will suffer. But there's a lot you get in return. So you get a synchronous API, which simplifies things a lot, and you basically have no latency. So we've been thinking about this. We wanted to live in a world where we have no spinners. We wanted to, or this was also the kind of the dream for me. If we get a database, typically in a cloud context, I've worked with a database in a kind of like having async APIs, but here, coming from a JavaScript world where Redux, et cetera, is all synchronous, I wanted to have the cake and eat it too. So I wanted to have a database, but synchronous APIs. So we took the red pill. Yeah, the benefits are great. We're now 2 years in and been like sometimes kind of doubting, oh, was this the right call? And then like a month later, yes, was the right call. And it's those two things are, I think, really the main things for me is like it's much simpler to program in. So just by like this code example, for example, if you query some data, you have some tasks and off status. Now you have like here, even like locally in your UI state, kind of a distributed system that you need to deal with. And this is just like a teeny tiny example. This ruins like all the fun of building an app for me. So this is kind of table stakes right now for me. That's you have sync API, sync query responses, and remove so much what I'd consider accidental complexity if you look at most apps today. And it's also the, if you like tame the queries, you get some really great performance out of it. So this is what made it all worth it, but there were challenges. So, and yeah, I think the number one is, given that we're now running on the main thread, you can think about that similar to how you build a game. Like on a game, you also like you have a frame budget, etc. So you try to do as much as possible in a frame, but not too much, since then the game starts to lag. So you kind of try to make it as efficient as possible, and that was a lot of work. Also, the data size limit, in my experience, rather a theoretical problem. We haven't hit that yet. And also just implementing all of this. So I want to share a few more words about that. So frame drops, not gonna lie, the app still sometimes drops frames. We know like what levers we can use to avoid that. We've already come a really long way. But this is that's pretty tough. And while working on this, I also realized that most web apps we use today, like including Slack and Discord, etc., they drop frames like all the time. And so I'm feeling already pretty proud of like how far we've come and like knowing what you can do there to improve things. And yeah, it's mostly like avoiding slow queries, avoiding not doing too many queries all at once. And when you've done that as a baseline, then you can also make things faster by caching where it's possible, doing things like incremental view maintenance. We also have a very great collaboration going on with a person, Matt Wanlaw, who is working on some automatic incremental view maintenance things, also super interesting. And ultimately, given that the app still needs to do a bunch of work that needs to happen at some point, I needed to build a app-level task scheduling thing, which is, I think, fairly uncommon in web apps. But this is basically when I want to run some piece of code, I need to slice it up, yield once in a while back to the render thread that it can handle the user's interactions, so that it doesn't result in like a dropped frame or multiple dropped frames. And doing that in the web is kind of tricky, but we figured that out, and that's paying off big time and kind of like prioritizing work that needs to happen or that you can cancel again. So that's quite the undertaking, but it's been paying off a lot. Then another, I think more of a conceptual challenge, we haven't hit that yet for Overtone. So far for Overtone, all the metadata that we've been working with has been fitting into whatever device we've been testing it on. So for like in that domain, like 100,000 tracks, for example, we're roughly correlating with 100 megabytes of the database size. And let's say you're like your app is doing something completely else where you like really deal with like hundreds of millions of rows. I think this is where you could also partition the data, like use smaller SQLite databases and use the attach feature. So yeah, we haven't crossed that bridge yet, but I'm feeling optimistic that there are also ways around that. Or you could have a hybrid approach where like most of your UI state is in the main thread, and then some slower data could be on a worker thread. But yeah, if anyone is like following a similar path and has run into those sort of limitations, I'd be very interested to talk about that. And then in terms of implementation, yeah, we just, first of all, we dared to take the red pill. I'm not sure whether too many other people have like followed a similar approach. So lots of pioneering work, lots of self-doubt whether this is the right path. Efficiency was also all along like a pretty big problem. So that's kind of like the other side of the performance coin. If you might be able to build it in the app in a way that is all like runs 60 FPS or 100 FPS, but that could still mean that you're like using up the budget of every frame, and like you waste a lot of CPU and makes your like battery drain. So I had like hot laps a lot, particularly when I was traveling. So also trying to maximize efficiency. By now, I think it's in a good state. We need to come up with a solution for persistence. So in a way, we actually took the red pill primarily, and then also the blue pill for persistence. So we also run additionally a web worker, which is just there for persistence. So we kind of mirror the right calls to that. You could also think of other mechanisms. And we layered a reactivity solution on top of it based on Adapton, which allows us to, when we write to the SQLite database, that the corresponding React component is updating. And yeah, that was mostly it. A quick shout out, we're gonna start a local first podcast that might be happening at some point. And I'm not sure how I'm doing in terms of time, but I'd rather get into the questions.
Thank you. My 5-second hot take of this talk. Deciding between what Google tells you to do and the thing that looks easy, take the thing that looks easy is probably better.
So Johannes, many people have told me that it should be possible to have a CRDT running in a database. Matt Tanteman is building Vulkan, which is a SQLite CRDT. It seems in principle that it should be possible to put like AutoMerge or YJS and have it syncing into SQLite. And as the number one person I know who is really into web stuff, database stuff, and local first stuff, I'm just wondering when you're going to start work on that.
I'm glad you asked the question when I'm going to start working on it, and not like what is my take on it, since I will start working on it, but I don't know my take yet. So I'll give you an update in the months to come. But I'm starting to pick up the conversation. Also, Walter is here from Electric SQL, so we're just exploring that with whoever has thoughts on that, and yeah, hopefully I have a take on that soon.
You talked about how async programming takes the fun out of programming, but splitting the work up into these small chunks would seem to take the fun out as well. Is it really more fun that way than the other way?
Fair. I think it depends. In building a UI, I think the things you do should be like all very small. And so if you, it's like, this is all totally possible to like follow this architecture if you don't accidentally do like a whole lot of unnecessary work. And I'm kind of switching between hats Like I'm either wearing like the blissful application developer hat who's building a feature and has a lot of fun and doesn't think about that at all. Or then once in a while I do, as an application developer, recognize, oh, there's some things that are slow, and then I go into, like, I've built a lot of dev tools around that for observability. Then I try to figure out, like, okay, what is like this time the reason for slowness? Then I switch into like library builder mode, and then I realize, oh, like there's all of this entire category of unnecessary work that's happening, and I can like remove that, oversimplify it, and tell my application developer persona like, hey, it's faster now, but nothing has changed for you, and then it's a lot of fun. Yeah, I think I'd say broadly this applies for like UI apps. This is where it should all, like, as a render loop, like nothing there should take very long. And then the things that are inherently maybe taking a bit longer, then it's also kind of fun to think about that. And then I would rather say, oh, can this, maybe as another big thing to lean on there, does it need to happen on the main thread? If it doesn't need to happen on the main thread, I'm like very happy to put it on like a web worker and then async all the way. But for the things that need to happen on the main thread, this is where like a sync API makes things a lot easier.
Okay, thanks.
If just someone could, imagine a programming language where multi-threading was easy. I do have one more question. So you do use SQLite, right? Which is pretty complete implementation of the SQL standard, which allows a lot of complex queries. But you said you kind of try to use simple queries for performance reasons. So what do you say is the trade-off level? How much do you get from SQL as like a complex query language? How necessary is that? How much does it help with the application?
Right. So why I wanted to have something like SQLite as opposed to something like MobX, etc., is because I want to, from like knowing that Overtone already is a fairly complex app and will only grow more complex, one thing that I need to lean on a lot for that complexity is data models. And I didn't have a clue like 2 years ago what the data model would look like a year from now, like a year ago, and like even less today. And I'm pretty sure that today I don't know what it will look like in a year or 2 years from now. So my data models constantly evolve, and being able to decouple the way how I think about my write models and the read models is very liberating. And this way I can basically, I'm following also kind of like a event-oriented architecture, not quite event sourcing, but ish, is also evolving. So this way I can think about my event log as the write model, and wake up tomorrow, rethink my view model entirely, refactor it, rehydrate, and do very sophisticated queries on that. Whereas like with MobX, I'd need to like rebuild everything. So a database gives me quite a lot of power that I use.
Do you still store both the event log and the hydrated UI state in the SQLite database, and how do they relate?
So technically, yes, the event log lives on a different thread though, but that doesn't matter. Like that's could also be binary encoded into whatever like OPFS.
So it's mainly the application state that lives
exactly.
in the database. Right. Any more questions from the audience? Otherwise, we have a talk on time, which is great. So let's thank the speaker again. And we have Victor with the next talk. I'm not going to stop. Guess again what kind of talk this will be.
What is
HDMI?
Hey, return the adapter, please.
Do we have a USB-C to HDMI adapter?
Yes.
Amazing. Oh. Let's all thank USB-C for making conferences much easier.
It used to be VGA to HDMI, it was the same thing. Every 5 years.
But this time it's like more laptops have USB-C. I think that improved a little bit. Okay. We're good to go?
Yes, sure.
Done?
The presentation. No, it's the other one. Sorry, the other screen.
Like everyone likes to see a bit the working environment of everyone. Right? This looks like my slide workflow. Well, I don't use Markdown.
Which? Here. Here we are. Boo. Boo.
It's very small.
Can I somehow? I don't know. Mirror. I should mirror it. 1 second.
So I think we didn't have anyone having problems with Windows yet, but I think that's because no one used Windows, which is an interesting development as well.
Technology. Okay.
It's pink.
Okay, nice, trendy.
It'll be fine. It's not how it's supposed to look, but the stage is yours.
Okay, so I'm talking about. Actually, can you hear me in the background? The online people. Sorry. We are talking about causal trees, that is a CRDT, which is more or less equivalent to RGA replicated global arrays. But I'm using this term when I also assume that not only linear collections, but generally tree-like collections. So causal trees, they can also express JSON-like structures, key-value objects, and so on. And my key idea, to which degree we must innovate to make it work well. I will illustrate the topic. So this is Ford model 1931. So it has like 2 trunks. One trunk like traditional cars had trunk before this model, like actual trunk. And the other trunk like already modern trunk, which is embedded into a car. So this is the situation we are in. We are sort of innovating CRDT stuff. We are trying to slap it on top of, how to say it, infrastructure which we have, because building new infrastructure from scratch is a bit too expensive. So my personal story with CRDT is like this. So my, how to say it, I saw the paper on wood, which I believe it was, in fact, first CRD. It was like 5 years before the term was invented. From INRIA group, then I decided to improve it, and I proposed causal tree CRDT. And then at some point in year 11, such proposals were already so numerous that Shapiro team, if I remember correctly, invented the term to generalize it all. So basically, this is where I started. I did a lot of client-side work by necessity, but that was like in year 12, year 14. It was raw JavaScript and React. And basically, it was MVC, like what is the proper way to build client-side applications, MVC. In our case, what was the difference? The difference was that the model was replicated. So we didn't reuse any, well, we reused React, right? But the idea is that we took very classic concept, which is like from the 70s, right? And we basically adapted to CRDT distributed applications. We replicated the model. Our local changes are sent into the network. Everything that comes from the network is applied to the model, and the rest stays the same, basically, right? So we have that trunk-trunk situation. So on the client side, for us, at least, innovation was minimal back then. Of course, people who do it like seriously, like Ink and Switch, for example, and many people here like dig into implementation details, but you know, to make it work, that was not sufficient. Then a much bigger story, which became an epic because I'm more like a backend guy. The problem was how to make actually, that problem was popping up during previous talks. How do we make a good storage for CRDT data? Should we reuse some existing database like SQLite or I don't know, Postgres, anything? Should we like cram it into some key value storage? Should we just keep profiles on disk? Actually, it is, well, it is a very like vast field of work and study, and if we look at what Mr. Klepman was doing for the last 5 years with auto-merge and columnar formats for the databases, yes, there is a lot of work to do. And I was more or less in the same field, so basically, what is the problem? Why can't we just put CRDT data into SQL database? We can, but we have a problem, impedance mismatch, right? So SQL database, it is adapted to tuple data. We have tuples of the same scheme. We make SQL queries. There are like very standard ways of thinking along these lines, working along these lines. And once we start, basically, what is the top problem of CRDT data? Metadata. Metadata. For each tiny piece of data, we must know who and when created it, where they put it. And this metadata may be like an order of magnitude more than the actual data, right? So when we start cramming it into a regular SQL database, we get like times 10 stuff. And well, it is good. We also have indexes on top and everything, but all the assumptions the regional designers had, they are not for our case. So it kind of works, but it doesn't really work that well. So this is the situation of impedance mismatch. So we must somehow deal with the metadata, minimize it, compress it, do something, then make it, our indexing needs are very, very special. So we must also design for that. So that was quite a problem. So key value, relational, and also be columnar. And the causal tree is basically a tree, but it is like tree, like it is formally a tree. In fact, it is a linear collection most of the time. But it is a tree because mathematically it is a tree. So there are many things to think about. So basically the problem was performance, impedance mismatch. When optimizations implemented in the database, those optimizations have their price and they're not relevant to our case. And in our case, we need optimizations in a different place, and a regular SQL database doesn't have that. So basically, we paid the price, but we got nothing. Problem. At the same time, we want to reuse as much of existing code base as we can, obviously. Doesn't always work. So this part of my work overlaps very heavily with what AutoMerge team was doing. So the original inspiration was columnar databases. Everybody knows columnar databases. They are more like read-only databases, but they have very good compression ratio. So the first instinctive idea of a person who had experience working with columnar databases, basically takes CRDT data, slash it into columns, put it into columnar database, and let it compress it. Anyone following still? Yeah. So, and basically that kept us busy like for 3 years, like working in parallel, right? More or less, yes. So the problem is, well, columnar databases have their problems, which are known like from the 80s, I don't know. They are basically read-only. They have terrible amplification on write. So, but they solve the metadata compression problem, but we get another problem. So, well, before that I was working in Realm, so for me that was also like natural idea, we should try columnar databases. And then I realized like, well, one problem solved, 3 problems appeared, so, okay. So my second iteration, this one was funded by Protocol Labs, by the way, was reusing key value databases. It is like a very archetypical approach. we implement high-value database on top of low-value store. And low-value store, in like 80% of the cases, is RocksDB. It is just a very popular legacy set for constructing custom databases. It is currently maintained by Facebook, but actually the roots of the project go into Google, into their big table system, and all the stuff. So it is a log-structured merge tree database, which is very write-friendly, differently from columnar. Here we may just throw data like at, you know, as much bandwidth we have, like throw it all, it will eat it. So the idea was to do like everybody is doing, adapt with storage engine, to keep our CRDT data and somehow tweak it to make it compress metadata because, well, and then actually the second idea was, why don't we serialize it in a columnar format and then put it into LSM database? So that way we have good write rates, at the same time good compression. That was an idea. It mostly worked. It actually worked. So basically you serialize CRDT into a columnar format. You turn it basically into a string, and then you put it into LSM database. LSM databases have such a thing, which relational databases never had, merge operator. You may not just overwrite values, you may merge values. Like, you may put like 3, and then you may put +1, +2, +8, +7. And it will do the addition somewhere inside in the engine. So merge operators are very good. CRDT is all about merges, like, yeah, like, found it. It actually worked. So merge operator was overloaded to parse that columnar CRDT and merge different pieces of it. So when we make an update, we make a string of it in a columnar format, throw it into the database, and somewhere inside the database is digesting it. You see the point 4, right? You see the point 4, how it ended. Unfortunately, I had to, you know, make it appear piecemeal. So basically, the problem is the same. Designers of such a database didn't foresee our very special usage pattern. They don't optimize for it. Because, you know, there is a bunch of people, I don't know how many of them sitting in Facebook developing their database, they have use cases which they see in Facebook. Our use cases they don't have. So their merge operators are not parsing columnar formats as a string and then merging them on the fly and then writing back, and they don't understand it might be such an expensive operation. They imply that merge operator is some very trivial and simple operation. And all the optimization inside the database, they imply the merge operator is dirt cheap. So basically, when you make it expensive, designers of the database didn't expect this kind of trade-offs. They are like special to our case. They're special to CRDTs. Like on the paper, it was all like a perfect match, but then you realize you have to rewrite a database like and make Facebook accept your patches or fork their project. So next iteration. I think most of it was also funded by Protocol Labs. Skip log. Here we see certain influence of the crypto community. They like the data structure. It is like skip list, but the other way around. You understand skip list, right? Skip log, we basically append something to the log and we make backlinks. Why backlinks? Because crypto people, they like append only, they use hashes as the links, so they can only point into the past. So skip log. Differently from RocksDB, it had like 0 moving parts. It was just append only. We take a piece of an object, we append it to a log. When appending, we put references to the rest of an object. And in the end, an object basically forms a skip list, a subsequence of that skip log. So it is simple as a brick. It is one file on the disk, always append only. Another file is an index. We must know where each object ends, so we can like grab it and pull it. It worked. I mean, it worked. It was much simpler because once you combine columnar database and LSM database in one, you know, like biblical monster, it is a bit overcomplicated. This one was simple as a brick. The only problem, of course, that in the end, your object is like spread all over the place, because LSM database eventually will compact that object into one lump. It just takes lots of adventures, but eventually it will do it. Here, your object always stays like the list. If your data fits into RAM, that is not a problem at all. For example, if you're doing a wiki, for example, or some, I don't know, revision control system like me, for example, I implemented a wiki using this data structure. It was like small wiki, less than 100 pages, but I put it like on a web server, put it on Hacker News several times, so it was like Flash crowd, all the smart guys and script kiddies trying to make fun of me and failing. So actually, one of my colleagues was ridiculed like in real time. He was doing demo and okay. So so basically it worked. It worked. But the original mission was like a revision control system. Revision control system has branches, and we're talking like for 5, 7, maybe 10 years. Actually, I think the first time I saw that in NC in 2010, like branching database, great. Maybe not in NC actually, I don't remember. But it is like an old idea. I will never claim credit of it, a branching database, because I'm absolutely, or at least almost sure, I heard this from somebody like 15 years ago. So branching database, boom, 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 boom. Basically in this data structure, it is really difficult to work with branches for a variety of reasons. Basically, you have to scan it all to understand which piece relates to which branch. So, because this is a workshop and not a conference, there is also another iteration of this project, which I will tell nothing about. But you understand the key idea. Basically, the same thing, but that can do branching. My focus is not like on big data, on small data, like texts, revision control texts, like wiki revision control, and small databases, maybe collaborative databases, I don't know, address book, some weakly structured, maybe tree structured database, but not big data. So my term is multi-base, like a branching database. Branching in a very wide sense. Okay, this one is to be published. Then, the amount of reused and invented stuff. So what I found is exactly also not my idea. Not my idea. It was an idea by a guy on YouTube channel, Forgotten Weapons. And he was saying, basically, the specifics of Russian weaponry school, they always steal ideas, but they only steal ideas, not designs. So basically, you can reuse the concept, MVC or MVCC. But if you try to steal specific design, it almost guaranteed not to fit your trade-offs. If you steal designs, you ridicule yourself. If you steal the concept, you're good. So, multiversion concurrency control. This is like 99% of the database is currently in operation, right? So what is the idea? The idea is that many people are writing to our database. We want to see a consistent snapshot of it. So basically, we number all the transactions. Like, for example, Postgres is numbering transactions with 4-byte integers. So in some bigger databases, that number wraps around like several times a day. But still, that is sufficient. Same thing in RocksDB and many other databases. So basically, it is an integer. So if we see some data which is marked with a version number which is greater than our time of our transaction, then we ignore the data because the data was added after we started. So basically, it is ephemeral. Then understanding what is a version, right? What is a version? The talk by Carlos Baquero, right, earlier today, he spent like half his, I don't know, time, I think, optimizing version vectors, because version vectors, they have like O of n space complexity, which is terrible. Well, so you may see like that in a traditional database, version number is an integer. In our case, in the best case, it will be a vector of integers. Like in the best imaginable case, it will be just a small vector. And it can be actually pretty, I mean, it may correspond to the historical number of versions that I've operated. So it may be a map. Actually, this is also a map. It's just a different kind of a map. When I started this project, Peter said to me, like, don't start a new project in C++. Not today, like, maybe Rust. Everybody is using Rust. And then I see like 3 or 4 projects in the field, they like fail because of excessive complexity. And in 2 cases, people need psychological, you know, help. Seriously. And then I realized, like, well, I'm not using Rust. I will use C++ anyway. So, well, eventually I understood that C++ is also overcomplicated modern C++, so.
No pressure.
So, basically, what is my key idea here? What is my key idea? O of 1. All these data structures, I mean, version vector, its space complexity is O of n, but its lookup complexity is O of 1. And vector is small compared to the database. So basically, the problem is not that the vector is big. The problem is that you're scanning much bigger database, and on each record, you have to check it against the version vector. And because the lookup time in a good hash table is O of 1, then our situation is not really different from Postgres or RocksDB. That the actual heavy lifting is scanning the database, and lookup time is O of 1. So that classic MVCC, it will be a bit more expensive in our case, but it is still workable, and academically speaking, it is the same complexity. So basically, MVCC is fully applicable in our case, conclusion. And MVC is also fully applicable. So, yep.
Yeah, thank you very much for the talk. We have time for some questions, not that much, but any questions in the audience? So I do have a question. Victor, I've seen your work before, and you've talked about doing things a long time ago already. What were your applications? Like, what motivated you to this field? I'm super curious.
Well, actually, a bit of Googling may like uncover my tracks. So, so it is like revision control and wikis. There is like a great idea of space communism that if you run Wikipedia in peer-to-peer network, where different institutions support their replicas, then you can overcome its scaling threshold and make a thing which is like many orders of magnitude more useful. For example, but that is thing that was motivating me in 2010, and it has been like many other things since, but I think I don't have time to. But for example, currently I'm focusing on revision control and wikis. Yeah.
So was that more on the, you did it for idealism, or you did it for you need the performance side?
Idealism or
performance. You know,
space communism.
The great trade-off. Space communism.
Space.
That sounds like idealism. Great. Any further questions? If not, no.
I was just wondering about the link. You mentioned the branching and merging and version control like things, and you mentioned MVCC. didn't quite make the link between the two explicit. So is the idea that you use MVCC techniques to figure out which edits are visible on which branch? At least that's how I've been thinking about MVCC in the context of CRDTs.
That is, sorry. MVCC in our case is understanding which edit is visible on which branch, right?
Yes.
And the question?
Well, I was asking if that is what you had in mind. So
yes, more or less like that, yes.
Okay, cool. Yeah, thank you for clarifying.
I mean, MVCC in a regular database is sort of transient, like within time scale of several seconds. In our case, we generalize it like to complete space communism, so it is like to version 0.
So in space communism, presumably you can maintain your own opinion in spite of what else is happening in the world, right?
Yes,
Plurality
exactly.
of
Yes,
perspective.
yes.
But of course, in space, we don't hold still, we travel, one concludes. So logically, one of the things that we've been trying to figure out and exploring is what we call floating branches. And the idea is that if you have some underlying, say, Wikipedia, but you have your perspective or your institution's knowledge or whatever floating on top of that, that you should be able to have sort of like an ongoing, continuous
Another term is overlay branches, yes.
What branch?
Overlay branches.
Overlay branch, yeah, I like that too, yeah.
I mean, I don't claim credit, I also heard this from someone.
Does that work with this model?
Yeah.
Cool.
That is the point.
Nice, I'll have to ask you more about that later.
Perfect, now we are over time, so we can have the next speakers. It's a good tradition. Yeah, this will be the final talk of the session, which means it's the final talk of the day, but it will be the last of the 6 half talks. So we have 2 speakers again.
Hopefully you should see a command line
ready
with
to set up?
critical errors at any time.
Can we have the beamer active this time before I try to sit down, because it never worked before?
Well, it's a Linux machine. It's not supposed to work, right? Okay, there we go. Yeah, there we go.
This looks nearly good.
Yeah, we just need to go into full screen mode. Yeah, there we go, but it's not. Okay.
I think you've nearly got it, so this stage is yours.
All right. Sorry? There's this button. Thanks. All right. Well, hello, everyone. Maybe I'll just stand here. Okay. Hello, everyone. It's good to, actually, it's good to be at the end, because we'll just do a loop back towards the beginning. There's some stuff that Brooklyn mentioned in her fantastic keynote this morning that we'd like to address, and we're here to do that. So who are we? I'm George. I'm this guy on the right. Mirko is my co-presenter. I'll give him the mic soon. We're from the programming group, and we're kind of split over the University of St. Gallen and Darmstadt. And what do we want to do? We want to make safe and correct local first applications. And how do we want to do it? Using type systems and programming languages. And our projects are 2. There's 2 directions consist, which Mirko will talk about, and then Propel, which is what I'll be talking about now. And Propel is just this verification tool that helps us in reasoning about any kind of stuff that does eventual consistency, but just essentially CRDTs, because these are the de facto ways of doing eventual consistency. And the verification tool just essentially tries to verify algebraic properties which the CRDTs care about. And these are commutativity, associativity, idempotency, and just we want to verify these properties. Propel is a DSL, but it's also a kind of a programming language. You'll see a bit towards the end. And the way it does these verification is by essentially restricting the type of functions to also annotate them with the algebraic properties that they're supposed to have. So here, for example, the very first function defines a merge function for the G counter. And the type says that it takes a list of 2 numbers and it gives out a list of numbers, but it should also be commutative, associative, and idempotent. And it does this by recursively traversing over the list and then applying pairwise maximum. So nothing very complicated there. and just for completeness, maxes all the way down with its own type. So essentially, the verification becomes part of the type checking, because if you want to have, if you want the type checker to accept this program, it also has to prove these algebraic properties. But the very cool thing about this program is that merge has this kind of traversal pattern, which is in Haskell world called like zip width. You just give it a function and it does pairwise elements on top of this list. And the very nice thing about it is that we can make it polymorphic over the properties. So if you give zip width any function that has the properties we want, then it produces a function with the properties that we also want. And so it kind of gave way into a new way of constructing correct CRDTs from ground up. Anyways, this is all kind of done, well, sort of done work. If you want to read more, go ahead and read our PLDI paper. But for those who have noticed, the properties that we check are kind of state-based CRDTs. So the novel stuff now is how do we deal with operation-based CRDTs? And well, it's all about, again, commutativity, but this is a different kind of commutativity. The propel commutativity is all the way down. And it's kind of different because, well, we quantify over 2 variables, not 1. And we talk about commutativity of arguments, not of functions. But luckily, we can encode one over the other in a way that's very nice for CRDTs because we can just quantify over the messages that the operation-based CRDTs are supposed to handle. So if you do this kind of thing, where you map messages onto functions, and then you kind of use this ad hoc function all the way down, you can make one kind of commutativity equivalent to the other. So we wanted to try it. We took an operation-based map CRDT with last writer wins semantics, which famously is hard enough to merit a tweet and a publication by Martin. And over many hours and many human labor, the bug was found. But so we said, okay, let's try to do it with Propel. So we wrote this code, which is essentially the same as the one that Martin tweeted. So I'll guide you through it line by line, not really. So it's full of comments, some standard library stuff. So this you wouldn't have to implement. The encoding of the CRDT and the actual message handlers. So it doesn't boil down to being all that much. And then 5 minutes later, after feeding it into Propel, we get this message, which means that we successfully failed to prove that it's correct. Right. So now I'll give you Mirko to talk about his project.
Yeah, thank you. Now we heard about correct CRDTs and eventual consistency, and now I want to go a bit beyond local first and start with this picture that we actually had in the talk in the morning, where we had different consistency models, and we said that well, local first applications kind of flow into the space of weak, what I call here weak consistency, which are consistency models that can have, where you can have temporary inconsistent replicas. But also, when you have an application, you might want to interact with stronger consistency models. So, right, so there's like this distinction between weak consistency, where changes are merged eventually, but sometimes you require some coordination. So for example, when a client wants to authenticate to a server, they need to coordinate. But of course, the problem with strong consistency is availability, scalability. That's why when you want to write an app that kind of requires such an authentication, you only want the authentication to be strong consistent, while the rest of the app still should be weak consistent. So what we propose is called mixed consistency, which means that a program can consist of strong parts and of weak parts. And yeah, so now, but when you have an application of strong and weak parts, you actually have to reason about how these two parts interact with one another. So when we go back to this authentication example, let's assume that you have some credentials that are replicated with weak consistency. That means that a client and a server may see different user credentials. Now, when you have an authentication method that is strong consistent, then this authentication method could see different user credentials on the client and on the server. So this can lead to problems in the application. So we actually want to find such dependencies. So now, first of all, how would you create a mixed consistent application? So for example, you can choose different middleware. So you can store weak consistent data in one database and strong consistent data in another database. You can also use middleware where you can tune the consistency on a per operation or per transaction basis. The problem with that is you can't reason about the dependencies of the values in your program. That's why we are going to a language-based approach where you can actually track what you do with the values in your program and act accordingly. Right, so what do we have? We have replicated objects as a main abstractions. So replicated objects are just some objects that are available, exist on many devices. You can define a consistency level of these objects and of methods of the object according to what you want to do. You can bundle operations and transactions, which are atomic transactions, and in these transactions we have a type system that prevents consistency violations. Yeah, so what have we seen in this talk? So we have seen some approaches to implement safe applications, one with Propel, which verify eventual consistency for CRDTs, and one with Consist, where we have saved mixed consistency in apps that go beyond local first. Yeah, and that's it with this talk, and we are ready for questions.
Immediate question here. So both of these sound really cool. I'm curious, are they, like, what state are they in? Are they both like research projects or proof of concepts or like ready to use in business logic, in production apps? And what do you see as like the path towards getting there if it's not there?
Yeah, so for my part, we have a prototype implementation, so it's not ready for industry usage or something. We are currently working a bit on a formalization and also some extensions to the language, but yeah, so it's a research project status currently.
Same goes for mine. But you can actually go on the website, there's a nice editor, and because everything is written in Scala, we compiled it to JavaScript. You can run the whole thing inside your browser, local first, and you won't upload any of your code, we won't read your code, but at the cost of running it in JavaScript, which takes like 10 times more. But yeah.
You mentioned dependencies. What kind of dependencies are you talking about? Like data?
Right, so basically data dependencies. So for example, when like I had this example with the authentication procedure, right? Where basically some data flows into this procedure that might be at a weaker consistency level that is actually needed for correct.
But you could also have operation dependencies, right? So one operation might make another operation available. There's this AMSA's paper work.
Right. So currently we are not looking at such dependencies, but only on data dependencies. But yeah, that's actually. Yeah.
So great talk. I really enjoyed the ideas. So along the lines of getting that thing more into production, and I'm not sure what currently the view on academia is on TypeScript, but I was pretty, like when I got deeper into TypeScript, and I've little bit of Haskell background, I was like pretty surprised of like how many concepts from Scala and Haskell could be applied to TypeScript as well. And I think TypeScript is more used in a production setting. So I only encourage you to, if you get good feedback for this, and if you want to make it more production ready, I think this can be, a lot of those things can be applied to the type level of TypeScript.
We'll keep that in mind.
Yeah, but maybe just also to add, so I think the techniques should also apply still to TypeScript. A little bit on the architecture. So you might have seen two languages. One where it's like the Scala DSL, but we also kind of have this intermediary language. And then if we get access to like a TypeScript compiler, then we could just compile into this intermediary language. But that's kind of another project on its own.
We are in the process of psychologically accepting TypeScript. It's in progress. We are trying to do that.
I'm glad to hear. So Guido speaks for his research group.
So,
Yep.
In the example of a transaction that may be dependent on some data that, say, hasn't arrived yet at a particular node and so can't run yet, is there an implementation of how consensus is found and like what form of strong consensus is used in the transaction, or like a technique that, or like, does the language implement a particular consensus algorithm, or how does it create transactions?
Right. So currently what we are doing is we're using distributed logs, but so we are. The middleware that we are using for the language is kind of interchangeable. So currently we also have like two implementations, one on top of Akka and one on top of Cassandra. Yeah, basically we have an interface for middlewares that you could actually plug into the language. As I said, currently we only have a prototype for that, so that would be something to do also in the future.
Any further questions from the audience? So I know this worked way too well, so you don't. Well, I could ask about all the great properties of Scala, but I guess maybe because I also really want to answer this question a little bit. I think from a research perspective, it's like the concrete languages don't matter as much as the programming model used. And TypeScript or JavaScript even and Java have pretty similar semantics in some cases. So a lot of these techniques always apply to all of these like general purpose languages, right? Whereas a different language would be something like Datalog, where this probably would be very different, right? But for the other languages, it's a matter of implementation, which probably isn't that bad even. Any further questions from the audience? Otherwise, I think we're pretty much on time.
I was just going to ask if this is the most papers resulting from a tweet that anybody in the room knows about. Because that's 2 now. Does anyone have a 3-paper tweet to their name? No? Okay, well, that's the record.
So this is yet to be published, the one based on the tweet.
Okay, well, Martin published his, so when you publish yours, that'll be the current record holder for this community.
For this particular tweet?
Yeah.
Oh.
There you go.
There might not be any after that, right?
Right, and that's saying there may not be more tweets for those on the stream. I guess they're X's now?
Yes, yes. But I think this is an encouragement to the community to tweet more problems. So this way we can cite more tweets. Yeah.
Yeah, I guess then thank you for the great talk. I have some closing words, but.
Can we have information about the dinner for the audience who didn't?
Yeah, for some information. So those of you who are registered for the PLF dinner, I hope you know if you're registered. We'll meet at 6:30, I believe. Yes. In the lobby floor or outside around that area, you'll probably find a crowd. If you can't make it, please let me or Walter know so we can maybe substitute someone else. Yeah, that's that.
with that said, I really want to thank all of the speakers again. I think we had a very hard time choosing the program. This is also why we had to combine some talks, because we just had so many great submissions from like really a big spectrum of backgrounds, which is like really what we want to achieve with this workshop. I'm really grateful that this time, like, we didn't have to invite anyone in addition like we did last time. You just came to us, and that made my life much easier. And also a big thanks to the rest of the organization committee. Like having you invite those speakers, reach out to those communities is, I think, what really enables this workshop. So I'm very grateful to, have you help me have a workshop that I can just enjoy all day, all talks. It's amazing. It's a very great pleasure to have been here. And finally, I kind of want to highlight some content things, because I think, like, the talks today, right? We've seen a lot about verification of things, about usability, right? About this longevity problem, which is kind of a hard thing, like schema changes, these things, right? We've seen how to scale to much larger systems with hierarchies, with all of these dirty solutions that like go into the depth of things. We've seen incorporating more than just eventual consistency. And I think, like, at least to me, it looks like even in the past year, the community has like explored a lot more in depth. Like a lot of the problems that were hard last year are now solved, right? And we're looking at not all of them, not all of them. Look, let me have my moment. Right? And there have been really like a lot of development in this area, and I think this is it's very exciting to be in it. As a researcher, it's also scary because I want to publish papers, right? And always get left behind. But it's a fun community to be in. So thank you all very much for being here and participating in this workshop. Thank you. That's it, folks.